Hello, my dear students. Welcome to BYJU'S exam prep. So the time has come to have a discussion of our mega marathon series of industrial engineering. So I would like to ask you whether my audio and video is all good. Please write in the comment section, guys. Good morning. Good morning. Ajay, Raghu, Bhaumik, Sharma ji. Mishra is on fire. Actually, it was densely fog, so that is why we had a slight delay in the session. It was total foggy today. So we had a delay by 17 minutes, I think. Good morning, Manas, Mithun, very good morning. Okay, so energetic guys, how your marathon sessions going on? All enjoying? I heard yesterday you had a 12 hours marathon of fluid mechanics. I hope so you all enjoyed that. So let's repeat that same. And today we'll be covering entire industrial engineering in this session. I'm good. I'm perfect as always. Energetic and super. All sessions are super, sir. Okay. So let's wait for a while so that many of the students can join. Full josh hai kya? Arey, bahut badhiya yaar, bahut badhiya, very good. We are having full josh. So please write in the comment section, please, whether audio and video is all good. And yeah, please do share this video to all your friends so that every students will be joining this super marathon session. And I will say that we won't be having part 2 of industrial engineering. We will be completing in this particular single video. Okay. Chahe 12 घंटे लग जाए यार, but no worries. But we'll be today completing our industrial engineering subject, and we will be able to answer all the questions. So those who are not having a good command over industrial engineering, just do watch this video, and you will be having a complete. We can say, yes, all good. Both audio and video is all good. Okay, perfect. So shall we begin? Okay. So in this particular session, we will be covering almost every topic. Okay, we'll be starting from PERT and CPM. Then we're moving with inventory, break-even analysis, linear programming. Every single topic will be covered. Okay. So, okay. Will the practice session will be there? We'll be trying to cover. If not, what we can do is tomorrow we are having a mock test. Okay. We are having a complete mock test. We'll be covering our question session in that only. Have some small doubts in I said, oh, definitely, yeah, definitely. It will be clarified today, right? So let's start our session of industrial engineering, and I hope so everything is good and perfect. Let me drink a glass of water before starting. Telegram channel, yeah, please do share this video to our every Telegram channel that we are having. Okay, fine. Fine. Okay. Good morning, everyone. Very good morning. Good morning. Chaliye. So let's begin our session on industrial engineering. So let's start our discussion. I hope so. This is my Telegram channel. So those who are not yet joined, please do join. And here ek kaam kar dijiye. Please do share this video to this particular channel. Okay. I'm not having a mobile phone right now. It's in my bag. So what you can do is you can do share this video to this channel. And also, as you know that, yeah, we are having a mega workshop by Abhinav sir on 15 January on 12:30 p.m. Yes. At 12:30, we are having a 15 January ko mega workshop, 7 successful mantras to clarify GATE 2024. Chalo, let's begin. Okay. And 90% scholarship test on 8th January. I think that's already passed. I think so. Chaliye. So let's begin. Good morning. Very good morning, all of you. So let's begin with our very interesting topic, that is PERT and CPM. Now, why I've started with PERT and CPM is because this is a topic which actually carries a good number of weightage. Almost every alternate year or every year they are asking questions from this PERT and CPM. Okay. Right. So let's begin our discussion on this topic of PERT and CPM. So if I write PERT and CPM analysis, we'll be having a quick brief discussion, then we'll be taking problems. What I can do is we will be taking questions in between, like after every topic, we'll be taking some sample questions so that in industrial engineering, if you're not solving question, your industrial is not completed. Okay, that is the most important part. So if I talk about PERT analysis, now what is the major difference between PERT and CPM? Where we're using this PERT and CPM analysis? Anyone who can tell me in the comment section? Where we're using this PERT and CPM? PERT analysis and CPM analysis both are basically used for scheduling or planning of any construction or any we can say different activities. We are having a collection of different activities, and group of that activities or combination of that activities forms a project. Okay, so if you are having a project with me, and in order to plan that project, we are using some tools like PERT and CPM. Before that, we were using Gantt chart. Okay, fine. Before that, we were using Gantt chart. But in Gantt chart, there was one problem that whenever we are having parallel activities, you won't be able to track down the, you won't be able to have a proper planning in that. So that is the reason we switched to PERT CPM in order to have a better clarity. Very good. So if I say PERT analysis, it is a probabilistic approach. Right, it is a probabilistic approach, and if I talk about CPM, it is a deterministic approach. Now, what is the meaning of this? What is the meaning of this particular difference? If I say a probabilistic approach, that basically means I'm not having a clarity when this activity will be completed. That is the reason in PERT analysis we are having 3 time estimates. 3 time estimates, right? Because I'm not sure whether the activity will be completed in a single go. Sometimes it will be taking 10 minutes, sometimes it will be taking 5 minutes, and sometimes it will be taking 25 minutes. Okay, so based on that, what we can do is we can divide the activity completion time on the basis of the probability on 3 basic classification. One is optimistic time. Optimistic time. Second is pessimistic time. And third is most likely time. Okay, which we are denoting it as TO, TP, and TM. Okay, can you tell me the difference between these 3? Okay, perfect. Now, let us take one example. Let us take a very important example. Let us suppose we are having 100 topics in gate examination. In mechanical gate, there is 100 topics, and you have studied only 15 topics. And question is being framed from that 15 topics. What is the probability of that? Anyone? You have studied out of 100, 15 topics, and the question is being framed from that 15 topics only. So what is the probability of getting that particular situation in gate examination? Sir, Hindi mein bhi mix karenge. 100% probability. Okay. Yes. Tell me. Sharma ji is saying, sir, 1%. I would rather say less than 1%. I will be saying that it will be less than 1%, right? Okay, fine. It is not, we cannot have a particular probability that you're studying 15 topics out of 100, and in examination, the only question is being asked from those 15 topics. Not possible. Say on the other hand, there are 100 topics, you have studied 95 topics, and 5 topics you are left out. And in examination, the question is being framed from that 5 topics. What's the probability? Definitely very, very low. So let us try to have that particular understanding in this particular situation. That is, if I say the optimistic time, the pessimistic time, and the most likely time. So what is optimistic? Optimistic basically means it is that particular time duration when everything is in your favor. Hana? When everything is in favor. Let us suppose you are studying 10 topics, and question is being asked from that 10 topics only. 100% marks in the gate examination. Probability थोड़ी सी less होगी, but definitely that's an optimistic approach. Okay. If I talk about pessimistic, pessimistic means you are studying 95 topics, 5 topics is being left out, but question is being framed from that 5 topics. Definitely उसकी probability बहुत कम है. That is a pessimistic approach. And most likely means the activity completion under normal working conditions. Okay. So it is being seen that this is all I'm talking about for an activity. This is all I'm talking about for an activity. Okay, I'm not talking about any project. Okay, I'm talking about an activity. So an activity has 3 time completion. One is the optimistic, pessimistic, and most likely. And it is being seen that it follows a beta distribution curve. It follows a beta distribution curve, right? That means we will be having a curve something like this. Something like this. That means if I say this is your this is your optimistic time, this is your approximately the pessimistic time. In between, you will be having a probability of the most likely time, because this is a normal working condition. So under most likely time, the probability of that occurrence will be very high. For optimistic and pessimistic, the probability of occurrence of that particular thing is very, very low. Okay, fine. Is this clear? And it is being seen that it follows a beta distribution. And for beta distribution, we know from our mathematical expression that, yeah, this one, we can say the expected time of completion for an activity is equal to the summation of optimistic plus 4 times of most likely plus pessimistic divided by 6. Okay. For all individual activity, we will be having 3 time estimates in PERT analysis, right? So one is optimistic, second is pessimistic, third is most likely. What is optimistic? Optimistic will be everything is in our favor. Whatever we are, whatever condition is having, all the condition is in favor. Pessimistic means whatever condition is there, everything is in the against our that. That means if I want to do welding, I'm having the worst welder in the world with me. I'm having the worst welding machine with me. I'm having the high voltage fluctuations, right? So definitely that will be the worst condition. If I talk about optimistic, I'm having the best welder with me. I'm having no voltage fluctuation. I'm having the best welding machine with me. That is optimistic. In most likely, we can say we are having welding is completed under normal working condition. There might be some fluctuation of voltage. There might be some problems in the welding machine. Okay, so definitely this is the probability of activity to be completed under most likely will be very, very high, and that is we are seeing in our this particular graph. Okay, is this clear? This particular graph, right? Yes, understood. So now I have understood that for every activity in PERT analysis, we are having 3 time estimates. So we can calculate the expected completion time by using this formulation because it follows a beta distribution. Okay, yes, perfect. Now, as I'm saying that we are having most like, and can you tell me which will be having the highest magnitude among all these three? Among all these 3 time, yeah, optimistic, pessimistic, and most likely, which will be having the highest magnitude? Tell me the comment section. Tell me the comment section. Perfect. Obviously, sir, pessimistic. Why? Because nothing is in our favor. If I want to complete welding, it will be taking the largest time, right? So we can say the pessimistic time, highest magnitude, most likely, then we are having the optimistic time. Okay, fine. And this is for every individual activity. Now, you might have heard about a very interesting term. We call it as standard deviation, which we are denoting it as like this. Okay. What is standard deviation? Standard deviation basically means the deviation happening from its mean value. Okay, the deviation that is happening from its mean value. So we can simply say that for an activity, the standard deviation is equal to the pessimistic time minus the optimistic time divided by 6. And this is I'm talking about for an activity only. For an activity only, right? I've not switched to the project. This is only about activity. Okay, so why we are calculating standard deviation? Can anyone tell me why we are calculating standard deviation? Because you might have heard about a very interesting term, that is we call it as variance. Yes, that is we call it as variance. Anyone? What is a variance? Arey bolo bhaiya. Yes, what is meaning of this word variance? Let me check. It's a missed call that is being rakha hua hai. Yes. I think everything is good. Yeah. Share this video to Telegram channel. Okay. Perfect. Yes, anyone? What is the meaning of this word variance? Variance is, sir, square of the standard deviation. We know that. But what is the meaning of that? Before having that formula, if you are having the meaning, Okay, exactly. Very good, Manas and Shashank. Variance basically means it tells us about what is the uncertainty. What is the uncertainty in the occurrence? In the occurrence of an activity. That means, or completion of an activity. That means if you're having, let us take an example. Let us suppose I'm having an activity whose pessimistic time is, let us say 8, optimistic time is 2, and most likely time is, let us suppose 4. This is one set of activity. Second set of activity is your pessimistic time is 100, your optimistic time is 5, and most likely time is, let's say 40. Okay, so in this case, can you tell me, do we have high fluctuation? Because sometimes the activity completion will be 90 minutes, sometimes it will be 6 minutes. So the range that is being seen, it's very high. In this case, the range is very low. If you try to see, our completion time will vary between 8 to 2 only, because this is the maximum, this is the minimum. Here, the activity will be ranging between 100 to 5. So here we are having a high uncertainty. In that we call it as variance. And what is variance? That is the square of the standard deviation. That is equal to TP minus TO by 6 ka whole square. Okay, fine. Right. So let us do one thing. Let us take one example and let us try to apply whatever we have studied right now. Okay. Let us apply this concept to whatever we have studied and try to calculate the critical path. Now, what is critical path? Critical path is the longest time consuming path in an in the complete project. Okay, or along the path, what is the longest time taking path? That we call it from the first event to the last event. That is called as critical path. Or can we say this is the minimum time to complete the project? Is that statement correct? One is, it is the maximum time consuming path. Second statement is, it is a minimum time to complete the project. So is both the statement correct? Absolutely yes, sir. It is actually correct, because if I say, let us suppose I'm having a pathway right like this, 1, 2, 3, something like this. Okay, let us suppose this is 2 minutes, this is 3 minutes, this is 7 minutes. So can you tell me what would be the critical part? Anyone? Those who know the concept of critical path, if I start from 0, 0 to 2, 2 to 3 is 5, 0 to 7, 7. So we're having this as a critical path, which we are denoting by double arrows. Okay, so it is the longest time taking path. So this is the expected completion time. Expected completion time of project. Okay, is this clear? This is the expected time completion. So this is your critical activity. Now you will be saying, sir, how we can say this is the minimum time of completion? Let us suppose if I'm taking this as 5, that is 2 plus 3, 5. So in 5 minutes, can I complete all the activities present in this particular project? If I take 5 minutes, can I say in 5 minutes all the activities will be completed? No. In 5 minutes, only activity 1, 2 and 2, 3 will be completed, but 1, 3 won't be completed. Is this clear? So that is the reason we can say critical path is the maximum time consuming path from first event to the last event, or we can say it is the minimum time to complete a project. Minimum time to complete a project. Clear? Minimum time to complete a project. Is this clear? Okay, so now we can calculate from the critical path analysis the expected time to complete a project, or the minimum time to complete the project, that will be 7 days. Okay, now in PERT analysis, as every activity is having some range of completion, so definitely using the PERT analysis, what we are actually calculating is the probability of completing a project. That is we are calculating. Earlier we were talking about only about activity, like we are having pessimistic time, optimistic time and most likely time, and small t as the expected completion time of our activity, right? Okay, that we have seen TO plus 4TM plus TP by 6. And if I try to draw that particular graph once again over here, okay, beta distribution curve, something like this. So this is your small tm, this is your small tp, and this is your small to. And it is being seen that your expected time of completion always lies closer to the most likely. Okay, the expected, the most likely time always lies closer to the expected completion time of an activity. Is this clear? So let us take one example so that we can have a proper understanding what is basically happening to this particular situation. Okay, so let us say what is an example that we are having. Yeah, this one. So we are having a combination of different activities. We're having optimistic time, most likely, and pessimistic time. So if I want to draw the critical path, if I want to draw the network diagram, I need to have a single time estimate. So in order to calculate single time estimate, what I can do is, you can use the formulation of TE is equal to TO plus 4 times TM plus TP divided by 6. So quickly, can you tell me what are the different time? Calculate and tell me what will be the different time. Comment section may start with activity 1, 2. So have a quick calculation. Can expected time lie in right side of the most likely? Not possible. It is actually not possible. The reason being, if you try to see the graph also, we are having a larger slope on the left hand side and the lower slope on the right hand side. Okay, so that is the reason the expected time usually either it will be on most likely or slightly less than that of expected. Okay, is this clear? Fine, chalo. So let's have a quick discussion of this particular problem, because without solving the question, okay, 1, 2 is 2. Perfect. 7 plus 1. What you have to do is, in examination, try to see, you have to do it like this only. Multiply 4 to most likely, add these two and add this. So 4 plus 8 is 12. 12 by 6 is 2. 16 plus 8, 24. 24 by 6 is 4. 8 plus 10, 18. 18 by 6 is 3. 4 plus 2, 6. 6 by 6 is 1. This one will be 20 plus 16. That will be 20 plus 16. That will be around 36. 36 divided by 6 is 6. Okay. Here, if you see, we are getting slightly higher than that of most likely. Okay. So I hope so now that is being clarified. It's very rare chance, but yes, we are getting. And why we are getting? Because the pessimistic time is having a larger value. Okay. Pessimistic time is having a larger value as compared to the optimistic. Right? Chalo. 20 plus 10, 30. 30 divided by 6 is 5. Here also I think you will be getting a larger value. 18 plus 24. That will be what? Last value. It will be, I think, 7. 42. 42 divided by 6, 7. Okay, so we have completed and we have calculated the expected completion time only for activity. So what we can do, now let us draw the network diagram. 1, 2, 1, 3, 1, 4. Let me rub this off. Let us draw it over here only. 1, 2, 1, 3, 1, 4. This is activity 1, 2, 2, 1, 2, 3, and 1, 2, 4. Okay, 2, 5, 3, 5. 2, 5, 3, 5, 4, 6, and 5, 6. Something like this. Can you tell me what is the critical path and what is the expected time of completion? Quickly. AC को बढ़ाया जाए. I think माहौल गर्म हो चुका है ना? Yes. What is the expected completion time? 19. Very good. Okay. This is 2. This is 4. This is 3. 2, 5 is 1. 3, 5 is 6. 4, 6 is 5. And this is 7. So let us draw the critical path. So 0, 2, 3, 4, 10, 3, 5, 8, 17. Are we getting 17? Is everyone getting 17 or any other value? 10 plus 7. Yes. Quickly, are we getting 17 or 19? Murli is getting 19 and we are getting 17, I think. 17? Yes, perfect. So I think we are getting 17. So capital TE is 17 days. Let us take it in days only. Okay. 17 days is my minimum time to complete the project. Right? And what's the critical path? Critical path will be 1, 3, 3, 5 and 5, 6. The critical path will be 1, 3, 3, 5 and 5, 6 is our critical path. And critical path is basically being shown by double arrows. Perfect. Very good. Very good. All of you. Now, I have calculated 17 days is the expected time of completion for this particular project or minimum time to complete the project. Okay. But let us suppose if I want to calculate what is the probability if I'm completing this project in 20 days, right? For that, you should be having a basic concept clarity of the project, right? Because it is being seen that as activity follows a beta distribution that we have already been seen, right? But in case of project normally follows a normal distribution curve. Sir, what is this normal distribution curve? Let's try to have a look. If I say normal distribution, it will be something like this. Center, symmetric. Let's say this is your expected completion time of the project. Now I'm talking about from project perspective. Activity discussion is over. Let us suppose what is the probability that our project will be completed in this particular schedule time. Okay, TS resembles or TS means schedule time. So definitely here I will be discussing about the standard normal variate. Standard normal variate is denoted as capital Z. Standard normal variate, right? Which we are denoting as capital Z. And how we can calculate? Z is equal to TS minus TE by the standard deviation of the project. Okay. So we can calculate the standard normal variate by using this formulation of schedule time. Now TE we can calculate by using the critical path analysis. TS normally they are giving in the question. The challenge is how to calculate this project. First of all, try to understand what is the meaning of this particular relation. Let us suppose if I try to write this expression like this, TS is equal to TE plus standard deviation of the project into Z. Can I write it like this? That means if I add some portion, right, this addition will be standard deviation into standard normal variate, right? So in particular standard normal variate, what is happening is we try to calculate the area under this particular curve. Okay, fine. So if I say, let us suppose Z is equal to 1. If I take Z is equal to 1, our curve will be something like this. This is TE, this is equal to sigma, and this is TS. And the area under this curve will be this one, which is greater than 50%. So I can say the probability of Z is equal to 1 is equal to 50%. That means if I am calculating the value of Z from this expression, and if Z is coming out to be 1, that simply means that our project completion time or the probability of completing the project will be 50% only. Let us suppose if I take Z is equal to 0. If I take Z equal to 0, Z equal to 0 means TS equal to TE. This is TS. This is TE. That means what is the area? What is the area? This is nothing but, this is Z equal to 1 now. This is more than 50%. 84%. Somewhere around 84%, right? This is 50%, right? So this is your having an area of 50%. So probability of Z is equal to 0 is equal to 50%. Okay, that was 84%, right? 84. It's not 50, it's 84. Okay, fine. So now, if I'm able to calculate the value of Z, I'll be able to calculate the probability of completing this project in some scheduled time. So how to remember these values? Because we are having infinite values, something like this. We'll be having values like this. Z equal to 0. We are having 50%. Z is equal to 0.4, 65%. Z equal to 0.21, something like this. It's not possible to remember all these values. Okay, fine. So what we can do is we can remember some standard values which is required for the examination. Okay, so what are the standard values? When Z is equal to 0, right, the probability of Z is equal to 0 is equal to 50%. When you are saying Z is equal to, when you are saying Z is equal to 1, the probability of Z is equal to 1 is somewhere around 83.6. We can take it as 84%. If I take Z is equal to 2, more area will be covered. Probability of Z is equal to 2, definitely more than this, near about to 98%. Right? Okay. But let us suppose, if I say I'm having Z is equal to -1, that means TS is equal to TE plus Z into sigma. This was the formulation. That means we'll be having less than that of TE. So if I try to draw the normal distribution curve, this is your expected completion time. So if I put Z is equal to -1, this will be TS is equal to TE minus of standard deviation. That means it will be somewhere around here. Okay. So what is the area completion? This is the area covered. So if I say probability of Z is equal to -1, as the best part of normal distribution curve is, it is always symmetrical from the central axis. So if I take this as Z is equal to 1, this will be Z equal to -1. That means this is equal to 1 minus probability of Z is equal to 1. This is 1 minus 0.84, that is 16%. So now we can have more set of values in this particular situation, that is your probability of when Z is equal to -1, probability of Z is equal to -1 will be approximately 16%. Probability of Z is equal to -2 will be equal to approximately 2%. So this way you can calculate what is the probability of completing the activity by just calculating the value of Z. So let us have a discussion, but the problem here lies is how to calculate the standard deviation of the project. This I know, this I can calculate. How to calculate the standard deviation of the project? It is being seen that the standard deviation of the project is nothing but root of summation of variance of only the critical path activities. That's it. How to possible to finish the project in less than a minute? It is possible. Try to increase the number of resources. If initially there was only one person, you can increase the resources, right? Fine, but it is very having less possibility. You can see when Z was equal to -1, the probability of completing the project is only 16%. Let us suppose if Z is equal to -2, the probability of completing the project is only 2%. Definitely that will be very, very less, right? How this is possible? Because we are having a range of completion of the activity. An activity can be completed, if you try to see this particular table, in this particular, let us say I am taking activity 1-2. Activity 1-2 can be completed in 1 minute also, can be completed in 7 minutes also. I am taking on an average value of 2 minutes. Let us take activity 3-5. Activity 3-5 we can complete in 2 minutes also, we can complete in 14 minutes also, we can complete, and on an average I am taking 6 minutes. So definitely if I take all this possibility, we can have a completion in less than 17 days. Yes or no? Understood? I'm not talking about crashing. Crashing is only applicable in your CPM analysis, not in PERT analysis. Okay, fine, right? I'm only taking the average, average expected completion time, right? Activity 3-5, let us suppose everything is going in our favor. I can take completion time as 2 also, right? So if I do so, definitely your completion time of the project will be changing. Okay, fine. So coming back to this, how to calculate the standard deviation. Okay, this is our major challenge. So standard deviation of the project is nothing but you just need to add the variance along the critical path. So if I take this question one more time, here we have already calculated the critical path, that is 1, 3, 3, 5, 5, 6. So I need to calculate the variance of only these activities, that is 1, 3, 3, 5 and 5, 6. That's it. So how to calculate variance? By calculate the standard deviation of an activity. How to calculate standard deviation of an activity? We can calculate standard deviation of an activity is equal to TP minus TO divided by 6. If you try to square it, that will be the variance. So let us try to calculate 7 minus 1 divided by 6. That will be equal to 1. Okay. This one. 14 minus 2 divided by 6. 12 by 6 is 2. And this one is 15 minus 3 divided by 6 is again 2. So we have seen that along the critical path, the variance is coming out to be, what will be the variance along the critical path? That will be equal to 1 square plus 2 square plus 2 square. Right? So this will be, I think, 9, let's say, days square. The variance is having a unit of square of the time. So if I want to calculate now the standard deviation of the project, that is coming out to be root of summation of variance along the critical path, and that is coming out to be root of 9, that is 3 days. So by this way, I'm able to calculate the standard deviation of the project, right? Okay, perfect. So now how to calculate the Z value? Z is equal to TS minus TE by standard deviation. TE we have already calculated by using this critical path analysis, that is 17 days. TE is already being calculated as 17. Sigma you have calculated as 3. Let us suppose if I want to calculate what is the probability of completing this project in 20 days. Can you tell me? What is the probability of completing this activity in 20 days? Can anyone tell me in the comment section? What is the probability of completing this project in 20 days? Anyone? So TS we know, right? TS we know. Calculate the value of Z. So Z is equal to 20 minus 17 by 3. That is 1. And what's the probability? Somewhere around 84. No, not 50. Try to recall. 84. More than 50% area is covered. Z equal to 0. TS equal to T. Only 50%. Right? So we can say over here is the probability of Z equal to 1 is 84%. That means if you want to complete this project in 20 days, the probability of completing this project will be only 84 days. 84.6 exact value Shashank is saying. Absolutely correct. Okay, fine. So this way you are calculating, you are using the your PERT analysis for the calculation of the project completion, or we can say probability of completing the project in some stimulated time. Why not add 1 plus 2 plus 2? It is not standard deviation. Check. It is, what is this one? It is this project value is nothing but the summation of the variance. What is variance? Variance is the square of the standard deviation. Yes. Right. Is this clear? You have to square the standard deviation. We are calculating the value of the standard deviation only. You have to square that. So 1 square plus 2 square plus 2 square, that is 9. This is your variance. Take the root of that. That will be coming out to be 3. Okay. Take the root of that. That will be coming out to be 3. Done? Yes? Understood? Everyone, please write in the comment section. Yeah. PERT analysis done. Yes, definitely I can take a black color. Is that red color not visible? Okay, done. Okay, so now this is your complete discussion about the PERT analysis. Okay, this is the complete discussion about the PERT analysis. Let us now go with the CPM. Very interesting. The summation of the standard activity is not the standard activity. Summation of the standard activity is, no, it's not. We have to just, we are not adding this this one. We are not adding the standard deviation. We are adding the summation of the critical variance, right? We are just adding the variance. What is variance? Variance will be equal to 1 square plus 2 square plus 2 square. Take the root of that. That will be the standard deviation. Okay. Fine. For project, we are only taking the critical path, right? And we are calculating the variance of the critical path and taking the root of that. That will be your standard deviation of the project. Okay. Clear? This is all about your PERT analysis. So let's quickly move on to CPM. Is this clear, Sharma ji? Yes. Okay. So now let's proceed with the critical path method. We call it as CPM. Critical path method, that we call it as CPM. Now in critical path method, exactly, we are calculating for the overall project, right? And for project, we are only taking the critical path only. Now in CPM, we are having only one time estimate. That means for completing an activity, we are having only one time estimate. Okay, so if it is a single time estimate, that simply means that now I'll be getting exact completion time. For completing a project, I'll be getting an exact, let us suppose by using the CPM analysis, we have seen that activity will be completed in, let's say 30 days. But if I want to complete this activity in 20 days, what do I need to do? Because this is a single time estimate. You cannot have a range of time of completion for the activity. Now the activity is having only one time. That means you are talking about a deterministic approach. So the problem here lies is if the project is being completed in 30 days, how we can complete the project in 20 days? By having a very interesting concept of crashing, right? So in critical path method, actually what we are doing the cost analysis. In critical path method, we are basically doing the cost analysis. In PERT analysis, we are not doing cost analysis. We are not doing, because there I don't know what is the exact completion time of the project. We are having a probabilistic approach there. Let us say I'm working in an R&D sector. In R&D sector, my first objective will be I need to complete this project. That's it. Let us suppose a project is going on, let's say in construction, right? There's a project has already been done, let's say 60% project is being done and 40% is left out, and I know this project will be completed in next 1 month. I need to crash down the activity and need to complete in 15 days. There I'll be using the concept of critical path method. Okay, there I'll be using the concept of critical path method. Okay, perfect. So now we have seen that critical path method, which is basically the cost analysis. So for understanding critical path method, there are two things that you need to understand. One is forward path computation, and second is the backward path computation. Now, what is this meaning of forward pass and backward pass computation? Let us take one example. Let us suppose I'm having an activity like this. 2, 3. Okay, let's say this is 2, 6, and this is let's say 7. Right. So quickly tell me what will be the critical path, just by having a basic understanding that we have already used. So what we do, we try to go in the forward direction from left to right, and we try to identify the longest time taking path. That is basically we are saying 2 plus 6, 8, 1, 2, 3 is the critical path. Okay. But let us suppose that is the forward path that we are doing is 0 plus 2, 2 plus 6 is 8. So if you try to go from 1, 2 and 3, I'm getting 8 as a completion time. If I go from 1, 2, 3, I'm getting 7, right? So I always take the maximum value in the forward. So in forward path computation, what we do is, if I say this is activity I, this is activity, this we call it as event. Okay, let's say this is EI, this is EJ, this is LI, this is LJ. So EI is basically meaning we say early start time, EJ is latest start time, EJ is early finish time, LJ is latest finish time. What is the meaning of this word EST, LST? If I say activity, let's say this is activity A, this is B, this is C. Okay, activity A can be started by 0 minutes, right? It will complete it in 2 minutes. Okay, fine. But let us suppose if I say activity 7 or activity C, if I go with the backward pass computation. So backward pass, or let me do one thing. Let me take one more activity so that you're having more clarity. Let's take one more activity, add one more activity over here. Let's say this is 4 and this is like this. Okay, so we are having A, B, C and D. Let's say this is 2, this is 5, 7, this is 3. Okay, 7. Tell me, what will be the critical path? Anyone? What will be the critical path in this case? If you are seeing on the screen, what will the critical path? If you try to visualize, 0 plus 2, 2 plus 7 is 2 plus 5 is 7, 7 plus 3 is 10. So in the forward pass computation, what we have to do is we have to take the maximum time. So maximum time is 10. So this is my final. Okay, in the backward pass, what we do, we start from 10 and we go in the reverse direction. So in the reverse direction, what we do, we try to take the minimum of all. Okay, so if we try to move from 4 to 3, 10 minus 3 is 7. Okay, 10 minus 5 is 5. 7 minus 7 is 0. 5 minus 2 is 3. So in the backward direction, we take the minimum of all. Right? Fine. So I can say Li is equal to Lj minus Tij, and you have to take the minimum of all. Okay, if I talk about Ej is nothing but Ei plus Tij. You have to take the maximum of all, and this is we call it as the forward pass, and this is your backward pass. That means if I try to visualize activity B, I can start activity B after 2 days. Okay, if I'm starting this activity after 2 days, it will be completed in 7 days. Okay, no problem. But if I'm starting this activity at 5 days, I can complete in 10 days, still not problem, because this is the maximum time up to which I can extend my project. So I can say as activity B is not the critical activity, so I can alter any value. If I say, if I'm increasing by plus 2, that means 5 plus 2 is 7. So 2 plus 7 is still 9. So is activity B, if I'm increasing the time duration from 5 to 2, is that changing my project completion time? Yes. If I'm changing the completion time of activity B from 5 to 7, is that changing my critical path? No, right? Because still your activity project completion time is 10 days. Because if I say 2 plus 7 is still 9. You're having some sort of buffer still left out, right? So this this particular concept, we call it as float. This particular concept, we call it as float. Okay, fine. We'll be discussing this float after 10-15 minutes. But before that, we have to have a complete analysis that what is the cost analysis. Okay, what is the cost analysis? Now, in cost analysis, what we are doing is, there's a very interesting term, we call it as crashing. There's a very interesting term, we call it as crashing. What is crashing? Let us take one example. There was an activity A, and this activity A takes, let's say, 10 days to complete, and there are 2 persons and 1 machine they are using. If 2 person, 1 machine are working together, right, they are completing the activity A in 10 days. But let us suppose if I want to complete this activity A in 8 days, or let's say 6 days. Okay, if I want to complete this activity A in 6 days, can I complete by using this 2% and one machine? Can I complete this completion of activity A, right, in 6 days by using the 2% and one machine? Not possible. What you have to do, you have to have some more persons being added, right, and some machines you need to add. Okay, fine. So by doing so, you are now crashing this activity A from 10 to 6 days, and this process we call it as crashing. That means by increasing the resources, you are increasing the cost of that particular project completion, and by doing so, you are now completing the activity instead of 10 days, you are completing in 6 days, and this process we call it as crashing. This process we call it as crashing. Is this clear? So let us try to understand how, by looking at this particular example, sir, cost will always increase. How we can say there might be some optimization of the cost? By looking at this particular example, let's say by doing this particular exercise, it is costing me rupees, let's say 500. It is costing me rupees additional 500 to complete this activity instead of 10 to 6 days. Right? So by doing so, sir, cost has been increased. How we can say cost might be decreased? Here, we need to understand two very important concepts. That is, one is your direct cost, and second is indirect cost. Here you need to have a clarity of this particular concept of direct and indirect cost. What is direct cost and what is indirect cost? Direct cost is basically, this is that particular cost which is directly involved in the completion of an activity, like your machine, this one. Let's say the salary of these persons, the machine rent. Okay, so whatever resources that we are using in by increasing that cost, right, you are completing the activity in lesser time. So definitely, if you try to have the crashing, the direct cost will always increase. Okay, after crashing, the direct cost will always increase, because once you are crashing any activity, earlier there were only 2 persons. I have to give the salary for only 2 persons. There was only one machine. I have to give the rent for only one machine. Now there are 3 machines. I have to give the rent for 3 machines. 6 persons working. I have to give some additional salary. So definitely here, if you try to increase the direct cost, the activity completion time will be directly influenced. So that kind of cost, we call it as direct cost. Okay, fine. That kind of cost, we call it as direct cost. It is a cost which is directly involved in the completion of an activity, which basically involves your direct material, direct labor, cost of machine, equipment, etc. Okay, fine. But the problem here lies is how you can say an optimization. Let us take an example of indirect cost. What is an indirect cost? You might have heard about a very interesting concept about daily allowance. Yes? Let us suppose if you are going to write any examination, some of the PSUs are giving you TA and DA. One is travel allowance and second is the daily allowance. Have you heard about this? A concept of DA? Right, when not all PSUs, some PSUs, when they are conducting their own examination, they are giving T and DA. Okay, students will be happy. You can claim 3 AC train ka rent, है ना, and daily allowance. Right, fine. I hope so. Gate भी ऐसे करता, it could have been a very good situation. Okay, chalo. Coming back to our concept. So if you are giving a daily allowance of rupees, let us suppose 200 rupees. Okay, let us suppose any examination is giving a daily allowance per day. Cost is 200 rupees. In that you can have your lunch also, anything, whatever you like. Okay. So now if I try to give 200 rupees per day, right? Fine. So in this particular example, it was costing me rupees 500 from moving from 10 to 6 days. Additionally, I have to give 200 rupees per day basis as a daily allowance. So now I'm completing the activity instead of 10 days as 6 days. So can you tell me how much daily allowance I have saved? Per day 200 rupees I have saved. Now crashing by 4 days. So 800 rupees I have saved. Yes. Yes. if you try to visualize, if per day 200 rupees is the daily allowance which the company is giving to me, the company is now trying to have a very smart analysis. They are trying to say, let us complete this activity instead of 10 days in 6 days. So that means they are saving 800 rupees. You need to give additional 500 rupees. You are saving 800 rupees. Still we are having a profit of how much? Still we are having a profit of how much? 300 rupees. Is this clear? So that is the best part. That is the best part. Sir, by crashing the activity, the total cost, instead of increasing, it is being decreased. It's directly being seen. And we are having a cost cutting of rupees 300. And this is your optimization. That means while after the crashing, your direct cost will increase, the indirect cost will decrease. So we have to have a balance between these two. And this is, we call it as the crashing. This is, we call it as crashing. Is this clear? This is, we call it as crashing, that when you are balancing between the direct and indirect cost. Right? Understood? So now we can see that indirect cost after crashing, it will try to decrease. So if I say the total cost, which is the summation of direct cost and indirect cost, will try to have a decrease. So I need to find out an optimum value. I need to find an optimum value where the cost has been decreased, right? And your project duration as time has been decreased. How indirect decrease? Okay. Look. Let us take one example. Every day, I'm giving you a daily, I'm not giving, company is giving, okay? Per day, I'll be giving you more than this, yaar, no problem. 200 rupees nahi. I'll be giving you 100,000 rupees, okay? Get a very good rank, more than that will be, I'll be giving. Okay, we'll be doing party for that. Chalo, 200 rupees per day, this is your indirect cost. Activity was completed in 10 days. So total indirect cost will be, what will the total indirect cost? 2,000 rupees. Yes. Now the total indirect cost is 2,000 rupees. Yes or no? The students, those who are not understood, right? And we are having a direct cost, let's say rupees 1,500. Rupees 1,500, right? For completing this activity in 10 days. But what I've seen that, okay, let us do one thing. When I am trying to complete this in, let's say 6 days, it will be costing additional 500 rupees. That means the total direct cost will be now 2,000, or let's say this is 600, so that you are having a difference in the value. Okay, so now the total direct cost will be 1,500 plus 1,600, that is 2,100. Yes. So now when you are completing this activity instead of 10 days to 6 days, the total direct cost is 2,100. But if I talk about the indirect cost, what is indirect cost? Now you are completing this activity in 6 days. So what is the total indirect cost? 6 into 200, that is 1,200. Yes. So initially, what was the cost before crashing? Before crashing, it was 2,000 plus 1,500, that was 3,500 rupees. Total cost after crashing, it is coming out to be 2,100 plus 1,200, that is coming out to be 3,300. So I have saved 200 rupees. I have saved 200 rupees. Yes. और वो कैसे हुआ? देखो, 4 days crashed, per day saving 800 is per day saving, right? Additional cost is 600. So total saving will be 200. Understood? Yes. Okay. बहुत बढ़िया. Yes. So this is the concept of crashing that we have to do, and this is your cost analysis, and this is the fundamental of critical path method. Okay. Is this clear? बहुत बढ़िया, right? So yeah, please do like this session, right? Please do like this session, all of you. And I want gradually, because this is a long marathon session. It's just being started, yaar. Mahol garam ho raha hai. Okay. So now let's talk about how we can calculate, how we can do the analysis. This is very easy to understand. You are taking only one activity, but we are having a combination of different activities. What we have to do? We have taken only one activity, sir. Very easy to do the analysis. But in examination, sir, it is not about one activity. We are having combination of different activities. Then what we have to do? चलिए वो भी करते हैं, है ना? Okay. So now what we have seen that as direct cost will be changing, will be increasing while after the crashing, right? That we have seen directly. So let us suppose if I say, if I take a graph, okay, let's say I'm taking Tn as the normal time of completion and Tc as the crash time. Like in previous example, it was 10 days and 6 days. Okay. And Cn is the normal cost. That was 1500 in our previous example. And Cc is the crash cost. Right? Cc is the crash cost. Arey shant ho jao bhai. Let me keep in a silent mode. Do not D&D mode. Okay. Now, if I take the normal cost will be definitely having a lower value. And let's say this is Tn as a normal. So let's say this is the point. This is that point where we are completing normal cost and normal time. Can you tell me normal time and crash time which will be having a lower value? Which will be having a lower value? Crash time or normal time? Obviously, sir, crash time. है ना? We are completing the activity in 10 days. Now we are completing in 6 days. So crash time will be having a lower value. And corresponding to this will be having a larger cost. Okay. So there's one assumption that we are doing. One assumption that we are doing is we have to have a linear approximation, because definitely we can have a variation like this. We can have a curve variation, but we are taking, okay, sir, no problem. We can do is we can take a linear approximation. That means there's a variation happening in a linear way. So what will be the slope of this? The slope of this particular curve, this is cost on the y-axis and time on the x-axis. Then what will be the slope of this curve? This is the change in cost by change in time. So I can say this is equal to crash cost minus normal cost divided by normal time minus crash time. Okay, so this is, we call it as the crash cost slope. This is, we call it as the crash cost slope. Then what is the meaning of this crash cost slope? Let us take one example. Example ke bina industrial is not complete, I think. Hai na? Let us take one example. Let us suppose I'm having an activity A, right, whose normal time is 10 days. I'm taking the same example. And the normal cost is 1500 rupees. And the crash time is 6 days. And the crash cost, let us take it as, so that it will be divisible by 6. So 6 plus 6, 12. 27. Okay. Yes. Right. That means activity A, normally it will be completed in 10 days and normally it will be charged rupees 1500. But if I want to crash to 6 days, it will be costing me 27. So can you tell me what will be the crash cost slope? Your crash cost slope will be equal to 2700 minus 1500 divided by 10 minus 6. Can you tell me what is the value? What is the value that we'll be getting? अच्छा 4 हो गया ना, 1 2 हाँ, yes, 300. Perfect. Rupees 300 per day. That, what's the meaning of this? The meaning of this is I have to pay 300 rupees additional per day basis. I have to pay 300 rupees additional per day basis. Sir, can you tell me what is the physical meaning of this? Let us suppose if I want to complete this activity in 9 days, instead of 10 days, I want to complete this activity in 9 days. Perfect. इससे अच्छी बात कुछ हो ही नहीं सकती. We are having a gate admit card being released, right? So ठीक है, बहुत बढ़िया. So I think industrial is the lucky charm for you. Okay. So if I want to complete this 19 days, so 1500 plus 1 into 3, because I'm crashing by 1 day. So what will this? It will be costing me rupees 1800. It will be costing me rupees 1800, right? Okay, let us suppose I want to complete this activity in 7 days. Can you tell me what will be the total cost that you have to? This is all I'm talking about, the direct cost only. Okay, can you tell me if I want to complete this activity in 7 days, what will be the total direct cost that will be charged? 1500 though we have to pay, plus additional how much? Plus additional how much? It is how many days? 3 days we have crashed. 3 into 300. That is somewhere around 9. This is 2400. Okay, fine. If I want to complete this activity in 6 days, let us take that also. If I want to complete this activity in 6 days, 1500 plus 4 days crashed, 4 into 300, that is somewhere around 2700. I think that is the same value that is being seen over here. Understood the concept of crash cost slope? In crash cost slope, we are basically calculating per day basis how much additional cost we have to give. And that is matching with our value. Okay, is this clear? That is matching with our value. Right? So now let us do the analysis. Let us take one example. Try to inculcate all the concept that we have studied to that particular concept. Okay, fine. Is this clear? And in this particular example, we'll be taking the step-by-step analysis. Huh. Exactly. Correct. Job in? Yeah, job in, right? If you want to complete, let's say I'm taking the same value over here. This was 10 days. This was 6 days. So if you want to complete this in 7 days, it will be costing me how much? What was the value? The value was 2400. This was 2700. This is 1500. Is this clear now? And that is your approximation that we are doing, linear approximation. The concept of slope is basically that only. Clear? Very good. A question from Jobin. I hope so now this has been clarified. Okay, chalo. Now let us take this example and let us try to have a clarity. We are saying we are having a table being given in this normal cost, normal time, crash cost and crash time is being given. They are saying that if you want to reduce the project by 2 days, what should be the additional cost that you have to bear? Understood? Understood the question? That means if you are not doing any crashing, let's suppose this was any X days. If you want to complete this in X minus 2 days, what is the additional amount that you have to pay? Let us try to understand. Now, this is a very interesting thing. Can you tell me if you are changing total cost during sir, only IDC does not change exactly. Actually, IDC is also changing, right? It is decreasing. I hope so that is being clarified over here. IDC, it is being decreased. By crashing, DC will increase, but IDC will decrease, right? This is always per day basis. This is always rupees per day. Earlier you were doing in 10 days, now you are doing in 6 days. So per day cost has been decreased, right? So indirect cost will be decreasing, direct cost will be increasing. You have to have a balance between these two. Clear? Fine. Okay. Right? Because indirect cost is what? It is the cost which is not directly involved in the execution or completion of an activity, but it is actually compulsory, which is required for the safe and the timely completion of the project. It is also a mandatory thing. It's not like this indirect cost is not required. Total cost might increase, might decrease. That is the optimization that we have to do, because total cost is equal to the summation of direct plus indirect, right? If you are doing crashing, this is increasing, this is decreasing. So you have to have an optimization between these. You have to have an optimization. Might be the total cost will be decreasing. Might be the total cost might be increasing. That you have to do. Okay, fine. So let us take this example. I was asking one question. In a complete project, can you tell me by changing the time of which activity you can change the project completion time? If we are having a combination of critical and non-critical activities, so which activity you have to select so that you can change the project completion time, capital TE? Will it be critical or non-critical? Sir, definitely critical. That is the reason I'm calling that particular activity to be critical. Okay, critical activity simply means if you change the time of the completion of the critical activities, your project completion time will also be changed. Okay, so now we have understood that. So now let us try to calculate. What we can do is, let us first of all calculate the cost slope. Let us calculate the cost slope over here for all activities. Okay, what is the cost slope? That is, this is your crash cost, this is crash time, this is normal cost, this is normal time. So 200 minus 100 divided by 2, that will be 100 divided by 2, that is 25. Oh, sorry, 50, not 25. That will be 50. Okay, fine. This is your crash cost. This is crash time. This is normal cost. Normal cost. This is normal time. Okay, we know that we can calculate this by using the formulation of crash cost minus normal cost divided by your normal time minus crash time. So this will be 100 divided by 2 is 50. This will be how much? 200 divided by 2 is 100. Yes. Values you have to say. 40 divided by 1, 40. 300 divided by 4. 300 divided by 5, 60. 100 divided by 4, 25. 20 divided by 2 is 10. Are we having this value? Yes. What is that? In slope, we said total cost increase the normal time. No, sir. No, that was whenever we are discussing about this particular slope, right? This was only I'm talking about the direct cost. This is all the information that we are discussing. This all thing we are talking about the direct cost only, not about the total cost. Total cost will be the summation of direct and indirect. Okay, if you try to visualize this, all we are talking about the direct cost. Okay, fine. Ajay, is this clear? This slope that we are doing, that obviously, right? Chalo, coming back to that particular question now. Now we have calculated the cost slope for all individual activities. Let us draw the network diagram and try to identify among this which is the critical activity. 1, 2, 1, 3. 1, 2, 1, 3, 2, 4, 2, 5. 2, 4, 2, 5, 3, 4 and 4, 5. Okay, now let's write the duration of time. We'll be writing the normal time, right? 1, 2 is having 8, 1, 3 is having 4, 2, 4 is having 2, 2, 5 is having 10, 3, 4 is having 5, and the last one 4, 5 is 3. Okay, so this is your network diagram. Can you tell me which is the critical path and which activities are the critical activities? So let's try to have a clarity. 0, 8, 4 plus 9, this will be 10, 18. Yes, are we having 18 days? Right, and the critical activity is 8 plus 10, 18. So 1, 2, 5 is the critical path. It is a critical path and the expected time of completion is 18 days. Yes or no? Yes, 1, 2, 5. Perfect. 1, 2, 5. So among all these activities, only activity we have to concentrate on 1, 2, 1, 2 and 2, 5. That's it. Forget about the rest of the activities, because if you change the completion time of the non-critical activities, won't be changing the completion time of the project. So among 1, 2 and 2, 5, which activity is having a lower cost slope? Because I'll be preferring that if I try to crash activity 1, 2 by 1 day, it will be costing 50 rupees. If I crash activity 2, 5 by 1 day, it will be costing me 60 rupees. So which activity I'll be preferring? Sir, without any doubt, I'll be preferring activity 1, 2. Yes, I'll be preferring activity 1, 2, because if you try to decrease the project duration by 1 day, it will be costing me rupees 50. Okay, additional 50 rupees, right? So now, and try to do one thing. Can you calculate what is the total cost? It is not required in the question perspective, only for your understanding. At this point of time, what is the total cost? total cost is, and I think they have not given any, indirect cost. Let us suppose I'm assuming the indirect cost is rupees 200 per day. Okay, so that we can have more understanding of this particular question. So let us suppose I'm giving you in the question the indirect cost is 200 rupees per day. So can you tell me what will be the total cost at this point? So total cost will be addition of all these costs. Without crashing, it will be costing me rupees 250, 300, 400, 500, 580. 580 plus indirect cost, which I've assumed is 200, 200 into 18. Okay. So what will be this total cost? Whatever will be the value, we can calculate. Yes. Can you tell me the value of this? 3600 plus 580. 4180. Yes. 3600. Something like this. 4180. Yes. So this is the total cost. 4280. Sorry for that. This will be the total cost that I have to bear if I want to complete this activity in 18 days. Okay. In question, they are not saying that you have to optimize. In this question, they are not saying we have to optimize. They are saying what is the cost that you have to bear in order to crash for 2 days. So coming back to this question, so I will be selecting activity 1, 2. So if I crash activity 1, 2 by 2 days, will this project completion time or will the critical activity will be changing? Can you tell me? If you try to crash activity 1, 2 by 2 days, will it be changing the critical path? Yes or no? Try to have a clarity over this. No, right? If I try to redraw over here, 1, 2, 5, 4, 3, right? So before crashing it was 8. Now after crashing it is 6. Rest all the activities will be same. 4, 5, 3. 4, 5, 3. This will be 2 and 10. Okay. So now let us try to calculate. I have crashed this activity 1, 2. I have crashed activity 1, 2 by 2 days. So by doing so, 0 plus 6, 6 plus 2 is 8, 8 plus this is 16, right? 4, 4 plus 5, 9, 9 plus 6, 12, right? So I'm getting the project completion time. I'm completing in 16 days. So by doing so, how much additional cost you have to pay? 50 rupees for 1 day. So 50 into 2, 100 rupees you have to pay additional. Right? You have to pay 100 rupees additional, right? So now I can say in the question, they were only asking you about what is the cost to reduce the project by 2 days. Option A, 100 is the correct answer. Option A, 100 is the correct answer. This is only for your understanding because after this solution, we'll be having this particular concept being included. In examination, just you have to see how much cost. It's only 50 rupees per day. You are crashing by 2 days. 100 rupees is the correct answer. So let us have some extension of this particular discussion. So if I try to see now at this particular time, what will be the total cost? Direct cost plus indirect cost. What is the direct cost? It was initially 580. 580 plus 50 plus what I've assumed is 200 rupees. 200 into 16. So can you tell me, are we in a safer side where the cost is increasing or decreasing? What is happening? Are we on a safer side? Definitely we won't be on a, we will be having on a safer side because 200 rupees per day, 200 rupees per day is the cost. So I'm saving 400 rupees, right? This is the total saving, total being saved, and I have to bear 50 rupees additional. 50 rupees additional that I have to give. So almost I will be saving 350 rupees. Total saving will be 350. Is this clear? Understood? So what will be the value? You have to just, if you add, what is the value you are getting? This will be 100. 2 days, na? 50 for 1 day, I'm crashing by 2 days. So it will be 100. So it will be 300 rupees being saved. So this is 100. So I will be getting how much? 3980. Yes? Yes, I'm getting 3980. Yes, everyone. Okay, so now what we have seen that because I have saved rupees 3880, exactly 300 rupees, na? 3880. So now you have seen that when you are completing this project in 18 days, it was costing me rupees 4,280, but now as I'm completing this in 16 days, I am charging, I have to pay only 3,880. So this way, this is 4180. Whatever value you are having, है ना? Exactly. Okay, perfect. 4180, and by subtracting 300 to this, I will be getting 3880. Now perfect. Okay, fine. Is this clear? So initially that I've written was correct. Okay, understood. So by this way, by doing the crashing activity, you are actually decreasing the total cost. Okay, in examination they will, it's very rare that we'll be asking the optimization. They'll be asking question like this: what's the cost to reduce? Or they'll be saying what's the total cost you have to bear after decreasing the project by 2 days, right? So definitely you can calculate now by using this. In that case, they will be giving you indirect cost also. They will be giving you the indirect cost also, right? Clear? Now let us now proceed with the last segment of PERT CPM, that is float, total float, free float, independent float. What is the meaning of this? Okay. Now let us say I'm having an activity from I to J. Okay. And let me do one thing. Let me take an example. Let's say this is 1, 2, 3, 4. Okay, I'm taking a random values A, B, C, D. This is 5, this is 6, this is 3, this is 8, and this is 7. Okay, what is the value that you are having? What is the critical path that you will be having? Quickly, the critical path will be 0 plus 5. This will be 5, 8, 8 plus 7. This will be 8. This will be 15. Anna? Yes? Yes? Are we getting this 15? And the critical path will be 1, 2, and 15. Yes. So I'm getting 1, 2, 3, 4 as the critical path, and the expected completion time is 15. Let's do the back calculation also. Let's do the backward pass computation. 15 minus 7 is 8. 15 minus 8. What will be 15 minus 8? 15 minus 8. What will be that value? Somewhere around 7. And if I say 8 minus 3, that is 5. So in the backward calculation, I'll be taking the minimum value. So this is the 5. Okay, fine. 8 minus 6 is 2. 5 minus 5 is 0. I have to take the minimum value. So now I have completed this particular activity in the forward pass and the backward pass computation, right? So now let us try to understand the concept of float. Float means by how much duration you can delay an activity without changing the project completion time. That means, let us say if I delay this activity D by 1 day, that means I'm increasing the duration by, instead of 8 to 9. By doing so, is my project changing from 15 to 16? Yes. If I'm changing the duration of activity D instead of 8 to 9, is that changing the project completion time from 15 to 16? Yes or no? Yes. Try to see. 5 plus 9, still 14. It is not changing. It is not changing. Why? Because this is a non-critical activity. Non-critical activity. Is this clear? Fine. So, float will always be equal to 0 for a critical activity. Always remember that. Because if I try to increase the duration of activity E by 1 day, let's say I'm changing from 7 to 8, definitely it will be increasing from 15 to 16, right? So we are not having any buffer to complete this activity E, but yes, I'm having some buffer to complete this activity D. So if I try to note down this activity D, this is from 2 to 4, activity D completed in 8 days, right? It is having 5, 5, 15, 15, right? So here I will be now discussing about 3 important understanding, that is total float, free float and independent float. What is the meaning of these 3 terms? The first one is total float. Total float basically means it is the amount of time by which an activity can be delayed without changing the project completion time. Okay, if I say the definition perspective, total float is the difference between the maximum time available to the actual time required to complete an activity without changing my project completion time, or without changing my project completion time. If I try to calculate what is the total float, so total float calculation will be, if I write for a general perspective, I, J, okay, this is EI, this is LI, this is EJ, this is LJ, right? So I can now write it as the total float will be equal to, let's say this is duration of time is Tij. LJ minus EI, go with a cross calculation, LJ minus EI minus Tij. By using this formulation, you can calculate the value of total float. By using this calculation, you can calculate the value of total float. Let us try to take this example over here. If I want to calculate the total float, this is your LJ, this is your EI. So 15 minus 5 minus 8. Can you tell me what is the value? It will be equal to 2. That means I can delay activity 8 by 2 days without changing my project completion time. And that is absolutely correct. If I try to change plus 2, if I try to complete in 10 days, so 5 plus 10, 15, still my project completion time is not being changed. But if you try to increase beyond that, let's say I'm completing in 11 days, then my critical path will be changing, then my project completion time will be changing, because once you are changing to 10, it is now becoming a critical path. When you are changing from 8 to 10, now it is also becoming a critical path. So that case, we are having multiple critical paths in that case. Okay, so now we have seen that total float is equal to LJ minus EI minus Tij. Is this clear? No need to have any other formula. There are multiple formulas given in the textbooks. Okay, no need to remember that. Just you need to have only one understanding. Draw the network diagram, use this formulation, get the value of total float. Never ever you will be having any doubt or difficulty. Never in your entire discussion of CPM analysis. Okay, fine. Clear? Total float. Now, let us try to understand the second very interesting term, that is free float. Second very interesting term, that is free float. What is free float? It is the amount of time by which an activity can be delayed without affecting the early start time of the succeeding activity. That means if I want to complete activity, if I want to calculate the free float of activity C, by how much duration activity C can be delayed such that the early start time of the succeeding activity is not changing. Let us take an example. Let us suppose if I say free float EI, IJ, this is EI, LI, EJ and LJ. This is your duration of time. To calculate the free float, you have to take only the upper values. Oh, sorry, this is, You have to take only the upper values, that is EJ minus EI minus TIJ. That means by calculating the concept of free float, your early start time of the succeeding activity won't be changing. Let us take the same example over here. Let us take the example of activity D only. Or activity D is the last one. Let us take activity B. Okay, let us take the example of activity B. Activity B is from 1 to 3. And it is having duration of 6, 0, 0, 8, 8. So can you tell me what will be the free float? That is 8 minus 0 minus 6, that is equal to 2. What is this meaning of this? The meaning of this is if you increase this duration by plus 2, let's say I'm increasing by 8. So 0 plus 8 till 8. So I'm not changing the early start time of activity E. Is this clear? Fine. Is this clear? I'm not changing the early start time of activity E by having a concept of free float. Understood? Yes. So this is your free float ka concept. Clear hai? Sharma ji, Manas, Ashutosh, everyone, Bhaumik, Shashank. Yes, sir. Okay. Enjoy kar rahe hain. Are you enjoying this? Because with the same energy, the same intensity, 7 baje tak, or more than that, we'll be discussing. Okay? Complete karenge aaj. We'll be discussing everything. And I want support from all of you. Okay? It's a mutual session. It's not about only one thing. Today, just like I think Dheeraj sir also said, today we also will be saying, and you guys also will be listening. Okay, just once, please. Okay, definitely. What is free float? Free float is basically by how much duration an activity can be delayed without affecting the early start of the succeeding activity. That means if you are changing the activity, let us take the same example. Let us take the activity number B. If you change the activity number B instead of 6 to 7, let us say I'm taking 7. Okay, so 0 plus 7 is 7. Here we are having 8. Still it is not being changed. You are not changing the early start time of activity E. Is this clear? And that is a concept of free float. So that means if I now increase by 2 days, so 6 plus 2, that is 8. So 0 plus 8 is 8, still not changed. But if I try to increase beyond that, let us say I'm increasing plus 3. Okay, 6 plus 3 is 9. So 0 plus 9 is 9. I'm able to change this. Okay, fine. Is this clear now? I'm changing this value of 8 instead of 9. So this is the concept of free float. Okay, chalo, bahut badhiya. Next is independent float. What is independent float? Independent float is the amount of time by which an activity can be delayed while all preceding activities are completed as late as possible. Simple matlab hai, it's very having easy understanding. By how much an activity can be delayed so that the previous activity latest finish time is not changing. Okay, so if I try to take the expression for independent float, right, let's say I'm drawing this particular diagram one more time. Just in 5 minutes we'll be completing PERT and CPM. Okay, EI, LI, EJ and LJ. Okay, this is your duration of time. So what is independent float? Independent float is LJ minus LI minus TIJ. Okay, no problem. Gate admit card release हो गया, कोई दिक्कत नहीं है. It has to be released, right? If it is not being released, then how you can write the examination? Okay, chalo. Fine. Right. So now let us calculate the independent float of this particular activity. Let's say I'm taking activity B only. Independent float of activity B. Okay, that will be 8 minus 0 minus 6. That is 2. early time of succeeding not change. Exactly. In case of free float, if you're changing the duration, your succeeding activity early start time is not changing. In case of independent float, your preceding activity, the previous activity, the latest finish time is not changing. Understood the concept between free float and independent float. So let us calculate for B. Now, if you try to increase, let's say I'm increasing by 1 day. Okay, this is your, let's say I'm taking 7. So 8 minus 7, it is 1. Still I'm not changing the previous least value, because in the backward calculation we always take the least value, right? If I'm, let us suppose, increasing by 3, let's say I'm taking it as 9. Okay, so 8 minus 9 minus of 1, which is not possible, right? We cannot have a negative value. So we cannot have a, you cannot decrease or you cannot increase activity B beyond 8 days. Okay, let us take one example of activity D, because here B is having the starting now, so won't be having any clarity in this. Let us take an activity D. This is activity D. Calculate the independent float. Independent float is 15 minus 5 minus 8. That will be 2. That means if you try to increase this activity D by 2 days, that is 10. 15 minus 10. Able to understand? Able to understand? The previous activity latest finish time should not be changed. Yes? Okay. If I'm trying, let us say I'm taking 9 days. 15 minus 9, it will be 6. Minimum value is still 5. Not changing. Okay. So independent float, total float and free float. This is the concept that we need to calculate. And in the GATE examination, they're asking questions directly from this. Okay. They'll be having 2 plus 2 common link problem. One question, calculate the expected time of completion. Second question, calculate the total float of any activity that you can calculate. By using all these expressions, let me write it over here one more time for all of you guys. I, J, E, I, L, I, E, J, and L, J. So total float is equal to, total float will be equal to Lj minus Ei, cross calculation, minus Tij. Free float, upper values, Ej minus Ei minus Tij. Independent float, lower values, Lj minus Li minus Tij. By using these relations, now you can calculate free float, independent float, and okay, fine. Right? So we have taken 3 floats. We are having a float. Float is classified under 3 different categories. One is total float, free float, and independent. What is total float? This is the duration of time by which an activity can be delayed without changing the project completion time. What is free float? This is the duration of time by an activity can be delayed without affecting or without changing the early start time of the succeeding activity. What is independent float? This is the duration of the time by which an activity can be delayed without changing the duration of the previous or preceding latest finish time. Okay. I think that is independent float. I think interference float. So we have taken all the 3 floats: free float, independent float, and total float. Because there are 3 possibilities. One will be talking about for overall project, that is your total float. One will be talking about the succeeding activity, that is free float. One will be talking about the previous activity, that is free independent float. Independent float is Ej, na? No, it is Lj minus Li. Independent float Lj minus Li minus Tij. Free float is Ej minus Ei minus Tij. Total float is Lj minus Ei minus Tij. Okay, so this basically completes your chapter number 1. That is the most important. the most important, that is your PERT and CPM. Okay, we'll be seeing all this, Ashutosh and I think Raghu, Raghu, we'll be seeing this, no problem. If any float is still being there, slack or float, देखो, one is we are discussing from your CPM perspective, one is we are discussing from PERT perspective, right? The basic meaning of slack and float is same only. Okay, if I say slack, we are using the concept of slack in your PERT analysis. The concept of floats we are using in CPM, but ultimately the meaning is same only, right? Normally we are saying float or slack, both are having the same significance. Okay, fine, right? So this basically completes your first chapter, I think, this one, PERT and CPM. So let's begin the next chapter, that is break-even analysis. Then we'll be having a 5 to 10 minutes of break, right? Then we'll be starting with the next very important inventory. Inventory ke baad, we will be taking your, I think, sequencing, right? Okay, fine. So shall we begin? Break-even analysis, it's a very small topic. Okay, let's begin. A very interesting and very scoring topic actually. And dekho, very important thing. There's a very huge misconception that, sir, industrial, who will be studying? They are not asking a lot of questions. They're asking at least 5 to 6 marks. And this is a subject where you can secure 100% marks. Okay. If you compare from other subjects, there will be some sort of concept which you are not covering. But industrial ka, if I say, the syllabus is very precise, and if you try to have the clarity of that particular syllabus, I think you can easily fetch all the 100% marks from this industrial engineering. Easily. Just you need to have the clarity of the concept. And I think today's session will be covering all the segment, right? So that you're not having any doubt being left out. So now let's talk about the next segment, that is break-even analysis. What is break-even? Yes, anyone? Break-even basically means we are talking about a concept of no profit, no loss condition. Okay, because this particular concept is being used in almost every production by every production manager. Okay, every production manager is basically using this break-even analysis concept, because this tool will be helping us to identify whether my company is going in the right direction or not, or do I need to, after a few months, need to close my company, right? Break-even analysis give an idea that is my production going in the right direction, right? Because from the day one itself, you won't be able to understand whether you are going in the right direction or not, whether you're going in profit-oriented or loss-oriented, right? So this tool will be helping you out whether you are going in the right direction. That means daily target that you are setting, is that we can say appropriate value? Like, is after some point of time, do I need to change my strategy? Or by the same strategy, if I'm going, will I be getting profit after 15 days or 10 days? Okay, that analysis is, or that tool that is being used by every production manager is your break-even analysis. So let us have a discussion of this particular topic. Now, break-even analysis, for understanding break-even analysis, you need to have a clarity about different type of cost. Okay, so let us talk about the first cost. If I say total cost is nothing but the summation of fixed cost and variable cost. Total cost is equal to fixed cost plus variable cost. So first of all, let us understand what is fixed cost. Fixed cost is that particular cost which is independent of how much production you are doing. You have to bear that cost. Let us take an example. I'm having a machine, okay, which is continuously manufacturing a product. Okay, so one day I'm manufacturing 100 units. On the second day, I'm manufacturing only 1 unit. So will the charges for rent will be changing? I'll be saying to my vendor, I've only manufactured 1 unit, please give me discount. Will he be giving the discount? No, right? The rent charges is independent how much production you are doing. Okay, how much production you are doing, right? It is independent of that. So fixed cost is basically that cost which basically it is independent of the volume productions. If I try to plot the graph between fixed cost and the volume of production, it will be having always a constant value. Irrespective of whatever will be the magnitude of the production, whatever will be the volume of production, the fixed cost will always be kept same. Okay, it includes rent, rates, research and development, your marketing costs, administration costs, a miscellaneous type, or whatever cost where volume production is not affecting the cost, that we call it as the fixed cost. On the other hand, if I talk about the cost which is if I try to increase the volume production, the cost is also changing, that cost we call it as variable cost. Okay, so variable costs are those costs which directly change with the level of output or with the level of production, right? So it is being seen that there's one assumption that we are doing. Assumption is the variable cost will always follow a linear trend. It's not a parabolic or a quadratic or any hyperbolic function. It will always form a linear trend. That means if I say capital V represent the variable cost is equal to small v into x, where small v represent the variable cost per unit. Variable cost per unit, right? And this is the volume of production. This is volume production, right? In variable cost, we are actually having the raw materials, the daily wages of the labor, right? We can say lubrication, oil charges, fuel charges, electricity charges. If you are increasing the volume production, definitely the electricity charge is going to increase. Okay, if you're increasing the production, definitely the raw materials requirement will be high, right? So variable costs are that costs which are directly changing with the this one volume production. So if I try to plot the variable cost, if I try to plot the variable cost with respect to x, it will always follow a straight line. Okay, it always follows a straight line. Something like this. And this is equal to small v into x. And what was total cost? So total cost was equal to fixed cost plus variable cost. So if I want to now plot the total cost with respect to the volume of production, it will be having some offset, right? It will be having something like this. This is the total cost and this is your fixed cost, right? So if I say this additional is the variable cost, this is the fixed cost. So at any volume production, now we can easily calculate what is the magnitude of the total cost. So this much amount I have to bear. Let's say if I'm manufacturing any X amount, okay, so I have to bear this much amount of price in order to manufacture X amount of production. Okay, I have to pay X, I have to pay let's say any X value, right, total cost at X in order to manufacture X unit of volume production, right? So this is all the discussion we are doing for whatever cost I need to bear. Definitely I will be earning some revenue also, right? So let us talk about the second portion, that is your sales or revenue, which I'm getting by selling the product. Okay, the cost that we're getting from selling the product. So capital S is equal to small s into x, where capital S resembles the sales or revenue. Small s is selling price per unit, your sales price for 1 unit, right? And this is the volume of production, right? So if I try to plot the graph for x versus sales, it will be having a relation like this. Okay, it will be having a relation like this. So now this is the total price that I'm getting, and this is the total cost that I need to bear. So can we say that sales is equal to total cost plus profit? Yes, whatever I'm getting, whatever I'm paying, if you take the difference of that, I'll be getting the profit. Yes, whatever I am getting, whatever I'm paying, if you take the difference of that, I'll be getting the profit. If I say I'm getting a negative value of profit, that means I'm getting a loss. Okay, so what I try to do, I try to plot a graph, right? I try to plot a graph between this particular total cost, right, and the selling price in a single go. So if I try to draw this graph over here, this is your revenue or cost or sales or total cost at any point. This is X. If I try to plot this is the total cost that I have to pay. Total cost. Okay. And if I talk about the sales price, that will be this one. This is the sales, right? So if I try to visualize, very important thing, let us say I'm manufacturing X1 unit. For X1 unit, I am getting S1 revenue and I have to pay TC1. So I'm talking about a loss making condition or a profit making condition. At X1 volume production, am I talking about loss making or profit making? Anyone? Mithun, Shashank, Surya, Ashutosh, Manas, everyone? Obviously, sir, loss. Sir, you are getting less amount, you are paying larger amount, so I'm getting a loss making condition over here. And this loss will be continuing, and at this point, what is happening? There is no profit and no loss condition, because beyond that, if you try to take any random point, let's say I'm taking this point, X2. At X2, I have to pay this much amount of money, right? And I am getting this much amount of money, right? So definitely this is, I'm talking about the profit condition. This is, I'm talking about the profit condition, right? So in between, there will be a point where there is a no profit, no loss. And this point, we call it as the break-even point. Okay, break-even point. No profit, no loss, right? Break-even point, no profit, no loss condition, right? So if you try to have the volume production more than break-even point, I'll be getting a profit. If you try to have the volume production below break-even point, we'll be having a loss condition. Okay? Right? So now let us try to have some more discussion. So this is your XBEP, the volume production at break-even point, and this is your total sale or total cost, because at this point total sale and total cost will be same. So I can say at break-even point, there is profit will be equal to 0. So your sales value will be exactly equal to the total cost, that is fixed price, plus variable cost, or I can say small s into x is equal to f plus small v into x. So x break-even point is equal to fixed cost divided by selling price minus variable cost. Small letter basically means I'm talking about per unit charges. Capital S, I'm talking about the total price. Okay, fine. So from this particular expression, now we can calculate the XBEP. And if I want to calculate what is the total cost, right, this will be simply SBEP is equal to F plus V. Okay, F plus capital V, because at that point there is no profit, right? And here I'm talking about a very interesting concept, that is margin of safety. What is margin of safety? Margin of safety is, let's say if I talk about, let's say you need to catch a train at 10 a.m. Okay, so and it is total duration will be exactly 1 hour. So will you be coming from your home exactly 9 o'clock? You'll be starting your journey at 9 a.m. No, right? You'll be taking some safety, margin of safety, so that if there is some disturbance or if there is some traffic, you have to cover up that also. So you always take a margin of safety of half an hour or more than that. It depends upon person to catch a train. So here also we always try to have some margin of safety, because we never ever have the volume production at this point. We always take a safety, margin of safety. Let's say I'm taking at this point, let's say this is X, any value, right? So margin of safety will be the difference between these two. This is the margin of safety in terms of X. So I can say that margin of safety in terms of units is equal to X minus X break-even point. What is margin of safety means? How much additional units you are keeping in order to have that safety. So corresponding to this margin of safety, we'll be having some selling price, right? So I can say that margin of safety in terms of sales will be equal to sales at any X point minus sales at break-even point. Okay, this is the concept of margin of safety. If you try to understand from this also, if I'm taking at this point, I'm taking any volume production at this point, corresponding to this is your X, corresponding to this, the total sales value is SX. So this difference is your margin of safety in terms of sales. Margin of safety in terms of sales. Okay, above this will be having a profit, below this will be having the loss. And here, if you try to have an understanding of this angle, which we call it as angle of incidence, angle of incidence, right? So more the angle of incidence, better the situation or worse the situation. If you try to increase this angle, what will happen? If you try to have the increase of this angle, then what will happen? Definitely the profit will be, the break-even point will be quickly achievable. If we try to see that, if this is the situation, this is X, this is your sales value or revenue, okay, this is your total cost, right? Let's say there is two sales. This is one sales, this is second sale. This is selling price for any other, this is first. So in this case, this angle is, let's say 2, and this angle is 1. So when this angle of incidence is increasing, you are getting the break-even point a bit quicker. This is break-even point for the second one. This is the break-even point at the first one. So we always try to have the angle of incidence should be having a larger value. Okay, because if you try to increase this angle, you will be achieving the break-even point a bit quicker, right? So best will be more the angle of incidence, more will be the, or better will be the situation, right? Fine. And one more thing that you need to have, there is one term we call it as contribution. Contribution margin, which we are calling it as CM. Contribution margin is nothing but the difference between the sales minus the variable cost. Contribution margin is nothing but the difference between the total selling price minus the total variable cost. This is the total contribution margin. And if I want to write what is contribution, contribution is nothing but the sales per unit minus variable cost per unit. So if I write the XBEP, that is equal to F divided by contribution. There was one question being asked in engineering service also. If you try to decrease the contribution, what will happen to the break-even point? That was the question. Many students didn't even know what is contribution. Contribution is nothing but the selling price per unit minus the variable cost per unit. Contribution margin is total selling price minus total variable cost. Okay. Now, why we are studying this contribution margin? Because there's a very interesting concept. We call it as profit to volume ratio. PV graph. Profit to volume. What is profit to volume? Profit to volume is nothing but the ratio of contribution margin by sales. Now, why we are using this profit to margin? Actually, profit to margin we are using whenever there is a company which is dealing with multi-products. Let's take an example of HUL, Hindustan Unilever Limited. There are multiple products that we are having, or Nestle. In Nestle, we are having ketchup also, Maggi also, coffee also, right? So whenever an organization is dealing with multiple products, they will never ever take the BEP graph for individual product, because break-even point graph we are drawing for only one product. Okay, you cannot have inculcate all the value, all the different products in a single graph. Okay, for one product, one break-even point, one BEP graph. Okay, so if you are the owner of let's say Nestle company, so you won't be looking individual graph. You should be having one graph which will be telling us about the multiple products and the multiple profit perspective, right? So profit to volume graph is basically, they are talking about, let's say I'm having a Nestle company, we are having Maggi also, ketchup, we are having sweetener, coffee, chocolates, okay, and let's say it is near about to February month. So Feb month, I think one of the product will be having a very large production. Can you tell me which product? Feb month may we're having a large manufacturing of one of the product. Which one? 14 Feb ke around, the Feb series. First week of Feb May, we're having a large manufacturing of chocolates. Right? Kit Kat or Cadbury. Kit Kat. Okay. Normally it's like silk. There are multiple chocolates we are getting. Silk, bubbly silk. I don't know. Remember? हाँ, silk नहीं है, but normally they are having a very large production. If you try to see during the February month, right? We will be having this one. Bubbly wala एक chocolate था. I don't remember the exact name. चलो. So here what we are seeing that we are having, let's say I'm taking 3 products as Maggi, ketchup and Kit Kat. 3 products I'm taking. So if I want to analyze what is the profit capacity of different products in a single graph, for that I'll be using this concept of profit to volume graph, because it will represent, if I say this is the volume of production, this is your graph, right? This is profit, and negative profit is nothing but loss. Okay, can you tell me, everyone, if there is 0 volume of production, what will be the total loss that I have to bear? If there is 0 volume of production, what is the total amount of loss that I need to bear? Let's say sales is equal to F plus V plus profit. If X equal to 0, what will happen? Your profit will be equal to minus F. That means I have to bear the negative value of the fixed cost, right? So if I try to plot the graph, you'll be getting a graph like this. So this particular cost is nothing but your fixed cost. And this is the point where profit is 0. That is a break-even point. And it is being seen that for a particular product, the PV graph, this particular slope will never ever change. That means profit to volume ratio is always constant for a particular product. Is always constant for a product. Okay, for a particular product, the PV ratio is always constant. That means if you change the volume production also, still the PV value will be changing. Because what is profit to volume? Profit to volume will be contribution margin by sales, or we can say sales minus volume by V, or we can say fixed price plus profit divided by sales. Okay, so I can say profit to volume of a product at some point will be equal to the profit at any other point will be equal to F by SBEP. So this relation is very important. You can expect a question from this, right? They will be giving you the profit and sales value at some 2 different points for a particular product, and they'll be asking what is the break-even point. Okay, for that what you have to do is you need to take this expression, take these 2 expressions at a time, calculate the value of F. Once you're getting the value of F, now you can use any 2 expressions to get the value of the break-even, because at break-even point the profit will be 0. That's why I'm not written any profit value over there. Okay, fine. And if I try to understand this particular for the multi-product, okay, fine. So this will be your X, this is your profit. Let's say I'm having 2 products. One is this one. Oh, let me write it like this. One is this one. Second is this one. Okay, this is Kit Kat and this is Maggi. So which is more profit making? Maggi or Kit Kat? Which is more profit making? This is the volume production. This is your profit. And this is your loss. Yes, which one is more profit making? Can you try to visualize by looking at this graph? Obviously, sir, Kit Kat. Because I am getting the break-even point a bit quicker as compared to Maggi. Let's say if I want to get the profit, I need to have, let's say, 100 units. Here, only by having, let's say, 20 units, I will be able to get the profit. So definitely Kit Kat is a more profit-making product. So I'll be concentrating more on Kit Kat rather than on Maggi. Okay? I'll be concentrating more on Kit Kat rather than on Maggi. So by this way, I can use a concept of the profit volume ratio. Right? I can take the concept of profit volume ratio Very easy. That means if you try to increase the slope, your profit volume, because definitely what is P by V? This is the slope only, profit to volume. Okay. So, and it will always be constant. For a particular product, this P by V value will always be a constant for a particular product. Right? If you're changing the sales value also, the your profit value will also be changing. Okay. Fine. So now you can easily compare at multiple points. Okay. For a particular product, the P by V ratio is always same. And by using this, you can calculate any question coming in the examination. Okay. Very small topic, break-even analysis. Fine. Chalo. Now let's proceed to the next topic, right? And I think this is the complete schedule, updated schedule, right? I think, have you got that updated schedule? The production part 2 has also been added up on 16 January. Okay, earlier it was still 15 January. One more session is being added based on your response, based on your energy. A core session we have added by Ravinder sir on 16th of Jan. Right? So, shall we start? Yes, the next topic is inventory. It will be taking at least 1.5 hour, 1.5 hour at max, okay, to complete this inventory. We'll be taking every single point. Okay, shall we continue? Inventory ke baad, I think we will be going with sequencing, I think. Chalo, I think energy is still high, so let's us flow mein, let's continue and let's start with the inventory. Very important. This is, if I say from a gate examination perspective, PERT, CPM, inventory, these two are very important topics. Forecasting bhi, I think. Everything will be covered. 5 minutes water break. Chalo. Okay. In that case, let me give you one question. Okay, you can take a 5 minutes break. I can give you a question. You can try to solve this right now. एक क्वेश्चन देते हैं आपको. Question is something like this. Let's say for a particular product, the profit to volume ratio is 50%, right? And the sales value at any point is rupees 1,000. And the profit value is 500. Okay, what is the sales at a break-even point? Can we calculate? Okay, so it's a question. The students, those who want to take a 5 minutes break, not 5 minutes, 2 minutes, ठीक है यार, है ना? Quickly, and the students, those who are live with us, quickly tell me what will be the answer for this. प्रॉफिट टू वॉल्यूम दे रखा है. चलिए, ट्राई दिस प्रॉब्लम. सर एफ इज 0. नो, you have to calculate f. They have not given the value of f. चलो, let's, students might be joining. ठीक है, let's try to understand. In order to calculate, we know that for a particular product, profit to volume ratio is always constant. है ना? It is sales, or we can say fixed price plus profit by sales, let's say 1 is equal to fixed price by sales at BEP. I think now the hint is being given. Now you can calculate. अच्छा, F0 आ रहा है. चलो, let's try to say अच्छा, इसको we are getting 0 ना, तो let's try to change this value by 2000. Okay, now perfect. Yes, let's change this value to 2000. That will be much appropriate. 0.5 is equal to profit is 500 divided by 2000. Okay, so from here I can calculate the value of fixed cost. Fixed cost will be coming out to be I think 1500 500, 500. So I'm getting the fixed cost as 500. Okay, so fixed cost 500 nikal gaya hai. Place it over here. So we can say 0.5 is equal to 500 divided by sales at break even point. So the sales at break even point will be equal to 1000 rupees. Perfect. 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 The sales at break even point will be coming out to 1000. Okay. Any doubt if you're having, please do let me know. Break completed. Yes. 2 minutes, 3 minutes bola tha. So I think that has been completed. We'll be taking a 10-15 minute break after inventory because inventory will be a larger topic. We'll be covering by 2 p.m. right? 1:30 or 2 tak we'll be covering inventory. Then we'll be starting I think forecasting. Chalo. So now let's begin our discussion of the topic of inventory. Very interesting. Many students are having doubt in inventory. So let's clarify that also. Okay. So let's have lunch break. 15 minutes काफी हो यार. I want कि that momentum थोड़ा सा कंटिन्यू रखते हैं. We'll be taking the lunch break at 2:30. Okay, 15 minutes or 20 minutes, whatever it's being required. Okay, we'll be taking that lunch break. Then we'll be continuing till the end. Between small breaks like this, 2-3 minutes break we'll be taking. Okay, so now let's talk about inventory. Inventory is nothing but the stock in hand. Okay, I won't be going for the definition right now. I hope so everyone knows what is an inventory, right? Or shall I start with the basic one? Dekho, inventory is nothing but, let us say I'm making a roti. Okay, I hope so everyone seen my video on that roti making. Hai na? So let us suppose I'm making a roti. So you're having a atta with me. Hai na? You're having the dough with me, right? You're having the hot case in which I'm keeping the rotis. So what I'm doing, am I going to shop every day and purchasing 200 grams of atta so that I can make the roti every day? No, right? I'll be keeping a stock, right? I'll be keeping a 10 kg stock, right, with me, and I'll be taking a portion of that from which I'll make the dough, and from that I'll be making the chapati. Okay, from that I'll be making the chapati. So let us suppose I made 10 chapatis because I was very hungry. It was a marathon session, so I had I was very hungry, so I made 10. But after eating 2 rotis or 3 rotis full, so the rest rotis I'll be keeping in a stack. So can you tell me, in this complete process, what will be the inventory? Are we talking about the final product, this, or are we talking, let's say I'm only taken this portion. Okay, this portion is being used and this portion is being left out. So in this case, which portion, I'm dividing this into 3. This is A, this is B, this is C. So which one will be the inventory? Only A, only B, or only C, or A and B, right? Or combination of this, because from this 10 kg, I'm not taking entire one. I'm taking this, and this complete I've converted into dough. Yes. Are we talking about the this only raw materials or the final product, or enter between the dough that we have prepared? Is that also the inventory? Very good, Sujesh. We will be having this also as inventory, this also as inventory, and whatever roti is being left out, that also an inventory. So inventory is basically the stock in hand which we can use for the later purposes. That could be the finished product also, that could be the raw material also, and that could be the work in process. Any WIP or work in process which you can use for later on, because definitely, let us suppose you're having a dough being left out. It's not like you'll be throwing. You'll be making the roti at night or the next day. Okay, exactly. Fine. So now, in case of inventory, because inventory is all we are talking about, the cost analysis. Okay, what level of inventory that I have to keep so that overall I'll be making a larger profit. So here, whenever I'm dealing with profit, I'll be dealing with some cost. So here in inventory, we are having different categories of costs that we need to understand one by one. One is purchase cost, ordering cost or setup cost, holding cost or carrying cost, or shortage cost. Okay, let us discuss one by one what are these different costs we are talking about. Let's start with the first one, that is purchase cost. What is purchase cost? This is the cost that I need to bear in order to purchase a particular item. Let's say I need to purchase this pen, and this pen is costing me rupees 5, MRP is 5, and I need to buy 100 pens. So I have to just give 5 rupees into 100, 500 rupees I need to pay, right? If I want to purchase 100 pens, each costing me 5 rupees, so definitely I need to pay rupees 500, and that 500 is nothing but your purchase cost. So if I write purchase cost, that is nothing but your number of units, okay, into cost per unit. Cost per unit. Or I can say, if I'm denoting capital D as annual demand, capital D as annual demand, that is units per year, and C as cost per unit, that is rupees per unit, right? So I will be having this as capital D into C. This is your purchase cost. Capital D into C, this will be the purchase cost. Okay, fine. 100 pens, 5 rupees each, 100 into 5, 500 rupees, that is the purchase cost. Now, whenever you are, let us suppose you are using Zomato. In Zomato, whenever you are ordering any food, they are charging some additional amount. Have you seen that? Or whenever you are purchasing a ticket from IRCTC, they are charging some extra amount. Have you seen that? In Zomato, they are taking delivery charges. In IRCTC, they are charging transaction charges or some additional charges, right? So that additional charges, we call it as ordering cost. Ordering cost basically means if I want to order 100 pens, definitely it's not like it will be, I'll be calling to the vendor, I'll be saying, okay, just send 100 pens to my factory. Definitely they will be charging some transportation cost. They'll be charging some transaction cost. They'll be charging some documentation cost. Okay, fine. So whatever cost is being used in order to bring that inventory from the warehouse to your factory, so that cost, additional cost, we call it as ordering cost. Okay, so what will be that ordering cost? That will be number of orders into cost per order. So if I say I'm denoting capital N as number of orders, right? So and per year, okay, and CO as cost per order. Okay, so I can say that number of order, that is ordering cost, will be equal to capital N into CO. Ordering cost will be capital N into CO, right? GST, any other transaction charges, right? Or any additional charges that they are charging apart from that MRP. Apart from that MRP, they are charging some additional cost. That is your ordering cost. Okay. Now, there are two possibilities that we can have. One is you can bring the inventory from outside. That is one possibility. Or what you can do is you can manufacture the inventory from in-house. This is second possibility. Like let us suppose, you might have seen in every automobile industries, the tires is always being procured from outside. Let's say I'm taking an example of Tata Motors. Tata Motors never ever manufacture tires in-house. They'll be taking from Apollo or JK or any other or MRF, right? So they are procuring from the third party, or they're procuring from additional outside market or outside vendors, and they're not manufacturing tires. So in that case, I'm ordering from outside. But let us suppose you have decided that I will be starting my own company of manufacturing of automobile, and I've said, okay, sir, let's do one thing. Let's try to manufacture tire also in-house. So in that case, I'm not procuring from outside. I'm manufacturing from in-house. So this kind of scenario, I'll be taking the concept of carrying cost or setup cost. Okay, that will be called as a setup cost, right? that will be caused as the setup cost. What will be setup cost? It is the cost that is being associated in manufacturing the inventory in-house. Okay, the cost that is being associated in bringing the shutdown production system again to starting position, or we can say that whatever cost will be beared by us in order to, let's say I'm doing the shutdown of the production system. Okay, so I'm doing the shutdown. Definitely, I need to have some internal some system, so that during shutdown my system, the production line should always be working, right? So I can say what will be the setup cost? Setup cost will be equal to number of setup into cost per setup. So if you try to visualize, these two formulas are almost similar, and you cannot have ordering cost and setup cost simultaneously working together. Either you will be procuring from outside or you will be manufacturing inside. You cannot have ordering cost and setup cost in a single go. Either you will be having ordering cost or you will be having the setup cost. Is this clear? Either you will be procuring tires from outside or you will be manufacturing tires in-house. Okay, so if you try to visualize, ordering cost and setup cost both are having the same formulation. So I can use the setup cost as the number of setup into the cost per setup. Okay, I'll be using the same notations. Why? Because so that to avoid unnecessary notations, right? I'll be using some standard notations and I'll be following that same notation. If they are giving the setup cost, that means they are talking about some production model. So definitely they'll be giving some setup cost. So you can take that as CO. Number of setup, I'm denoting it as capital N. Here, if you are procuring from outside, you'll be having the number of orders as capital N and cost per order as CO. So in order to avoid these type of confusions, what I'm doing, I'm generalizing all these cases, so that whatever condition they are giving, you will be having one standard notation and no confusion. Definitely it should be CS, it should be some NS. Why to write unnecessary notation which is having the same meaning? Okay, fine. So this is about the ordering cost and the setup cost, either ordering or setup. That is the reason while starting I have written it as ordering cost or setup cost, because both are having the same meaning. Okay, next is holding cost or carrying cost. Holding cost is because in case of your setup, you need to in order to manufacture tires, you need to have some rubber that you need to bring from outside, raw materials. You need to have some machines which will be manufacturing tires. That is also being included in this setup cost. So making one setup, how much cost is being associated? That is cost per setup. Okay, so now let us talk about holding or carrying cost. Now let us suppose you have opened a jewelry shop. Okay, you are now the owner of the Tanishq jewelry shop, diamond wala shop. Okay, and you have seen that, let's do one thing, let us try to procure the diamonds for the next 6 months. You're having in your account approximately 100 crore and you have procured almost for the next 6 months. So by doing so, right, and you're having a bulk of diamonds with you and you are storing in a plastic box, is that a feasible thing? Is that a feasible thing? That you're having a diamonds worth 60 to 70 crore and you are keeping in a plastic box. I think the person who is a security guard, that will be the first person that will be taking, right? Or you tell me the address, I'll be coming to that particular shop. Okay, definitely I won't be keeping that in a plastic box. I'll be keeping in a very safe house. Okay, I'll be having a armed person, a person who is standing with a gun with very big mustache, right? CCTV cameras. So you will be having a tight security. You're having a 60 crore, it's not 60 rupees. Okay, so definitely in order to keep it safe, in order to store that raw material, right, you need to have some cost being associated, and that cost we call it as the holding cost. In order to keep or maintain that particular inventory, you should be having some cost, and that also includes not only about storage. We will be having the handling cost, damage cost, depreciation, insurance, whatever cost that is being included in order to store or keep the raw materials or the inventory safely. That is, we call it as the holding cost. Okay. Now holding cost is basically equal to, now let's take an example. You are keeping the diamonds for 6 days and you are keeping the diamond for 1 month. In both the cases, will the holding cost will be changing? In both the cases, will the holding cost will be having some differences? In one case, I'm keeping for only for 10 days. In second case, I'm keeping for 1 month. Definitely the holding cost will be varying. So now you can have a very important discussion that holding cost depends upon the time also. If the duration of the time is more, the holding cost will be more. If the duration of the time is less, the holding cost will be less. So now you need to have, ज़्यादा ठंडा हो गया यार. I think 18 degrees Celsius is very high. So inventory holding cost is nothing but the average inventory for a particular period into holding cost per unit time. Okay, I won't be writing the expression right now. The reason being, for writing the expression, you should be having a clarity with the concept. Okay, so when we'll be discussing the EOQ model, they'll be taking the derivation and there I'll be giving you the formulation of holding cost, right? Okay, and same goes with holding cost or carrying cost. The next one is shortage cost or stock out cost. Now, shortage cost is basically you are having the shortage of inventory. That means in your store, the inventory is not present. So due to the shortage of inventory, what cost you have to bear, what loss you have to bear, right? You might have seen that, let us suppose you want to purchase a Hayabusa bike, okay? So you are going to the, we can say, that agency, right, that outlet, showroom outlet, right? You went there, you are saying, I want to buy a Hayabusa bike right now. So will that person will be saying, will it be available at that moment? No, right? Fine. Exam है सर रिकॉर्डिंग तो हाँ बिल्कुल बिल्कुल कोई प्रॉब्लम नहीं है, कोई दिक्कत नहीं है. Fine. देखो, I know semester examination is going on, so don't worry, but try to see the session afterward also and try to clarify all the doubts that you're having. Okay. Coming back to this, you are going to purchase an Hayabusa, right? And you are going to a showroom. So will that showroom person will be giving you this Hayabusa at that instant? Chances are very less. Okay, chances are very less, right? So you'll be saying, I want it right now, or else I'll be going to the adjacent showroom and who is giving, we can say Bajaj Platina, I'll be purchasing that. Okay. So definitely you'll be saying, what you can do is, because Hayabusa is having a very good facility, just wait for 10 days, I'll be delivering you to your house. Okay. So there is some shortage that is being created, and that is shortage basically created to get the profit also. Because if you are keeping Hayabusa in your showroom, let's say I'm keeping 50 Hayabusas in your showroom, the cost that I have to bear will be very, very high. One Hayabusa will be costing around 80-90 lakhs, right? So 90 lakhs for one bike, 50 bikes, very high cost, near about to 45 CR. Okay, so in order to decrease that particular cost, I'll be deliberately keeping some shortages so that if a customer is coming, I'll be saying, okay, you can wait for 2 or 3 days or 10 days. I'll be delivering you after 10 days at your home. Right? So stock out or shortage cost is basically the absence of inventory, the loss that is being associated with not serving the customer. This is, we call it as the shortage cost. Now, here also, shortage cost is also a time dependent factor. One case shortage is happening for 10 days, second case shortage is happening for 1 month. In both cases, the shortage cost will be different. So here also, if you try to see, shortage cost is equal to average number of units short into shortage cost per unit per time. If you try to visualize this expression and this expression, almost we are having a similarity. Hai? If you try to visualize this expression and this expression, almost we are having a similarity. The similarity is the definition. The expression won't be same. In this case, expression won't be same. Slightly similar with the approach, but the expression won't be same, right? So we'll be having, when we'll be discussing the shortage model, they'll be taking this particular concept. Okay, so now let us talk about the EOQ models, or we can say the inventory model. There are two basic possibilities of inventory models. One is deterministic and second is probabilistic. What is deterministic? Very, very important. Deterministic model is basically, in this case, the demand rate will be constant. In this model, the demand rate and the lead time is constant. What is lead time? Let us wait for a while. Small d is the demand rate. Okay. So demand rate will be constant. What is demand rate? Demand rate is basically your rate of consumption rate. per day basis, weekly basis. Okay, if I say 20 units is required every day, so 20 will be the demand rate. Or if I say 50 units is required every week, so 50 will be the demand rate for weekly basis. So demand rate is nothing but, in case of deterministic model, this demand rate is always constant. Okay, fine, it is not having any variation. Fine, but in case of probabilistic model, which is basically a realistic model, in this case the demand rate is not constant. Now, demand rate, if it is not constant, it is a realistic approach, but still, in almost every live examples or every discussions, we are only concentrating on deterministic. What is the reason? Because there is one very important significance for this. You won't be having, let's take one example. Let's say today's target is 100 units you need to manufacture. Will the tomorrow's target will be 1000 units? No, right? You can have from 100 to 110 or 120 or 90 or 95 or maximum to 85. You can have that kind of variations. You won't be having a variations from 100 to 1000. Right? So we can say almost the demand is constant. That is the reason we always do the analysis on deterministic model in detail rather than probabilistic. Probabilistic is more realistic because demand rate can never be constant. If I say today is 100 units, after 10 years, will that the target will be 100 units? No, absolutely no. Right? Okay. So please, you have to understand that deterministic model is very, very important. And in probabilistic model, as the demand rate is not constant, so it is more sort of a real life or real world condition. Okay, fine. So as there is a variation is happening, so you need to carry a safety stock in case of probabilistic model. Why to carry a safety stock? What is safety stock? Let us suppose every day 10 units is required, but suddenly the units requirement is 15 days or 15 units. So what happened? At the near about to the last day, you won't be having the raw materials with you. So definitely you should be having some buffer stock or safety stock that will be used in order to deliver the products to the customers. Okay, so the concept of safety stock is very significant probabilistic, and in this case, no need to carry any safety stock because already we know the demand rate is constant. Okay, so let us start with the deterministic model. We'll be discussing all the 4 models, that is simple EOQ, EOQ with discount, manufacturing, and EOQ model with shortage. Okay, so let's start with what is EOQ? EOQ basically means economic order quantity. What is economic order quantity? Let us suppose I am denoting Q as the level of inventory. Inventory level or inventory, right? So let us suppose I'm taking 2 examples. Let us say, let us take example over here. Let us say I'm having an annual demand of 10,000 units. Okay, right? And the ordering cost for one order is rupees 100. Rupees 100 is the ordering cost for one order. Okay, there are 2 possibilities. One is you can have in one go, you can purchase all the annual demand in one go. Second possibility is you can purchase, you can have 1000 units in one go. That means for one order, you will be having 1000, and in one order, you will be having 10,000. So can you tell me, in this case, what will be the number of orders? In the case number 1, where I am procuring exactly the same annual demand as that of your number of orders. So what will be the number of orders? Anyone? Very good, Suchis. It will be 1. Sir, very easy. 10,000 is required. This is yearly. And I am procuring in one go. So number of orders will be 1. How we have calculated? So simple. D by Q. This is number of orders. And if I want to calculate ordering cost, that is number of orders into ordering cost. So from here I can calculate D by Q into CO. Yes. D by Q into CO, that is the total ordering cost. Over here, can you tell me what will be the number of orders? What will be the number of orders? Anyone? 10? Because 10,000 is required per year. In one order, you are procuring 1,000. So I can say D by Q, that is 10 orders you have to place in a year in order to completely fulfill our annual demand. In order to completely fulfill our annual demand, I need to place 10 orders. So what will be the ordering cost in this case? Number of orders into ordering cost, that is equal to how much? 100. So this will be 1,000 rupees. In this case, what will be the ordering cost? 1 into 100, that is rupees 100. Are you able to visualize one very important thing? That means if you try to increase the number of orders, your ordering cost is going to increase. And if you try to decrease the number of orders, the ordering cost will be decreasing. Very important point. Keep note of this. Okay. But once I said about the holding cost, remember, if you are holding for a smaller duration, or we can say lesser number of amount is if you are holding, and second case, larger amount or holding for a larger duration, which will be having a larger holding cost. Well, this will be having a larger holding cost, or this much amount will be having a larger holding cost. More quantity or less quantity? You're having a 60 crore diamond, we're having a 1 crore diamond. Which is more easily to hold, which is more easily to store? 1 crore diamond or 60 crore diamond? Definitely, sir. If you're having, yes, first case, sure, I'm having 10,000 units with me. I need to keep at least 3 to 4 rooms. I need to have 3 to 4 rooms in order to store this particular units. In second case, I need to have only 1 room sufficient. Let's say in 1 room 1,000 units you can store. So in this case, I can only have to rent only 1 room. Okay, fine. Is this clear? Right? So if you are increasing the level, or if you're increasing the inventory, the holding cost will be increasing. Can we say like this? Yes. If you are increasing the inventory, like in this case, when you have increased the inventory, your holding cost will also be increasing. Can we say holding cost is directly proportional to Q? Yes or no? In first case, the holding cost will be more. But if you try to visualize, in first case, ordering cost was less. In first case, ordering cost was less. That means if you try to increase the inventory, the holding cost will be increasing, but ordering cost will be decreasing. Yes? Yes? More order, more holding cost. More order cost is equal to more holding cost. No, it's not like this. It is different. Holding cost is different. Ordering cost is different. Okay? Exactly. I've not given that derivation right now, so that I'm not directly writing the formulation. What we can do is, we know that our holding cost is directly proportional to inventory. Yes? That means more the inventory, more will be the holding cost. So from here, there's a very important discussion that we are having, that if you try to increase the inventory, the ordering cost is decreasing, but holding cost is increasing. If you try to decrease the inventory, the ordering cost is increasing, but the holding cost is decreasing. That means I need to have an optimization between ordering cost and holding cost, and that is the concept of this one, economic order quantity. Is this clear? That is a concept of economic order quantity. So let's have a quick discussion of how to calculate the expression for holding cost and ordering cost, and then we'll be having the discussion for further models. Okay, so let us say I'm talking about economic order quantity or Harris-Wilson model, or we can say infinite replenishment model. Infinite replenishment model. Why we are saying infinite replenishment model? If you try to visualize, let us suppose I have inventory, I place an order, I have a maximum inventory. This is, we call it as the maximum inventory level. Okay, that we am denoting as capital Q. Maximum inventory level. Exactly. Correct, Jobin. Absolutely correct. If you're having more number of orders, ordering cost is gonna increase. But if you're having more number of orders, I have to keep less number of items. Less item means less holding cost. Simple. So let us suppose I'm having Q as the maximum inventory level, and this is the demand rate, let's say, or demand rate or consumption rate. We calculate as consumption rate, demand rate or consumption, all is having the same, which is denoted as small d. So with a constant rate, it is being consumed and it is becoming 0 at one point. And after that, again, the next inventory is coming and again, it is being consumed and going to 0. And this way, your basic EOQ model is being dealt with. In this way, the basic EOQ model is being designed. Now, if you try to visualize at this point, what is happening to the inventory? It is going from 0 to maximum. At this point, it is going from 0 to maximum. And what is the change in time that we're having? What is the change in time? That is 0. So can we say at this particular point, the change in inventory to change in time will be leading to infinity? Yes, because if I say the change in inventory to change in time at this point will be tending to infinity. Yes or no? Yes. Inventory is going from 0 to maximum. There is no change in time. So definitely this del Q by del T will be tending to infinity. And that is the reason we are calling this as infinite replenishment model. That is the reason we are calling this as infinite replenishment model. Is this clear? Okay. The reason why we are calling this as, because many students know about this, but some students don't know what is, sir, why we are calling this as infinite replenishment. Okay. Fine. So let us take one example. Let us say this is inventory level. We're having some inventory, let's say 10 units. Okay. Fine. Or 100 units. And with constant rate, it is decreasing. It's coming to 0. And again, it is increasing to maximum value. Right. And again, it is coming to 0. And this cycle will be repeated. This we call it as the cycle time. We call it as cycle time. Okay. Or time period. We can call it as cycle time, or we can say it is time period. Okay. Because it is repeated again and again. Okay. And it is consuming at some rate. Let us suppose small d is given as, let's say 5 units per day. So can you tell me after how many days our inventory will be coming to a 0 value? Can you tell me? If you're having 100 units with you, every day 5 units is being consumed. So after how many days this will be coming to 0? Yes, it will be simply, sir, it will be, we can say Q is equal to small d into capital T. Right? I can say that capital T is equal to capital Q by small d. So from here, I can calculate the value of T, which is coming out to be, I think, 20 days. Yes, 20 days. That means in 20 days, my inventory will be coming to 0. Clear? Now, the next question is, do I need to place the order on the 20th day so that I can get the inventory? It's not possible actually. It is not possible. If you want to place an order, you have to place before reaching the last day, right? So let us suppose I have said, okay, at this particular point, I'll be placing the order. So this is the point where I'm placing the order placed, right? And this is the point where I am receiving the order. Receiving order. Right? So that duration change in time when I'm placing the order, I'm receiving the order, this is, we call it as the lead time. This is, we call it as a lead time, which is denoted as LT. This is, we call it as the lead time. Okay. And definitely how we can understand lead time, there might be some certain level of inventory. There is some certain level of inventory at which I'll be placing the order, and that level of inventory, we call it as reorder level. The level of inventory at which I'm placing the order and I'm reaching this and the time duration between order being placed to the order being received, that is we call it as a lead time. Okay, so this is the level of inventory which I have to place the next order. Let us suppose I'm taking this particular value as 5 days. I'm assuming this as 5 days. So can you tell me after 15 days how much inventory will be left out? Because after 15 days, last 5 days. So tell me after 15 days how much inventory will be left out? Anyone? Tell me in the comment section. After 15 days, what will be the level of inventory at which I'll be placing the next order? Yes, we can have vice versa. Okay, 25 units left in hand. How you have calculated? Sir, it's very easy. What we can do is, if you try to calculate this particular time, whatever the left out time is 5 days. 5 into D is 5. So I'll be having 25 units being left out. So let us suppose if I want to calculate what is the level of inventory after 6 days. Can you tell me? What is the level of inventory after 6 days? Can anyone who can tell me in the comment section? After 6 days from the starting, what will be the level of inventory? Anyone? Simple question. After 6 days, what will be the level of inventory? 70. Okay. 70. Sir, very easy. Let's say this is 6 days completed. So whatever days being left out, that is 14 days. So we can say QX is equal to, let's say I'm taking this as TX. So I can simply say that D into TX will be giving us the level of inventory at any point of time. So I can simply say that this is 5 into what's the left out dates? 14. So this will be I think how much? 70 units. 70 units will be left out after 6 days. Is this clear? Yes. So this way you can calculate at any point what is the inventory level. For that you need to have the clarity what is the time period, what is we can say the demand rate. Okay, fine. So now let us try to visualize this expression one more time. So this is the reorder level. Okay, this is the lead time. So can we say reorder level can be written as lead time into demand rate? Can I write it like this? Everyone, can I write it like this? Reorder level is equal to lead time into demand rate. Yes? Okay, because this is the left out time. This is lead time. Okay, into the demand rate, that will be giving us the reorder level. Okay, so now let us try to have the expression calculation, how to calculate all the expressions. So let us draw over here and I'll be calculating the holding cost, the ordering cost, everything will be calculating over here. This is inventory, this is time, right? And this is your okay, this is maximum inventory level, that is Q. Fine, this is demand rate. And this is capital T. We have seen that. Let's start with the total cost. So total cost or total annual cost is equal to the summation of purchase cost plus ordering cost plus holding cost. Okay, if I want to calculate what is the total annual cost that I have to bear, it's the summation of purchase cost, ordering cost plus holding cost. So let's start with purchase cost. What is purchase cost? The annual demand into unit price. Already we have seen. Annual demand into unit price. What is ordering cost? Number of orders into cost per order. Now how to calculate number of orders? We have taken the expression example, that is annual demand by the inventory into CO. This is the annual ordering cost. This is all I'm talking about annual. Okay. This also I'm talking about annual only. Okay. Per year. Rupees per year. Now the challenge is, what is holding cost? Now let's say CH represents the holding cost per unit per time, right? CS represent your holding cost per unit per time. So if I want to calculate what is the holding cost for time period capital T. So the holding cost for time period capital T will be equal to average. Now, can you tell me in one time period, what is the average inventory level? Sir, it is going from Q to 0. So can we say Q average will be equal to Q plus 0 by 2, that is Q by 2. It is going from maximum Q to 0 value. So average value will be Q by 2 into CH into T, because I'm calculating for a time period T. So the holding cost for time period T is Q by 2 into CH into T. But I need to calculate for annual. Now tell me one thing. If you're having N as a number of orders, so tell me this time period T will be repeated how many number of times? If you're having total as N as a number of orders in 1 year, so this time period or the cycle will be repeated how many number of times? N number of times. So I can say the annual holding cost, I can say that the annual holding cost will be equal to Q by 2 into CH into T into N. Yes? Yes? Right? Right? Now, if I try to remember what is N, that is D by Q. Fine. Let us take an example. Let us suppose this is your, let's say this is equal to 1200 units, and it is being completed in, let's say, this is 10 days. Oh, 10 units per day. 10 units per day. So can you tell me what will be the magnitude of this particular time period? In how many days this will be completed? Simple question. Good afternoon, Malesh. I think you are having that exam, right? Semester exam going on. Okay. If you're having 1200 units, 10 units per day is the demand rate. So in how many days the inventory will be coming to 0, sir? Very easy. 120. 120. Right? 120 days. Okay. So this is 120 days. If I want to calculate for 1 year, D is equal to, how we have calculated? Sir, Q by small d. This is, we can say day per order. Right? If I want to calculate for entire year, how we can calculate? You can change this day into year by multiplying by 365. Yes? Okay. Or we can say dividing by 365. So if you're having QD into 365, what is 3 D into 365? Daily demand into 365. Can we say this is nothing but your annual demand? Daily demand rate, if you multiply it by 365, that will be giving you the annual demand. So capital T is equal to Q by D. Capital N is equal to D by Q. What is N into T? Always equal to 1. Always equal to 1. Always. It will always equal to 1. So now if you try to visualize, this is N into T equal to 1, and this way I am calculating the annual holding cost equal to Q by 2 into CH. Is this clear? Right? So the total annual cost that we are having is purchase cost plus ordering cost plus holding cost, that is D into C plus D by Q into CO plus Q by 2 into CH. So by this way, I can calculate the total annual cost for any particular product. at any lot size. Okay, but I think we were discussing about something about EOQ. And we were discussing about, sir, we were discussing something about where we'll be getting maximum profit. Here you are calculating for any lot size. Okay, let's do one thing. For economic order quantity, what will the total annual cost? The total annual cost will be minimum, right? Or we can say the differentiation of total annual cost with respect to Q will be equal to 0, right? Now, we'll be doing this derivation after some time, but let's try to have a discussion over here. Is there any cost which is independent of inventory? Is there any cost in this total annual cost which is independent? Like how much will be the inventory level? It doesn't matter. It will be having the same value. Yes. In this purchase, ordering and holding cost, is there any cost you can see on the screen which is independent? Yes, sir. Which one? Which is independent of Q? Ordering cost is having Q, right? Holding cost is also having Q. But if you see the purchase cost, it is not, it is independent of inventory. So I can say that total annual cost is equal to purchase cost plus total inventory cost. Total inventory cost. Or we can say total variable cost. Okay, we can, instead of using TIC, we can use TVC also, that is total variable cost. Because this two costs, ordering cost and holding cost, is only depending on the inventory size. Okay, so now let us try to differentiate. So when I try to differentiate, we'll be having minus, this will be 0, minus the D by Q square into CO plus CH by 2 equal to 0. So Q square is equal to 2D CO by CH. Next page, let's try to write Q is equal to 2D CO by CH root of this. So this is the amount of inventory that you have to keep in order to have the minimum price. And as we are talking about economic order quantity, so we always write star as the symbol to represent the economic order quantity. Okay, fine. Is this clear? So economic order quantity, this is the level of inventory at which the cost will be minimum. So let us calculate the total inventory cost, right? That is equal to ordering cost plus holding cost, right? That is equal to D by Q star into CO plus Q star by 2 into CH. When you place this value, you will be getting this TIC star is equal to root of 2D CO CH. 2D CO CH. So I can say that the total annual cost at EOQ is equal to the purchase cost plus the total inventory cost at this, or I can say TAC star is equal to D into C plus root of 2D CO CH. This, all the discussion that we are doing is at EOQ. At economic order quantity, we have calculated now how to calculate the total cost. Total annual cost is the purchase cost plus the total inventory cost at EOQ. But if I want to calculate at any lot size, okay, if I want to calculate at any lot size, this will be for any lot size. That is except EOQ, you will be getting this. But if you try to visualize this particular expression, okay, and if you try to plot this graph, what I'm seeing that ordering cost is D by Q into CO and holding cost is Q by 2 into CH. So if you try to plot based on the cost versus inventory, you are getting a direct relation for holding cost and you are getting a inverse relation for a ordering cost. Okay, and when you try to plot for the total cost, this will be the total cost. This is Q star, and it is being seen that at we can say this is your economic order quantity. At EOQ, the holding cost and ordering cost is exactly same, because at this particular point I'm getting this cost to be minimum. Right? So I can say that if I try to have at economic order quantity, ordering cost is equal to holding cost, that is D by Q into CO, Q by 2 into CH, rearrange Q is equal to 2D CO by CH root of this. So now you can easily visualize what is basically happening is you can define the economic order quantity by two perspectives. Either you can differentiate the total annual cost, get the expression, or what you can do is you can have this particular very interesting direct relation, that is at economic order quantity, ordering cost and holding cost is exactly same, that we are able to visualize in this particular graph also. Okay, is this clear? Fine. And except EOQ, if there is no EOQ, then you have to use this particular simple direct formulation. If there is no economic order quantity, then you have to use this. If there is economic order quantity, then you have to use this expression. Okay, so for EOQ, we have now got to a very conclusive expressions, that is 2DCO by CH. This is very important because all other models are dependent on this particular expressions. We'll be using directly or indirectly this expression in the other models also. Is this clear? Fine. Understood? Now, let us try to have a very important discussion. The second important, fine, this already we have seen. This is your economic order quantity, right? This is your economic order quantity, that is EOQ. Okay, fine. Is this clear? So now let us talk about the second model. Anyone having any doubt in this basic EOQ? It's very easy, direct, straightforward. The second model is your discount model, or we can say price breakup. What is discount model? You might have seen that sometimes when you're going to a mall, you have seen that if you purchase 2 jeans, you'll be getting 3 jeans free. And if you're purchasing 5 jeans, you'll be getting 10 jeans free or 10 t-shirts free. Have you seen this kind of bonanza or offers in malls? If you purchase 2 jeans, 3 jeans you are getting free. If you purchase 5 jeans, you'll be getting 10 jeans free. Yes, sir, we are getting some time. That means your unit price is gonna change. There will be some ranges of order size where unit price is gonna change. So here you have to have a clarity. In this case, what happens? There will be some range of a particular this one. Like if I say this particular order size, if the order size is less than 500, the unit price will be 10. If order size is greater than or equal to 500, then unit price will be 9. So I need to calculate what will be the minimum order size. What should be the order size so that my cost will be minimum? What should be my order size so that my cost will be minimum? So that is particular your discount model. Okay, let us suppose if I try to plot, let's say this is one range. For first range, the EOQs we are getting like this. In second range, I'm getting a curve like this. In third range, I'm getting a curve like this. Okay. But if you try to understand, if you want to have a better clarity, let us do one thing. Let us take one example and try to understand from this example what is a discount model. Let's say consider the following data of an item. Annual demand is given. Ordering cost is given. Now, always remember that your holding cost is always a percentage of unit price. Okay, if it is given directly, it's okay. But if it is not given, it's always, you have to understand that it is always some percentage of unit price. If you see over here, they are saying this is 25% of unit price. So if CH value is changing, right? If your unit price is changing, then your CH value is also changing. If the CH value is changing, then definitely your economic order quantity will be changing for the different ranges, right? So let us do one thing. They are asking what is the optimum quantity in units. So let us take the first one, because definitely this is having a lower unit price. So let us say when the order size is greater than 500 with a unit price of rupees 9. Okay, let us do the calculation. Let's see what will be happening. Q star is equal to 2D CO by CH. Okay, this is 2 into annual demand is 2500 into CO is 100. CH is 0.25 of 9. So can you tell me what is the value that we are getting? After solving this, I think this is the third chapter. PERT CPM completed, break-even analysis completed. This is the third chapter going on. After this, we'll be taking a break. Okay. Then we'll be starting with forecasting, linear programming. Now, can you tell me what's the value? Approximately 470 or 480. What's the value you're having? Anyone who has calculated? Yes. 2 into 2500 into 100 by 0.25 into 9. This will be somewhere around. Anyone? Yes. 471.4. Very good. 471.4. Okay. Now let's try to visualize. What is happening? You are taking the unit price for greater than 500 and you are getting an EOQ for less than 500. Is that possible? This is not possible, right? Because if you want to use 471, your unit price won't be 9. It should be 10 rupees. Okay. So this is not feasible. This is not feasible. This particular discussion is not feasible. Okay. So let's do one thing. Let us take the second range, upper range, right? So when you are having Q less than 500, then your unit price is rupees 10. So in this particular perspective, let us calculate the EOQ by CH. 2 into 2500 into 100 divided by 0.25 into 10. Are we getting in a feasible range? Very good, Sharma ji, very good. 447.27 units. Okay, and this is actually feasible because I was discussing about a range less than 500. I'm actually getting a value which is less than 500. So this is feasible. Okay, this is feasible. So let us calculate what's the total cost that will be occurred. Purchase cost plus total inventory cost at EOQ, because this is I'm talking about economic order quantity. So purchase cost is D into C plus root of 2D COCH. So annual demand is 2500, unit price is 10. Okay, plus root of 2 into 2500 into 100 into 0.25 into 10. Somewhere around you'll be getting 27,000 or 26,000. You'll be getting 25,000 plus this value. Somewhere around you'll be getting 26,000 or 28,000. Can anyone who can tell me in the comment section? Very good, Malesh. We are getting 26,000 something. 118. Okay. Chalo, perfect. Hai? So technically this should be the minimum value, hai na? But let's have a cross checking. If I try to order exactly 500, what will be the total cost for safer side? Okay, for safer side, let us do one thing. Let us calculate when you are ordering exactly 500 units, what is the total annual cost? Now, in this case, do I need to use the formulation of D into C plus root of 2D COCH? Do I need to use the formula which we are using for EOQ over here, or the general formula that we have to use in this particular calculation? Anyone? To calculate this total annual cost, do I need to use EOQ or general formula? You have to use the general formula because this is not an economic order quantity. This is any lot size. This is any lot size, right? This is not economic order quantity. So this will be your D into C plus D by Q into CO plus Q by 2 into CH. So 2500 into 9 plus 2500 divided by 500 into CO value was, ordering cost was 100, right? 100 plus 500 divided by 2 into 0.25 into 9. So can any one of you can tell me what is the total price that we will be having when I'm ordering 500 units? Is it coming greater than 26,000 or less than 26,000? It should be somewhere around, I think, 23 or 24,000. Can anyone who can tell me? 2,500 into 9 plus this will be 500. This will be 250 into 0.9 into 9. Perfect. 23,562. So we are having a total price of, now if you try to visualize what is happening, in case of first range, when the EOQ was feasible, I was having a total price of 26,118. And when we were having at the limiting value or the threshold value, I'm getting 23,000. So definitely my order size or optimum lot size will be, exactly 500. This will be your final answer. This will be your final answer. Why? Because at this point, I'm getting the lower value. I'm getting 23,000 as the total cost. But in the previous case, I'm getting 26,000. So the optimum lot size will be 500 units. So let us try to plot the graph and why this kind of situations happen. If I try to understand from the graph perspective, let's say this is your inventory and this is your cost, right? Let's say I'm taking the first range. In first range, EOQ was feasible. In the less than 500, EOQ was feasible. So if I try to draw, it will be having a feasible range like this. This is for first range, it was coming out to be 447.27. 447.27. Okay. Now for second range, as the price was dropped, as the price was dropped in the second range, and it was having an EOQ of, it was having an EOQ at 471, which is not feasible. So it will be having price drop over here. This is 500. Okay. And if I try to plot the graph, it will be something like this. This is the final graph that we'll be having. Because for the second price range, my EOQ was somewhere around 471. Which was not feasible because for the second range, my threshold value was 500. And that is the reason I was getting a lower value over here as compared to this. This is 26,000. This is 23,000. Is this clear? Fine. If let us suppose in the first range, if EOQ was defined, if let us suppose this was greater than 500, then that would have been the final answer. No need to check at any other point. No need to check at any other point. So this kind of EOQ models, we call it as the discount model. Okay. This kind of EOQ models, we call it as a discount model. Done? Okay, understood why this situation happened? Why we are having EOQ not defined for the first range? Because it is coming less than 500, which is not feasible. For the second range, it should be greater than 500 or equal to 500. So that is the reason when I try to plot the graph, for the first range, it was feasible, which is 447. Second range, it was 470, which is not feasible. And if I try to plot the graph, I'm getting the minimum value, which is at 23,000. Is this clear? Okay, so this is all about your discount model. This is all about your discount model. Is this clear? If this is clear, then we'll be going for the manufacturing model, then the shortage model. Then we'll be taking a break. Okay. Half an hour more. I had a plan 2 o'clock tak we'll be completing inventory. So I think we are right on track. Okay. Chalo. Now let's talk about the next model, that is your production or manufacturing model. In this case, we are not procuring inventory from outside. We are manufacturing from inside. So here I will be having some production rate. I will be having some production rate. And I'll be having some demand rate or consumption rate. Consumption rate, also we can say demand rate. Okay. So let us try to understand from graph first of all, then we'll be taking up the relations. Let's say this is inventory Q and this is your, this is time. Okay. Now, let us suppose I'm having a production rate of 15 units per day. Okay. So my consumption rate will be greater than 15 or less than 15. If I'm manufacturing every day 15 units, so my consumption or demand rate will be greater than 15 or less than 15. What should be our clarity? What should be our idea in this? What should be the demand rate? Will it be more than 15 or less than 15? What is your call on this? Obviously, sir, less. Because if you're having a more than that, then how you will be fulfilling the customer needs? If the demand rate is, let us suppose 20 units and you are only manufacturing 15, then you will be having a shortage always of 5 units. Okay. So we always try to manufacture more than what is required. So let us suppose I'm taking 10 units per day basis. Okay. Fine. So let us suppose I am manufacturing. So I'm manufacturing, or production is happening with some production rate, right? Fine. And it is being produced for some small duration only. This is the production time, right? And this is the production rate with P. Now every day, let us suppose if 15 units is being manufactured and 10 units is being consumed, so every day how much units you need to hold or you need to store? If 15 units is the manufacturing rate and 10 units is the consumption rate, then every day how many units you need to store? Sir, 5 units? Yes. 15 minus 10, every day 5 units you need to store. Yes. Understood? Yes, everyone. Write in the comment section, yes or no. 15 units you are manufacturing, 10 units you are consuming. So definitely every day 5 units will be stored. So every day 5 units will be stored. So we'll be having one point, we'll be reaching some maximum value. Okay. So let's suppose this is your, let us suppose this is your daily storing rate. This is P minus D. By this amount, the inventory storage will be happening and will be reaching some maximum value. And after this, as there is no production going on, only consumption is going on. So if I try to have the graph, this is the consumption rate. So actually, you don't need to store Q value. You have to store less than that. So this is your maximum inventory level, which let us put denoted as QM. This is the maximum inventory level that you have to store at the end of the production. After this, whatever you have stored, that will be self-sufficient to fulfill the customer demand at the next cycle. And this way, this cycle will be going on. So if I try to draw now this particular graph one more time without having this dotted line, it will be something like this. Okay, we'll be having P minus D, will be having D, right? This is your production time. Okay, and the next cycle again like this, and this way your complete production manufacturing model, production model will be going on. Okay, and this is, we call it as the maximum inventory level, that is known as QM. Okay, so now if you try to visualize, let's say this is Q. So if I am manufacturing at a rate of P, if I'm not consuming, after TP will be having this much amount of inventory. Let us suppose if I'm not consuming, if I'm only doing the production, so can we say Q is equal to P into TP? Yes, P into TP, that is Q. And also we can say that QM is equal to P minus D into TP. Yes. Yes, anyone having any doubt how we have written this expression? It's very simple. Let us suppose I'm having production at, let's say I'm doing production for 10 days. So after 10 days, how many units will be stored? It will be 50 units. After 10th day, you'll be having 50 units with me, right? And that 50 units will be consumed because after 10 days, I'm not having any production going on. So we are having 50 units that will be consumed daily basis and will be coming to zero. Okay, so these expressions are very important because in gate examination, now talk about examination perspective, they're going to ask you a question, what is the maximum inventory level? Okay, QM. They'll be giving you a production rate, demand rate. They'll be asking you what is QM. If you take the ratio, QM by Q is equal to P minus D by P. So if you know the production rate, if you know the this one, you can easily calculate the maximum inventory level. Okay, this type of question is repeatedly asked. But let us try to have a EOQ model perspective. So now in this case, the total annual cost will be having purchase cost, because there will be some inventories, there will be some raw materials that need to procure. We will be having setup cost, will be having the holding cost. Now, if you remember, when we were discussing setup cost, I told you setup cost and ordering cost both are having the same formulations. So I'll be using the same formula that I've used over there. So I can say that D into C plus D by Q into CO plus now comes with the holding cost. We need to calculate what will be this holding cost, because here now the maximum inventory level has changed. Earlier it was Q, so it was very easy, Q by 2 into CH. Now it is QM. So if I want to calculate the holding cost for time period T, that is QM by 2 into CH into TP. Okay, fine. Yes? That will be for complete T. That is for complete T, because you are holding the inventory maximum this till the entire duration of time. This is your capital T. You are holding the inventory not for only TP, you are holding the inventory for entire duration, because slowly the inventory you are holding reaching the maximum value and coming to zero. So the average inventory will be QM by 2, right? Average inventory will be QM by 2 plus CH into T, right? So now the problem is we are having QM over here, but one thing I know that QM by Q is equal to P minus D by P. So from here I can simply say that the holding cost for time period T is equal to Q by 2 P minus D by P into CH into T. This is for one cycle. This is for one cycle. I need to calculate for entire year. How many cycles we are having? Will be n number of cycles. So now I can say the annual holding cost will be equal to Q by 2 P minus D by P into CH into T into N. And what is N into T? Already we have seen this is always equal to 1. So now the annual holding cost is equal to Q by 2 P minus D by P into CH. So from here I can say for any lot size, let me write it in the next slide. For any lot size, your total annual cost is equal to P, or let me write it directly, the formulation. The purchase cost, that is demand into unit price, setup cost, that is D by Q into CO plus Q by 2 into P minus D by P into CH. Okay, this is the total annual cost. Now here also we can do the analysis of as an economic order model. We can take the same concept. What you can do is, at economic order quantity, the total annual cost, if you differentiate with respect to Q, should be equal to 0. Let us differentiate. So when you differentiate, I'll be directly writing the expression. Okay, you'll be getting Q star is equal to 2D CO by CH root of this into root of P upon P minus T. This is the economic order quantity that we are getting in the production model or built up model. So if you try to rewrite the same thing, if you want to rewrite this, I can say that at EOQ, Q star is equal to 2D CO by CH into P upon P minus D root of this. So tell me, this particular factor that you are seeing, is it less than 1 or greater than 1? This factor that you are seeing, the additional factor, because this is the only addition thing. In the previous one, we were having only this much. So is this greater than 1? Yes. Is this particular factor that you are seeing, P upon P minus D, is definitely greater than 1? Okay, so this is your production model. So can we say that the Q star for the production model is definitely greater than that of the Q star for the basic EOQ model? Okay, so from this particular analysis, we can surely say that production-based model is having a better profit-oriented approach as compared to the basic EOQ. And this particular factor, very good, Sharma ji. So this factor that you are seeing, which is greater than 1, we call it as production factor. We call it as production factor. Okay, this is, we call it as a production factor. Is this clear? This is, we call it the production factor. Now similarly, I need to calculate the total annual cost at EOQ. Okay, let's calculate that also. Or let's say the total inventory cost at EOQ is 2D COCH root of this into P upon P minus D कभी कभार ऐसा हो जा. It will be P minus D divided by P root of this. And definitely if you try to visualize, this will be less than 1. This is less than 1, right? So how to remember this? I know that economic or production model will be having a better profit oriented, it will be better model as compared to the basic EOQ. So Q star will always be increasing. And if I try to calculate the TIC star for production, if I try to compare with the TIC star for the basic EOQ, it will be having a lesser value. Yes? Because this factor is now less than 1. P minus D divided by P is a factor which is less than 1. So from this particular expression, how to remember? Simple. EOQ mein factor will be multiplied which is greater than 1. Cost mein you have to multiply with a factor which is less than 1. Simple. Clear? Fine. The production based model. Okay, so now, and this is for only EOQ. If I talk about at any lot size, this is for any lot size. The total variable cost or total inventory cost, both are same. Right? Is this clear? The production based model. Fine. So now let's proceed with the last one, that is the shortage model. Okay, now let us talk about the shortage model. Now in shortage model, what we are actually doing is we are deliberately going for a shortage. It's rather a good thing to have some inventory in the stock rather than it's rather a good thing that you should be having a shortage of inventory rather than keeping that inventory for that particular duration. Okay, so there will be some time period in which I'll be keeping negative inventory. Negative inventory means I'm not having inventory with me. So if I try to draw the graph, we'll be having a graph something like this. Okay, this is one cycle. So from this point to this point, there is, let's say I'm taking this T1. From this point to this point, this is T2. So T2 is the time in which the inventory is kept short. Inventory is kept short. So if I try to take this as total as capital Q, this as capital Q, this as a shortage, let's say this is capital S, right? And this as the maximum inventory level, that is M, that is equal to Q minus S. Here the maximum inventory level won't be, because here I'll be including some shortage value also, because I need to have, if you try to forget about this shortage model, if you try to shift this x-axis over here, this will be exactly similar to your basic EOQ model. If you try to shift this x-axis over here, then it will be something, a very similar approach. If I try to say this is your basic EOQ model, Anna, this is your basic EOQ model, right? Basic EOQ. Now, if I want to have the shortage model, I'm just shifting this x-axis over here. So if I want to shift this, this is the x-axis I'm shifted. So there will be some duration of time where there will be some shortage happening. So T2 represents the amount, or the, we can say time during which units being short. Okay, units being short. Okay, and T1 is the actual, we are having the stock in stock. Okay, fine. T1 is the time duration, this is the time in which the units is actually present, and T2 is the time in which there is a shortage of unit. So here, if I try to understand, now we will be having the total annual cost equal to purchase cost, ordering cost, holding cost, shortage cost. Okay, now we'll be having one more additional cost, that is your shortage cost. Fine. You'll be having one shortage cost also being added over here. Okay, so now if I try to write, for other expression is simply D into C plus D by Q into CO plus now for holding cost and shortage cost, that we need to calculate. Now we know that, if you remember, holding cost and shortage cost was having exactly same formulation, average inventory into CH for some time period. Your shortage cost was average unit short into CB. CB is basically the back order or unit, we can say shortage cost per unit time. Okay, fine. So if I want to calculate now what is the holding cost, so if I try to draw the diagram, this is your diagram. This is your next cycle. So this is your one cycle T, this is T1, this is T2, this is your maximum inventory, this is capital Q, and this is the units inventory, that is short, capital S. So if I want to calculate the holding cost, now to calculate the holding cost, tell me you are actually holding the inventory for which duration of time? In one cycle, can you tell me, in one cycle, you are holding the inventory for which duration of time? Is it for entire T, or only T1, or only T2? Only T1, perfect. Because after T1, there is no inventory. There is no inventory. This is negative. There is no inventory. So can we say the holding cost for T time period, for one time period, I'm holding for only T1 time. So can we say the holding cost for the time period T is equal to maximum inventory is M by 2 into CH into T1. Yes, M by 2, because maximum inventory is M coming to 0. So M plus 0 by 2, M by 2 into CH into 1. But I need to have the formulation in terms of Q and capital T. Okay, let's do one thing. We know that what is M? M is equal to Q minus S. Chalo, what we can do is, it is Q minus S by 2 into CH into T1. But I need to remove this T1. I need to have an expression in terms of capital T, because I always try to calculate in terms of a cycle. So if I try to take capital Q, and this is your demand rate, can we say that capital Q is nothing but D into capital T, and your we can say Q minus S is equal to, Q minus is this one. This is your Q minus S. Okay, so Q minus S is equal to D into T1. So from here, can I say T1 is equal to, or T1 by capital T is equal to D, it equal to, we can see Q minus S divided by Q. Okay, so placing this value of T1 over here, we can simply say that Q minus S whole square by 2Q into CH into capital T. This is for one time period. For annual holding cost, what will be that? Annual holding cost will be equal to Q minus S whole square by 2Q into CH, because N into T will always be equal to 1. Okay, so if I go back, I can write it down very easily. Q minus S whole square by 2Q into CH. Plus, now let us talk about the shortage cost. Now, to calculate the shortage cost, right, I need to have a important introduction of a very interesting segment, that is CB, which is the shortage cost per unit per time. Okay, so now if I come back to this particular diagram, the shortage is happening in one cycle. Shortage is happening only for T2 time. Shortage is happening only for T2 time. So can we say that the shortage cost for a time period T is equal to S by 2 into CB into T2? Yes. S is the average unit short. Maximum is S. Here we are having a 0. Here we are having 0. There we are having S. So average inventory is that is being short is S by 2. So S by 2 is the average inventory into CB into T2. So similarly, if I try to use the same concept as like over here, so I can simply say this is S square by 2Q into CB into capital T. So from here, now I can calculate the annual shortage cost. The annual shortage cost will be equal to S square by 2Q into CB. So from here, if I try to place it, we'll be having S square by 2Q into CB. Actually, in the examination, they are not asking question from this, but you should be having a clarity what is shortage model. So here also, this is the total annual cost. So here also, at what we'll be doing for EOQ, what we'll be doing? The differentiation, right? So directly writing the values, because it will be very difficult to differentiate right now. So Q star is equal to 2D CO by CH into your CB plus CH by CB root of this. Okay, CB plus CH by CB. This is your total economic order quantity for the production shortage model. And if I want to calculate the TIC star, it will be equal to root of 2D CO CH CB upon CB plus CH. So this way, now you can easily calculate for a shortage model what is the total inventory cost at EOQ, what is a we can say economic order quantity, that is under root of 2D CO by CH into CB plus CH by CB. Okay, fine. Is this clear? Okay, so this basically winds up our inventory model in short. Then we'll be going with sequencing, right? So we'll be going with sequencing model. Then sequencing will be going for forecasting, linear programming. S star, M star. Yes, one more thing. S star and M star. Yeah, thank you for that. Now, sometimes we need to calculate what is the optimum number of units back ordered. Optimum units back ordered. Okay, fine. That means you need to calculate the value of S star. So we can say Q star minus S star into CH is equal to S star into CB. So if I try to divide this, we'll be having Q star by S star is equal to CB plus CH by CH. So from here, I can say S star is equal to Q star into CH by CB plus CH. Okay, fine. Now if I want to calculate M star, simple, M star will be equal to Q star minus S star. You can place this S star over here, so we'll be getting ultimately CB will be CH will be cancelling out. So Q star into CB upon CB plus CH. So this is the maximum optimum inventory level that we'll be having. This is your units that need to be short. So sir, value of S shorted doesn't come anywhere on the formula. Yes, it is coming, S is coming, right? If you try to visualize this one. Yes, acha, this S value in that particular, no, it won't be coming. It won't be coming because when we are solving, right, it will be cancelling out. When you are solving, when you are trying to take the differentiation of that, then it will be cancelling out, right? If you take, if you try to differentiate, many parameters will be cancelling out. So we are basically going for the final relation. Okay, fine. Right, so this is all about our shortage model, very rarely being asked, so don't worry about that. But basic EOQ and production model is very important. Among all these models, 4 models that we have discussed, basic EOQ and production model is very, very important. Try to have the quick revision of that. I think that is being seen. So now let's take, what's the time? 2 o'clock. So we are on time, I think. Okay. So बिल्कुल planning के हिसाब से we are going. So 2 o'clock, I think optimization is going on. Okay. So 2 o'clock we had a discussion that we will be taking. So we'll be taking a break of 15 minutes. More than sufficient. After 15 minutes, we'll be starting a very important topic of linear programming. Okay. Sequencing, the linear programming, forecasting, queuing model, transportation, assignment. 7 topics left out. So I think 15 minutes will be the optimum time. Exactly. Chalo. So let's meet. Let's take a break of 15 minutes. Okay. And let's meet exactly at 2:15 p.m. Okay. Let's meet at 2:15. Fine. बिल्कुल on time चल रहा है. बहुत सही है. So in this way, I think by 6-7 o'clock we'll be winding up the session. Okay, so let's meet at 2:15. Exactly 2 o'clock हो चुके हैं. So 15 minutes break. So let's meet at 2:15 and discuss about the next segments. Okay, so till then, quick. आप लोग भी जल्दी से have a quick lunch. Okay, or you can go and have a quick brunch. I think some of the students, if you have not done your breakfast, तो उनके लिए. Okay, so let's meet at 2:15. 15 minutes break. Then we'll be back with the same energy. Okay, चलिए. Bye bye. Okay, so I think 2:15 हो गया. Yes. Okay, so I hope so everything is good with audio and video. Yes, okay, so we are back on track. Let me check. All good. Yep. Okay, so please tell me in the comment section, all good, all perfect, so that we can continue our discussion. Yes. Raghu, Sujesh, Manas, everyone. Okay, so now let's start our discussion. It's 2:16. I hope so. 2:16 or 2:15? It was 2:16, right? 2:16. So now we are back on track. Okay, so let's hello, welcome back. We had a quick lunch break. 15 minutes काफी था, I think. Okay. So now we'll be starting with the next topic, that is sequencing. After that, we'll be starting linear programming, then forecasting. This way, we'll be gradually increasing our pace. Okay. So now let's talk about a very easy topic because lunch break के बाद थोड़ा सा easy बनता है ना? After lunch break, what happens? Students is having some laziness, वो tardiness वाला effect आता है ना? Let's include that tardiness, okay, or lateness after this lunch break, so that we can back on track, and after that we'll be going for the linear programming. Fine. So now let's talk about the next topic, that is the sequencing. Sequencing. Okay. 1 second, guys. Okay. Sequencing. Now, sequencing is basically what is happening. We try to arrange the set of jobs, or we try to arrange the different jobs in such a way that our machines will be having lesser idle time. Because what happens if I say there are 3 machines, okay, in which one machine is sitting idle for let's say 10 minutes, second machine is sitting idle for 15 minutes, and third machine is sitting idle for 25 minutes. So it is not justified that you will be giving same salary to all the 3 operators who is running a machine, and the person who is sitting idle for a longer duration, it should be minimized, right? So in this particular concept of sequencing, what we try to do is we try to minimize the idle time as soon as possible. We try to minimize this idle time, right, and try to optimize the utilization of any particular machine. Okay, we try to utilize the optimization of any particular machine, but what happens is if you're not utilizing, then what happens, some machines will be having excessive amount of load, or some machines will be working for a larger duration, and some machine will be working for only small portion of time. Okay, because some machines will be having a larger idle time, some machines will be having a low idle time. In this way, you cannot optimize our functioning, because every machine should be working with its full capacity. Whether it's working for even 5 minutes also, it should be working for full capacity without having any idle time or minimum idle time, because it's not practically feasible that you'll be having 0 idle time. Okay, in practical analysis or practical perspective, you cannot have 0 idle time. So by using this concept of sequencing, we try to minimize the idle time and we try to optimize the working of any machinery. So in this particular segment, we try to calculate these 2 segments, that is idle time and the utilization. So how we will be proceeding, how we'll be doing the sequencing? In sequencing, what we try to do, we try to arrange the activities in that order in which you will be having the minimization of this and the maximization or the optimization of the utilization. Okay, this is our objective. So in this particular sequencing, there are some terminologies that we should be knowing. So let us discuss one by one, and after that we'll be going for the this one, the methods for sequencing. There are some rules or assumptions that you need to follow. If nothing is mentioned, like if I say if nothing is mentioned, then the processing order will be same as that for machine will remains constant. That means if I say if you are working in order of 1, 2 and 3, there are 3 machines which is having a sequence of 1, 2 and 3. First 1, then 2, then 3. If no rule is being mentioned, then you have to follow the same rule. That means first of all machine 1 will be working, then machine 2, then machine 3. If any rule is being mentioned, then you have to use that particular rule. Okay, so same things mentioned, that if nothing is mentioned, then you have to take the same sequence as mentioned in the question. Remember one thing, only one job will be working at one time. Okay, if I say one machine, on one machine at a time only one job will be working. It's not like two jobs are working in a single machine. Okay, one job on one machine, and once the job is being complete, once the job is being started, it should be fully completed. It's not like this, so thoda kar lete, thoda baad mein karte hain. It's not like this, so thoda sa topic today will be covering, thoda sa topic tomorrow will be covering. Arey nahi, will be covering the entire topic in the entire stretch, one single stretch. Okay, so once our discussion is started, once the job is started, it should be fully complete. The time taken from one job to another job, from shifting from one job to another job. If I say there are 3 machines, okay, there are 3 machines, right? Bottleneck operation. So if I take this as a raw material, it will be going into this machine 1, it will be having some processes, then same raw material will be going over here, then will be going over. So the shifting the raw material from one point machine to another machine will be negligible. Okay, time taken by the job from one machine to another machine will be negligible, and at the end, irrespective of any order, whatever processing time is being taking, it will be saying. If I say on machine 1, this raw material is taking, let's say 5 minutes. Okay, so if you are going to machine 1 at the end also, it will be simply taking 5 minutes. Not like this. If you change the order or sequence, the processing time will also be changing. It's not like this. It is independent. Whatever order you are having, the processing time for any activity will always be remaining the same. So now there are some terminologies that we should be having. The first one is your job flow time. What is job flow time? Job flow time is nothing but, let us take one example. Let us suppose I'm having 3 activities, activity A, activity B and activity C, and it's taking the processing time of activity A is 2 minutes, this is 5 minutes, and this is 4 minutes. Okay, and there is a raw material which is coming, right? So it will be starting, it will be going to machine A, it will be doing some operation, so it will be coming out after 2 minutes. So same raw material will be coming over B. So can you tell me what will be the in time for the raw material at machine, or we can say at job B? What will be the in time for that raw material at the job B? Can we say that will be starting at 2? It will be starting at 2, 5 minutes processing time, and be coming out at 7. Right? It will be starting at 2, 5 minutes as a processing time in 7. And if I talk about the C, it will be starting its activity at 7, doing the process 4 minutes, then we are having 11. Okay. So if I want to say what is the job flow time of activity or job B? Job flow time is the time from some starting point till that particular job is completed. So can we say job number B, how much time it is taking? It is taking 7 minutes to complete. Yes. Can I say after 7 minutes, job number B will be completed? Yes. Or I can say, if I talk about activity C, what is the completion time for activity C or job flow time for activity C? That is 11 minutes. Is this clear? That means after 11 minutes, job number C will be completing its process. So that is, we call it as a job flow time. Then what is make span time? Make span time is one set of cycle from starting to the ending. How much time it is taking, that is your make span time. We can say it is a time from when the processing begins till the first job in a set until the last job is being completed. That is make span time. So here, can we say in 11 minutes, your entire one set of job will be completed. So this is, we call it as a make span time. Okay, this is, we call it as a make span time. Right? Fine. After this, we are having a very interesting segment, that is tardiness. What is tardiness? We can call it as lateness also. That means it is the amount by which a job is being delayed by its due date. Now, for that, you should be having understanding of what is due date. Let us suppose, there's an activity A. It is taking, let's say, 4 minutes as its processing time, and it should be completed with a due date of 6 minutes. Okay? Activity B, it is taking 5 minutes and it should be completed in 7 minutes. So you'll be saying, sir, every time every job will be completed before its due date? It's not like this. If you take this example, let us suppose I'm taking the due date for individual processes or individual jobs as due date is, let's say 3, it's let's say 6, 4 hai, so let's take it as 7. Okay, so tell me, job number A we need to complete within 3 days, and we are taking how many days or how many minutes? Job number A supposed to be completed in 3 minutes. How many minutes we are taking to complete? Sir, we are taking only 2 minutes. It's not a delay job. It's not a tardy job. It's not a tardy job because job number A is completed in 2 minutes. It should be supposed to be completed in 3 minutes. Okay, sir, perfect. Talk about job number B. Job number B is completed in how many days? How much minutes? What's the time duration for completing job number B? It is taking actually 7 minutes, but it is supposed to be completed in 6 minutes. So is activity B or job B a tardy job? Is it delayed job? Yes or no? Yes, sir. It is the delayed job. Why? Because it was supposed to be completed in 6 days or 6 minutes, and you are completing in 7 minutes. So it is being delayed by, it is having a tardiness value of 1 unit, minute or days, whatever they are giving. Okay, fine. Discuss about job number C. Now, job number C, it was supposed to be completed in 7 minutes. I'm completing in 11 minutes. So it is being delayed by 4 minutes. Is this clear? So by this way, exactly. So we are having a tardiness of 4 minutes. So can we say how many jobs are tardy job? Out of 3, how many jobs are tardy job? Anyone? Out of A, B and C, how many jobs are tardy job? The tardy jobs are, sir, job number B and job number C are the tardy jobs. So number of tardy jobs will be 2. If I ask you, what is the total tardiness? Total tardiness will be 1 plus 4, 5. 1 plus 4, that is 5. 1 minute in job number B, 4 minutes in job number C. So total tardiness will be 5. Okay, clear? It's a very easy segment. It hardly takes 5-10 minutes. Now next is, what is the average number of jobs in the system? What is the meaning of this? Let's take an example to understand what is happening when a raw material is entering A job, it will be taking 2 minutes. After that, it will be going and entering B. So what happens once A job is being completed? After this, we'll be having some raw material number 2 that will be entering the system. And after 7 minutes, this first raw material will be going to job number C, right? And the second raw material will be entering B. So what is this? Definitely. I'll be coming to that average tardiness, right? Let us try to understand what is this average number of jobs. So average number of jobs in the system is, on an average, one set of job is completed, how many number of jobs are present in the cycle or in the system? That is, we call it as the average number of jobs in the system. It is nothing but the number of jobs present all time within the system until one set of job is completed, and that is, we call it as the average number of jobs in the system. And how we can calculate this? We can calculate this by using the ratio of total job flow time divided by the make span time. Total job flow time divided by the make span time. From that expression, we can easily calculate what is the average number of jobs in the system. So now a question arises, sir, how we can calculate average tardiness? Okay, because there are some terms that you need to understand which is being expected in your examination. So let us take one example. Let us try to take one example, and from that example, we'll be calculating every single unknown parameters. Okay, fine. First of all, we'll be understanding that, then we'll be calculating every single processes. Now, in sequencing, there are three particular possibilities. One is you are having a one machine and n number of jobs. Second possibility is we're having 2 machines, n number of jobs. Or we can have 3 machines, n number of jobs. So we'll be taking one by one different cases, and we'll be talking about these individual conditions. So first is the sequencing rules when you're having n number of jobs and we're using only one machine. Okay, that means we're having a machine, and in this we're having number of jobs, 1, 2, 3, 4, like this. Okay, so this particular analysis or this particular sequencing, we can have 4 different types of sequencing rules. In order to have the sequencing for n jobs on one machine, we can use any one of the rules. One is shortest processing time, second is earliest due date, third is your critical ratio, and fourth one is slack time remaining. Let us discuss quickly one by one, and we'll be taking an example and try to calculate what is average tardiness, what is average job flow time, what is your total average number of jobs in the system. Everything will be calculating. Okay, by taking one example. What is shortest processing time? What we'll be doing, we'll be arranging in the increasing order of processing time. That means whatever activities we are having, whatever jobs we are having, and number of jobs we are having, we'll be sequencing according to the increasing order of the processing time. Okay, that is your SPT rule. Second one is earliest due date. In this case, we'll be arranging in the increasing order of due date. Okay, that is earliest due date. Sir, ठीक है, बहुत easy है sir. What's the new thing about this? Okay, critical ratio. It's a ratio of due date divided by processing time. We will be arranging in the increasing order of critical ratio. And the last one is slack time remaining. That is the difference between due date minus processing time. You have to arrange in the increasing order of slack time remaining. Okay. So what we will be doing, we'll be taking, because SPT and EDD are more important, we'll be taking one example from each, right? And we'll be understanding what is the major difference between SPT and EDD. So let us take one example on your screen, this one. Let us take SPT rule. So tell me quickly, we're having 5 number of jobs. So according to SPT rule, what will be the sequence that you need to follow? You have to arrange in the increasing order of processing time. So here we are having processing time for job number 1 is 4, job number 2 is 5, 3 ka 3, 4 ka 7, and 5 ka is 2. So what will be the sequence quickly? 5, 3, 1, 2, 4. Perfect. 5, 3, 1, 2, 4. Okay. Clear? You are just arranged in the increasing order, right? So let us do one thing. Let us draw this particular job and processing time. This is job flow time. This is tardiness. I think this is being okay. Tardiness. Okay. And here we'll be writing the due date. So what is the sequence? 5, 3, 1, 2, 4. Right? This is the sequence that we are having. Processing time for activity number, job number 5 is 2, 3, 3 ka 3 and 8. 1 is having 4 and 6. 2 is having 5 and 7. And 4 is having 7 and 10. Okay. So let's begin our completion of this table. Now, job flow time basically means how much time it is taking to complete that activity. That's it. So first job will be, this is the first job, will be starting at 0 time. 0 plus 2, that is equal to 2. Can you tell me what will be the job flow time for job number 3? It will be starting at 2. 3 minutes will be the duration. 2 plus 3 is 5. Next, 5 plus 4, that is equal to 9. 9 plus 5, that is equal to 14, and 14 plus 7, that is equal to 21. Hai na? Let me write it over here. Plus 7, that is 21. Okay, fine. Are we getting these values? Perfect. So now let's start understanding which job are tardy jobs. Let's start with first job, that is job number 5. Is it a tardy job? Yes. Is this a tardy job? Yes or no? Try to see. Is this a tardy job? It was supposed to be completed in 3 minutes. I'm completing in 2 minutes. Sir, not a tardy job. No. No. You can put a dash, you can put a hyphen, whatever you like. Next one. Job number 3. It is supposed to be completed in 8 minutes. I'm completing in 5 minutes. Again, not a tardy job. I'm completing. We can say earliness. We can here, instead of using tardiness, we can use a word as earliness. So we can say the earliness for job number 5 will be 1. The earliness for job number 3 will be, we can say 3. Okay. So opposite of tardiness is earliness. So now let's talk about this. Job number 1. It is supposed to be completed in 6 minutes. It is taking 9 minutes. So it is being delayed by how many time? So 3 units. Okay. Yes, 3 units. It is supposed to be completed in 7 minutes. We are taking 14 minutes. 7 units. Supposed to be completed in 10 minutes. Taking 21 minutes. So 11 units. So in total, what is the total time? 10, 20, 21. So this is your total tardiness. This is your total tardiness. Okay. This is the total tardiness. And how many jobs are the number of tardy jobs? If I want to write the number of tardy jobs, number of tardy jobs will be, sir, job number 1, job number 2 and job number 4. There are three jobs which are tardy jobs. There are 3 jobs which are tardy jobs. Perfect. 1, 2 and 4. 1, 2 ka 4. Acha, 1, 2, 4. Okay, fine. Right, and can you tell me what is the make span time? What's the make span time? This is our make span time. This is our make span time. 21. Perfect. देखो, best part is in single machine, if you try to add the processing time, it will again coming out to be 21 only. A small technique. If you add the processing time of every job, it will be exactly coming out to be 21. So this is only applicable for single machine. Multi machines will be having some different analysis. There we have to use this particular segment. Okay, so that is why normally I don't say that add processing time will be adding make span time. It's only applicable in single machine. In multi machine, that is not applicable. Okay, so now, so we have calculated total tardiness. Can you tell me what will be the average tardiness? What will be average tardiness? Anyone? Average tardiness. So total is 21 divided by the number of jobs. Number of jobs is, now they're having, some students do have confusion. So do I need to take divide by 5 or divide by 3? Students do commit mistake over here. You have to divide by the number of jobs. Total tardiness is 21. Divide by the number of jobs is there are 5 number of jobs, right? Do not divide by 3. Let us suppose if in a class there are 10 students, right? 7 students are having 100 out of 100 and 3 students are having 0 marks. So if I say, okay, what is the average of the marks? So will I take the total score or only the score of the 7 students? Definitely I'll have to take the total score and total number of students, right? So here also average tardiness will be the total tardiness, that is 21, divided by the total number of jobs. There are 5 number of jobs. 4.2. So what is the meaning of this word 4.2? 4.2 units. Let's say I'm taking in days. So on an average, every job will be delayed by on an average of 4.2 days. The basic meaning of average tardiness is every job will be delayed by 4.2 units per job. Okay, is this clear? Now let us calculate what is the average number of jobs in the system. How to calculate average number of jobs? Sir, we have to take the total job flow time. It is nothing but you have to add all the job flow time divided by the make span time. Let us calculate. Can you tell me what is the total? 2 plus 5, add. 2 plus 5, 7, 7 plus 9, 16, 16 plus 14, 30, 30 plus 21, 51. Are we getting 51 as a total job flow time? Yes, please check. बहुत बढ़िया. I'm getting some answers. Very good. So 51 divided by 21. So approximately 2.42. Perfect. So that means on an average, one set of job is being completed, 2.42 number of jobs will always be present in the system. Understood the fundamental or meaning of this word 2.42? Okay. Understood? And this you have to calculate in sequencing, in single machine. Right? So this is your SPT rule. Anyone having any doubt? I don't think so you should be having, because we have taken up the discussion of very difficult topics. So these are very small topics, easy topics. Yes, okay. So this was SPT rule, right? Now, if I talk the same discussion with EDD rule, what we have to do? Yes, you need to take the sequence according to the increasing order of the due date. If I talk about the EDD rule, you just need to take the sequencing according to the increasing order of the due date. Can you tell me what will be the sequence? According to earliest due date, okay, let us take the sequence by using earliest due date. 1, 2, 3, 4, 5. What will be the sequence? 5, 1, 2, 3, 4. 5, 1, 2, 3, 4. Yes? 5, 1, 2, 3, 4. Okay. Here I was getting 5, 3, 1, 2, 4. But in using EDD, I am getting 5, 1, 2, 3, 4. What changes we will be expecting in the final answer? Let's see. This is due date 5, 1, 2, 3, 4. 2, 3. 4, 5, 3, 7. 7, 8. So 6, 7, 8, 10. Perfect. Okay, so we have written in the increasing order of the due date, right? So let us calculate quickly the job flow time. 0 plus 2 plus 4, 6 plus 5, 11 plus 3, 14, and 14 plus 7, that is 21, and this is your make span time. This is your make span time. Is it a tardy job? Not a tardy job? Not a tardy job? Yes, it's a tardy job, and the total tardiness is, I think, 4. It is a tardy job. 18, 4, that is 6. It is a tardy job, that is 11. So total is 21. So here I'm getting the average tardiness as 4.2, and let's talk about the average number of jobs in the system. In the system. So this is total job flow time divided by the make span time. Add 8, 19, 29, 33, 33 plus 21. Yes. Exactly. What's the total value? Job flow time? 54? Yes. Are we getting 54 value? Yes or no? No? Okay. Huh, 54. Yes. So now we can calculate this as 54 divided by 21, which is coming out to be 2.57. 2.57. Now, if I'm using the SPT rule, I was using SPT rule, I was getting 2.42, but when I was using EDD rule, I'm getting 2.57. So in case of EDD, it is being observed that the average number of job flow time in case of EDD will be more than that of SPT, right? Average tardiness, I think you are getting the same value over here, 4.2. 21 divided by 5, that is 4.2. So you have to understand a very important point. I'll be writing over here. If you want to have minimum tardiness if you want to achieve minimum tardiness, you always be preferring EDD rule. You cannot get tardiness less than that which we are getting in EDD rule. Like in this case, we are getting the same value, 4.2 and 4.2, right? But it is being observed that if you want to have minimum tardiness, you will be preferring EDD rule, and if you want to have minimum job flow time, okay, minimum average number of jobs in the system, jobs, right, in system, or total job flow time. If you want to have minimum total job flow time, if you want to have minimum average job flow number of jobs in the system, you will be using SPT rule. Okay, very important, keep in mind, because sometimes what happens, they are not giving which rule you have to follow. They'll be saying that what is the minimum value of tardiness. So from that perspective, they are giving a very important information that if they are using this word minimum tardiness, you have to use this EDD rule. And if you are saying that what is the minimum average number of jobs in the system or minimum job flow time, then you have to go for the SPT rule. Is this clear? Fine, very important. I think rest is very easy. Now you can go for CR and STR. There is no special significance of CR and STR, but yes, if I talk about EDD and SPT rule, because these two are only there in your syllabus, but we have to have an understanding what is CR and STR. Okay, this is all about single machine. But what will happen if you're having two machines? If you're having two machines, then what will happen? But here we are not having a concept of due date. Here we'll be having only the processing time being given. So in this kind of scenario, when you are dealing with two machines, then you have to use a very interesting rule, that is Johnson's rule. Johnson's rule. What is this Johnson's rule? It is very easy. If the minimum value, you will be identifying the minimum value. If the minimum value is lying in the first machine, then you will be allocating that particular job from the left hand side. Okay, you will be allocating that job from the left hand side. That means first position will be given to that job which is having minimum value of job flow time if it is lying in the first machine. And if it is lying in the second machine, then you have to allocate from the right hand side. Clear? Understood? Rule understood? Okay, so can we do the sequencing right now? Let's do the sequencing. Can you tell me, among all these, which job is having the least processing time value? Among all these which you are seeing on the screen, which job is having the least processor? Here we are having two jobs which is having the least value. One is job number 3 and one is job number 6. Okay, no problem. But you have to see job number 6 minimum you are getting in first machine. So you have to allocate from the left hand side, strike off that. And as it is in the second machine, so you have to allocate from the right hand side, strike off that. Clear? Next, next minimum is 3, which is in the second machine. So we'll be allocating from the right hand side. And please make sure whenever you are allocating, now after allocating, try to strike off that because you are not reallocating that. Okay. Okay. 4. First machine 1. 6, 2, and 5. So this will be the sequence 6, 1, 2, 5, 4, 3. 6, 1, 2, 5, 4, 3 will be the sequence by using this Johnson's rule. Is this clear? Everyone, please write in the comment section. Yes. Perfect है. Okay. If this is clear, so क्या गेट में यही पूछेगा? नहीं यार, no. They will be asking. They can ask this for 1 mark, but if they want to ask for 2 marks, they can ask you question like this. So what I'll be doing, I'll be sequencing the job according to
the Johnson's rule. Okay, let's say this is machine number 1, right? And this is the job flow time. This is machine number 2, processing time of machine number 2. This is processing time of machine number 1, and it's job flow time. Okay, chalo. So the sequence that we obtained is 6, 1, 2, 5, 4, 3. 6, 1, 2, 5, 4, 3, right? 6, 1, 2, 5, 4, 3. And for 6, we are having 1 and 10. 1 and 10, right? For 1, we are having 4 and 5. For 2, we are having 6 and 8. For 5, we are having 9 and 6. For 4, we are having 8 and 3. And for 3, we are having 7 and 1. Chalo, perfect. So we have completed the table. So let's do one thing. Let's calculate the job flow time. Now, first raw material present over here. It will be entering the system. Job number 6 will be processed. How much time is taking? 1 minute. 0 plus 1 equal to 1. Now tell me, this is job flow time for machine number 1. This raw material will be entering machine number 2. What will be the starting time? Will be entering at 0 minutes or will it entering at after 1 minute? Same raw material, machine number 1, after that entering machine number 2. Exactly. It will be entering after 1 minute, right? 1 plus 10, that is 11. 1 plus 10, that is 11. Is this clear? So now, as machine number 1 is free, he'll be saying, "Arey aane do, next raw material." So it will be coming, right? So let us suppose this one, 1. So it will start process 1 and it will be doing processing for 4 minutes, 5. Because machine number 1 is free after 1 minute, so we can process any other raw material that we have to process job number 1. So 1 plus 4, that is 5. So tell me, can I start the operation after 5 minutes? For machine number 2, can I start after 5 minutes? Yes or no? Sir, no sir, because machine number 2 is occupied till 11 minutes. You cannot start before 11 because one job at a time. So you have to start this particular job after 11 minutes. 5 minutes will be the processing time, 16 minutes. Machine 1 बोलता है सर 5 minutes में मैं free हो गया. 5 plus 6, 11. Machine number 2, 16 minutes plus 8, 24. Okay. Machine number 1, 11 plus 9, 20. Machine number 2, 24 tak he is doing the work. Will be going for the next job after 24. 24 plus 6, 30. 20 plus 8, 28. 30 plus 3, 33. Next, 28 plus 7, 35. Now, tell me, what will be the starting time for that job in machine number 2? What will be the starting time of this particular job in this particular sequence? Exactly. It will be 35. Why? Because it is coming after 35 minutes from machine number 1. 2 minutes free बैठते हैं. 35 plus 1, that is 36. So this is your make span time of this particular sequencing. So 36 minutes is by make span time. So here, sir, we cannot calculate this one, tardiness. We cannot calculate average job length. Then what we have to calculate? Here we are actually calculating the idle time. So idle time for any machine is nothing but the make span time minus the processing time, the total processing time. We call it as working time. You can call it as total processing time or working time. Okay, or instead of working time, we get as total processing time. Total processing time. So by this relation, we can calculate the idle time for any machine. Okay, so if I want to calculate, what we can do is let us add For machine number 1, what is the total processing time? Can we calculate this value? Can tell me? This will be 10, 11, 20, 28 plus 30 plus 7. 35? Yes. Go with machine number 2. 15, 23, 29 plus 4, 33. Are we having this particular value? Please check. 35 and 33. Perfect है. आज वर्कआउट हो जाएगा आई थिंक. 8 घंटे कंटिन्यूस सेशन बहुत दिनों बाद. Okay. Earlier we used to have sessions 8, 9 hours continuous stretch. तब नहीं होता था. After COVID we are having once in a year or twice in a year. Okay. Chalo. So now if I want to calculate what is the idle time, what's an idle time for machine number 1, that is equal to make span time is 36 minus processing time for machine 1. Machine 1 processing time is 35. So it is 1. So that means machine number 1 will be sitting idle for 1 minute. Let's try to identify. According to formula, we are able to get 1 minute, but try to justify that over here. Okay. Starting at 0, 1, 1 to 4, 5 to 6, 11 to 9, 20. So there is no idle time, but if you try to see, after 35 minutes, it is sitting for 1 minute idle time because our entire cycle will be completed after 36 minutes. Our entire cycle will be completed after 36 minutes. So we are having 1 minute of idle time for machine number 1 at the last job, that is job number 3. Okay, fine. So we can say the idle time for machine number 1 is 1 minute. Let us calculate the idle time. Idle time for machine number 2, that is equal to 36 minus processing time is 33. So it is having 3 minutes of idle time. Let's try to identify, sir, where we are having 3 minutes. Can anyone who can tell me where we are having 3 minutes of idle time for machine number 2? Anyone? कौन से जॉब में will be having first and last? Okay, second last I think na, first and second last. Acha, between second last and last. Okay, so let's start. If you try to see, machine number 2 is starting its operation after 1 minute, so it is having a delay of 1 minute over here, idle time of 1 minute. 11, 16 starting, 24 ending, 24 starting, 30 ending, 30, 33, array 35. We're having a 2 minutes of idle time. So total 1 plus 2, 3 minutes is the total idle time. I think that is the same value that we are getting. Okay, is this clear? So by this way, now we can calculate the idle time for any machine by using the same value, same relation MST minus the total process time. And there is one more thing that you can calculate, that is utilization. That is utilization. What is utilization? It is nothing but the total of processing time divided by the make span time into 100, that will be giving in percentage. Remember when I started the sequencing, I told you we need to minimize the idle time and optimize the your utilization. The same thing we are doing. So if I want to calculate what is the utilization for machine number 1, that will be equal to processing time was 35 divided by 36 into 100, 90 something. For machine number 2, 33 divided by 36 into 100. What's the value? For machine number 1, 97.22. So our machine number 1 is 97.22 effective. Okay. And what about this one? 91.6. कोई FM है क्या? 91.6. 98.3 होता है. Okay. Okay, fine. Fine. So machine number 1 is having a utilization of 90. That means I'm utilizing machine number 1 97.22. ठीक है यार, इतना चलेगा. We can have 97. more than 90, good value, right? 91, ठीक है, no problem. Fine, is this clear? So we are able to utilize this machine 1 and 2 97% and 91% individually. By this way, now we are able to understand what is the importance of using this sequencing. If you are not sequencing, you can take it as an homework. If you're not doing the sequencing, and then if you try to calculate the idle time and utilization, you'll be seeing that it is having a huge value difference. It might be possible that machine 1 will be having a idle time of let's suppose 5-10 minutes. Machine 2 will be having an idle time of 15-20 minutes. Okay, you can do it at your home, not now, because we are having 3 बज गए, है ना? Right? Fine. Is this clear? So this is all about 2 machine. Sir, what will happen if you are having a 3 machine? Where is the 3 machine? कहाँ गया? अच्छा, वो लिखा ही नहीं है. कहाँ गया? अच्छा, चलो. What will happen if you are having a 3 machine and jobs on 3 machine? Okay, we can have maximum up to 3 machine, not more than that. If we're having n number of jobs on 3 machine, that means we are having machine number 1, machine number 2, and machine number 3. Okay, and there are some jobs 1, 2, 3 till n, right? And definitely individual machines will be having some individual processing time. So in this case, you cannot which one will be taking? Minimum of 1 or 2 or 3. So it's not possible to apply the Johnson's rule over here. So in order to apply the Johnson's rule, there is one condition that we need to be fulfilling. That is the minimum of machine 1 should be greater than equal to the maximum of machine 2, or the minimum of machine 3 should be greater than equal to maximum of machine number 2. Okay, if either one of the condition is being satisfied, then what we can do is we can club these 2 machine, and I can assume as machine A and this as machine B, where machine A is nothing but the summation of M1 plus M2, and machine B is a summation of M2 plus M3. That means I have converted my 3 machine job into a 2 machine job, and after I'm getting this value, now I can do and apply the Johnson's rule. Okay, fine. Is this clear? So here minimum of either one of the condition need to be satisfied. Minimum of 1 should be greater than equal to maximum of 2, or minimum of 3 should be greater than equal to maximum of 2. Right? Let us take one example. Let us take one example over here. Let us take one example. Let us take some arbitrary values. Let us try it. And any one of the conditions should be fulfilling. Okay. Let's say I'm having A, B, C, and D. 4 jobs, right? And its value over here is let's say 2. This is 4. This is 3, right? This is let us take it as 5. This is 6, 2, 5, 7, 1, 4, and 9, 3, and 4. Okay. So what I have taken is I have taken some random values. That is job A, machine 1 processing time, machine 2 processing time, machine 3 processing time. So check whether either one of these conditions is being satisfied. Okay. Let's check the first condition. The minimum of 1 is 4 should be greater than equal to maximum of 2. Maximum of 2 is this. Condition 1 is satisfied, sir. No need to check condition number 2. No need to check condition number 2. If you want to check, you can check also. minimum of machine number 3 is 3, है ना? Definitely it is not, then so this condition not satisfied, no problem. At least one condition should be satisfied. Okay, so first condition is satisfied. Now what we'll be doing, I'll be converting this 3 machine into 2 machine. So I'll be taking 2 arbitrary machines A and B, right? Or let us say X and Y, because A and B we are using for job. Okay, we can take X machine and Y machine. So X is 4 plus 4, 8, 6 plus 2, 8, 7 plus 1, 8, 9 plus 3 is 12. Y is 4 plus 7, 7, 6 and 7. So we have converted our 3 machines into 2 machines. Now we can apply Johnson's rule very easily. So let's apply the Johnson's rule over here and let's try to understand how sequencing can be done. So 4 jobs, 1, 2, 3, 4, right? So tell me what will be the minimum value? Which job will be assigned first? This is job A, job B, job C, job D. Which one? Apply Johnson's rule, because now we have converted 3 machines into 2 machines. So because the minimum is lying on the second machine, right? So definitely I'll be having C at the end. Okay. Then we're having 7. Now here, if you try to visualize, next minimum is 7. Now 7 is present in all the 3. So whenever you are having this kind of situation, what you have to do is you have to check the corresponding value of the second machine. Like in this case, as 8 is the minimum, so you'll be preferring A or B, because these two are same. So what you can do is either you can take A or B, or you can take B or A. Both way it is correct. And last, D, because it is having a larger value, because I'm talking about this, so we're having D. So final sequence will be D, B, A, C, or D, A, B, C. Okay. The final sequence that you'll be getting is D, B, A, C, or D, A, B, or C. Is this clear? Understood? Done. So this way we have seen how we can convert a 3 machine into 2 machine. Now the Johnson's rule that we are doing now, it is only for this operation that we are doing is only for to get the sequence. That's it. Once we are getting the sequence, now what we'll be doing, I'll be using machine 1, machine 2, machine 3, in of machine 1, in of machine 2, in of machine 3. So I'll be writing that, I'll be using this table. This is only used to arrange the sequence. That's it. Now the role of this table is completed, not required. This is also not required. Okay. Now this will be my focus. This is the sequence. Arrange jobs in this sequence. Write the processing time in that sequence. Calculate the idle time and utilization. Okay. Perfect. So this completes your sequencing operation. We have completed the sequencing operation. So now the next topic, the most important, I think, kaun sa hai? Okay, linear programming, one of my favorite topic. Right? So now we'll be starting with the linear programming. Okay? Linear programming karke forecasting, then transportation, then assignment, queuing model. So I think by 7 o'clock it will be completed. We'll be taking 1.5 hours at max to complete linear programming if everything goes in that same menu, same pace, right? Okay, so kare start. MRP, dekho, we'll try. MRP ka, if time is allowing, we'll be going for that, right? But at least I can tell you the basic fundamental how to solve the question. Okay, bill of material wala. Lean is a theoretical topic. For lean ke liye, I would take one additional session for that. It's completely theory. Kanban cards ka one question they can expect from lean, right? So MRP and lean, if time agar allow karega, we'll be taking, or else we'll be taking in any other session. Okay, fine. But majority will be completed. Don't worry about that. Fine. Because lean, if I take, it will be completely theoretical. It will be like I'll be reading the slides or I'll be explaining you some examples, right? So don't worry. If time allows, we'll be going for MRP and lean collectively both. So now let's talk about linear programming problem, LPP. Many students are having the doubts in this topic of linear programming, right? Many students do have huge number of doubts, sir. How to calculate infinite solutions? Simplex are very difficult. I'm getting fever every time I'm studying simplex method. Don't worry. I'll be giving you a simple method how to understand the simplex method, okay, by taking one example. Okay, so let's start with linear programming. Now, what is linear programming? In this case, what happens? We're having a huge set of solutions. Okay, I'll be having a huge set of solutions. In that huge set of solutions, you need to identify what is the best solution. And that is your linear programming. And as the name suggests, this is a linear one. So I won't be having a parabolic equation. Okay, or I won't be having a quadratic equation, or we can say a hyperbolic equation, exponential equation. We're only having equations which are linear. Fine. So among all the set of values, let's say I'm having set of different values. So in this set of different values, which value is the best value? So that identification is your linear programming. And this is a very important and effective tool. Is there in slides? No, Sujesh, it's not in there. Okay. But I'll try to manage that to get you that. Okay. I'll be giving you in Telegram also. Linear programming, lean manufacturing. If you require, I can go and send in that. Same goes with MRP. Okay. Chalo. So now let's talk about linear programming. As we know that from all the set of values, I need to identify the best solution. That is the linear programming. Now, basically linear programming is, if I talk about linear programming, there are two possible approaches. One is your graphical approach, and second is your simplex approach. One is graphical and second is simplex. Now, how to understand, sir, when to apply graphical and when to apply simplex? Tell me one thing. If you want to plot a graph, how many variables you require? A 2D plane, definitely in a 2D plane. There's a graph paper. So how many variables you require to plot a graph? The two variables x and y. That's it. If you want to plot a graph, you always take x and y axis, or x1 or x2. So whenever I'm dealing with two variables, I have to, or I must be using graphical. But if you're having more than two variables, then I'm bound to use simplex. Understood? If you're having variables like x1, x2, x3, so there are three variables we are having. So there I am bound to use simplex method. Why I'm saying bound to use? Because simplex is an iterative process or iterative method. What is the meaning of this word iterative? Iterative means you might have remembered when you're in third year or in final year, you're having one subject of programming where you are writing the codes. You run the code and that code will be running in a loop till you are getting that optimized value or the best value. What it does, it runs the code, it gets a result, it checks whether it's an optimum. If not optimum, again it will be running. One iteration done. Again running the code, getting one value, whether it is the optimum value. No, again your iteration. So iteration is a step-by-step calculation. So definitely, sir, exam mein iteration process is not possible, hai na? But they can ask you in between the iteration what's the value of objective function that will be defining right now. Okay, in examination from simplex method you can get, but they'll be giving you a table. They'll be saying whether this solution is we can say optimal solution or not. So you need to understand how to identify. So that for that you need to solve one question at least from this topic. So LPP will be having graphical and simplex. And if I say special cases, if I talk about special cases of LPP, we are having transportation and assignment model. We're having transportation and assignment model as the two important special cases of linear programming, right? So let's begin an LPP. Now in linear programming, there are basically three requirements that you should be fulfilling. One is objective function, second is constraint, and third is your non-negativity criteria. What is objective function? Objective function is basically the equation or the function which we need to maximize or minimize. And normally it is being denoted as capital Z. Let's say I'm talking about profit. So what is our intention? Should I go for minimization profit or maximization of the profit? What should be our objective towards profit? Anyone? How to proceed? Whenever I'm talking about profit, sir, we always talk about maximization only. Whenever I'm dealing with profit, we always talk about maximization. Whenever I'm talking about losses, so I always deal with minimization. Okay, so this objective function is nothing but the function which we need to maximize or minimize. That could be profit also, that could be loss also. If I talk about profit, that is a maximization problem. If I talk about loss, that will be a minimization problem, right? So now the second requirement is the constraint. What is a constraint? It is a restrictions. In that restriction only, in that boundary, you have to identify the best solution. If you're not having a boundary, right, then how you can identify the best solution? Let's say if I say there are best solution like this, set of solution. There is some solution here also. You can have infinite number of solutions. So you need to have a fine restrictions or boundary, then only you will be able to identify the best solution. If there is no boundary, if there is no boundary to identify the best solution, then you won't be able to calculate the best value. Every time you'll be getting a new best value. Okay, if there is no limitations, right? If I say, if there is no limitation of the syllabus, every time the examiner could ask any question from any topic. So for that, they are defining the boundary by specifying the syllabus. So that boundary, that is basically called as constraint. So under that constraint or condition, we need to identify the best solution. That is your LPP. And last one is non-negativity criteria. Non-negativity means we can never ever manufacture negative product. That means if I say, today I have to manufacture minus 10 units of this pen, is that practically feasible? You cannot manufacture a negative value. You always have either 0 or more than that. So always remember that variables will always be greater than equal to 0. Okay. So these are the 3 different conditions that should be fulfilling in order to solve any linear programming. Let us take one example to understand the graphical method. We are having a question on your screen. So Z, we are saying about maximization. Okay, maximization Z, 2x1 plus 5x2, right? And tell me, can we solve this question by using graphical? Can we solve this question by using graphical? Yes, definitely, because there are only 2 variables, x1 and x2. Is there any x3 value being given? No, right? You cannot, you can definitely use this question, and you can use the graphical approach to solve this problem. Okay, there is no x3 value, right? So what you have to do is, always remember, this is the objective function. These are the 3 constraints. These are the non-negativity criteria. So whenever you are having this kind of situation, always try to convert this into intersect format. Intersect format means I can write this equation number 1 as x1, let me write it over here, x1 by 40 plus x2 divided by 40 divided by 3 is 13.33. 13.33 less than equal to 1. Yes, I can write the second equation as x1 divided by 8 plus x2 divided by 24 less than equal to 1. And I can write the third equation as x1 by 10 plus x2 by 10 less than equal to 1. So what I've did is I have just converted the 3 constraints into intersect format. Why I've did like this? Because it's very easy to plot the graph when you are writing the equation in intersect format. x1, x2. We are having 48 and 10. So let us take 10, 20, 30, 40. Graph should be very, it's not like you should be having equal gap. You can have any rough graph like this. And x2 is 13.3 and 10 tak ja raha hai, so we can take 5 gap, 25, 20, 15, 10, 5. 5, 10, 15, 20, 25. Okay, so let's talk about the first constraint, 40 and 13.33. So if I talk about 40 and 13.33, this is 40. 13.33 will be lying somewhere around here, right? This is 13.33. So just join this 2 points. It's a straight line, right? Yes, perfect. The straight line. And now they are saying that you have to take all the values less than 1. So whenever you are having a less than equal to, you have to understand that you have to take all the values which is towards the origin. So you have to take all the values towards origin. This arrow will represent that you are taking all the values which is towards the origin. The second one is 8 and 24. X1 is 8. So let us take 8 over here and 24 over here. Okay. So 8 and 24, something like this. Less than equal to constraint number 2. This is constraint number 1. Third constraint is 10 and 10. 10 and 10. Black color. This is 10. This is 10. We can take this. Okay. So if you try to visualize, I'm getting a curve. I'm getting a region which is satisfying all the conditions. This is, we call it as feasible region. This is, we call it as a feasible region, right? And it is being seen that at corner points, very good. I'm getting some answers. So I'm taking all the corner points. This is A, this is B, this is C, and this is D. So identify the coordinates of the corner points. A is at origin. We can write A as 0, 0. B is at this point. The coordinate of B will be 0, 10. C will be at this point. Now, C is an intersection of which 2 points? C is an intersection of equation number 2 and equation number 3. So, let us see what is equation 2 and equation 3. This is equation 2 and equation number 3. So, it is 3x1 plus x2 is equal to 24 and x1 plus x2 is equal to 10. So, if you try to subtract this value, we'll be having x1 is equal to 14, that is 7. And x2 will be equal to 3. So 7, 3 is the coordinate of point C. 7, 3 is the coordinate of point C. Talk about point D. Point D is having a coordinate of, it is on the x2 axis. 10 is the coordinate, so 10, 0. So we have find out all the coordinates of the corner points. So let us calculate the objective function at the corner points. 0 and 0, 0. ZB 5 into 10. 50, ZC 14 plus 15, 29, ZD 20. So I have calculated the objective function at all the corner points. Oh, sorry, this is point D, 8, 0. Yes, thank you. 8, 0. Yes. है ना? 8, 0. This is the point, right? Not 10. This is the region. So 8, 0, that will be 16. Still not having any impact on this. Okay, fine. So we have got all the corner points and all the objective function. And if you clearly see that the maximum value you can observe at point B. This is the maximum value, right? So I can say the function, this particular linear programming is having the maximum value at point B, having a coordinates of 0 and 10. That means I can say that, write it in the next slide. Optimum value or optimal value of objective function is coming out to be 50. And at which point I'm getting at x1 equal to 0 and x2 is equal to 10. This is my optimal solution. But if you try to visualize, very important thing, that the constraint number 1, this blue one, is this having any significance to identifying this feasible solution? If you try to remove this particular blue constraint, will my final solution will be having any impact? Yes. If you try to eliminate this blue constraint, will this region that I'm obtaining over here, will that be changing? No, right? So these are type of constraint which is having no significance. These type of constraint we call it as redundant constraint. These type of constraint we call it as redundant constraint. Is this clear? These type of constraint we call it as redundant constraint, which is having no significance. उसका होना ना होना एक बराबर. We call it like this ना. वो हो या ना हो, no problem. I will be always be getting this as a final value. Right? So this type of constraint we call it as redundant constraint. Okay, clear? So now second important discussion that we are getting is I'm getting the solution, final optimal solution at only one point. That means this is a unique solution. I'm not getting at multiple points, 50, 50 like this. I'm getting 50 at only one point. The maximum value I'm getting at one point. This is a unique solution. But if you try to visualize very important point here, if I want to get maximum, because this is all we are talking about profit only, right? This was profit. Z was nothing but profit. So in order to achieve profit, your one of the variable is having a zero value. Can you imagine that situation? That one product is not giving any input to get the maximum profit. So whenever we are having any kind of situation like this, when one of the variable is having a zero value, this kind of situation, we call it as degenerate solution. So this solution is a unique degenerate solution. Okay? Because in order to get the maximum profit, you are not even depending on x1. x1 is equal to 0. To get maximum profit, you are only relying on x2 variable. Then only we can get maximum profit. So whenever you are getting this kind of situation, when one of the variable is having a zero value in the optimal solution, then this kind of solution, we call it as degenerate solution. Is this clear? So in the same example, we have understood two important concepts, redundant constraint and degenerate solution. Okay? Yes, everyone. Is this clear? Clear? One was your redundant constraint. Second is your degenerate solution. I hope so. This is being clear. Now, there are other special cases or some important cases in graphical method. Let us take one by one how we can identify this. The first one is infinite or multi-optimal solution. How we can identify this? Let us take an example. I got some values. ZA is equal to 0. ZB is equal to 20, ZC is equal to 20, ZD is equal to 35. So tell me, is this a multiple solution or and we are talking about maximization problem, okay? So tell me, is this a multiple solution or unique solution? By seeing the objective function value set, there are, let us suppose, 4 corner points. Unique because I'm getting the maximum value at only one point. So this is a unique solution. Right? Let us suppose instead of this would have been 15. Maximization problem. So now tell me, is this a unique solution or multiple optimal solution? As I am getting the maximum value at more than one location, so this kind of situation, we call it as the infinite or multiple optimal solution. Is this clear? This kind of solution, when I'm getting the optimized value at more than one position, then this kind of solution we call it as multiple optimal solution. Okay? Clear? Simple thing. Yes? Any doubt if you're having, please do let me know what's the doubt you are having, or else we'll be going for the no solution. Arey, yes? Okay, perfect. Arey yaar, this is a multi-solution because I'm getting multiple optimal solution, right? This is optimal values. These are optimal solution. I'm getting optimal solution at point B also and C also. That is the reason we are calling this as infinite or multiple optimal solution. Okay. Now, if I talk about no solution means I'm not getting any feasible region. No feasible region is obtained. No feasible region is obtained. Right? That means if I say I'm having a graph like this, let's say this is X, this is Y. So one of the constraint is like this, and second constraint was having some greater than equal to like this. Right? So there is, in this case, we are having no feasible region. there is no feasible region, there is no common region or no feasible region. No feasible region. So whenever I'm getting this kind of situation where I'm not getting any common feasible region, so this kind of situation we call it as no solution. This kind of solution we call it as no solution. In this case, we are not getting any feasible region. We are not getting any feasible region. So this kind of solution we call it as no solution. The next one is unbounded. What is unbounded? The region won't be a closed one. If I say I'm having a minimization problem, let us suppose I need to calculate Z minimum. Okay. Let's say this is x1 plus 2x2. And we're having the constraint as x1 plus 2x2 is x1 plus x2 is greater than equal to 10, and 3x1 plus 2x2 is greater than equal to 6. Okay. No, because I'm repeating, if I try to visualize one important thing here, why I'm not taking the lower values? Because there is one condition, non-negativity. x1 and x2 cannot be less than 0. When you are talking about the finals region, you will always be talking about in the first quadrant. Here all the final solution will be obtained in the first quadrant. You won't be getting in the we can say second, third or fourth quadrant, right? You can get the equation, you can get some equation where you are having some values like this where it is using some negative value, but final solution will always be lying in the first quadrant. So let us take one example. Let us take the same example, right, where I'm taking this as negative. Okay. In that case, there is no area, no feasible area, no common area, because this constant is saying all the values above this. This constant is saying all the values below this. So we are not having any feasible region. Right? Clear? Sujeesh? In this case, you are having the region 1. The first constant is saying this should be the region. Second condition, this should be the region. So we are not having any common region, which is having a common feasible point between these two conditions or constraints. Okay, so this kind of situation we call it as no solution. If I talk about unbounded, let us take this example. Okay, so try to convert this constraint number 1. This will be x1 by 10 plus x2 by 10 greater than equal to 1. Second one is x1 by 2 minus x2 by 3 greater than equal to 1. So let us try to draw this graph over here. Fine. This is x1, this is x2. Okay, 10 and 10. Let's say this is 10 and 10. Take this point. As they are saying that greater than equal to, so what should be the direction of arrows? Towards origin or away from origin? Tell me. All the values should be higher than this, so it will be away from origin. So your arrows will be pointing away from origin like this. Okay, fine. So what you can do is you can write plus and minus 3. We can write it like this. Okay, so let us try to extend this graph over here. Fine. So they are saying 2 and minus 3. This is, let us suppose, 2. This is minus 3. So we'll be having this one something like this. And as it is saying greater than equal to, so it will be away from origin. Right? So what is the common feasible region? This is the common feasible region. Right? If I want to show, this is the common feasible region. Okay? And this region is unbounded. We are not having any closed figure. We are not having any closed area. So this is an unbounded solution. And here you can see we are having two corner points. This is one corner point. This is second corner point. So we can calculate A and B. Where you are getting ZA, ZB, whichever is minimum, that is your final answer. Okay, you can calculate the coordinates of B. B is having 10, 0. B is having a coordinate of 10, 0. You can calculate the coordinate of A. A will be the intersection of these two equations. You can calculate, multiply 2 and add. It will be 5, 16, 3.2. X1 will be 3.2. Place it over here, you can get the value of X2. And multiply 2, sorry, not 3.2. If you multiply 2, sahi hai, 3.2. Yes, are we getting this? Just you multiply 2 in first equation, add these two, X2 will be cancelled out. So 5x1 is equal to, sorry, 26. 26 होगा तो 5.2 है ना. x1 will be equal to 5.2. x1 equal to 5.2. x2 will be equal to, can place and get, this will be 4.8 है ना. Sir, here Z is how this is unbounded even though the region is diverging, because we are not having any close boundary. Because if you try to see this region, it is increasing, right? It is, so it is having a diverging section. You're not having a constant closed figure, right? Bounded and unbounded means your region should be feasible and that should be a closed figure. Like in previous case when we were discussing about this problem, in this case we were having a closed figure, right? This was a closed diagram. This is not unbounded. This is a bounded solution. Fine. Because max, definitely max. If I talk about what's the, if this would have been a maximization problem, then your Z max will be infinity. If this would have been a maximization problem, then your Z max will have been an infinite value. Right? So here if they are talking about minimization, you will be getting one optimized value, but the solution will be unbounded. The solution will be unbounded. Clear? Fine. As they are asking the Z minimum, you will be getting a minimum value either at point A or at point B, right? But as the region is not bounded, so that is why calling it as unbounded. If this could have been a maximization problem, then maximum value will be infinity. And whether it is an bounded, no, it's not a bounded, unbounded. Okay? Fine. Is this clear? Okay, so this is all about the graphical method. We have completed the graphical method in a very short span of time, I think. Okay? Fine. So now let's begin the very interesting, that is simplex method. And simplex method is actually a topic to discuss because in simplex many students do have doubt. Many students do have doubt, sir, simplex method chhod dein kya? Yesterday also I got a message from one of the students, sir, simplex method chhod dein. Shall I leave simplex method? Wait, let's try to understand whether this topic need to be left or whether this topic should be covered. Let's try to understand in the next 15-20 minutes. Okay, so let's begin our simplex method. As we know that simplex method is an iteration method. Iteration means it's a step-by-step calculation. Okay, it's a step-by-step calculation. Okay, so now if I talk about simplex method, as it is step-by-step calculation, so here also we'll be having some solutions, solution 1, solution 2, solution 3. So technically it's very difficult to calculate the optimum solution. But let us take one example directly. I'm taking one example, maximization of this value. We are having some 3 constraints. I can solve this question by graphical method. Yes, because this is having 2 variables. So here x1 and x2, we call it as the decision variables or main decision variables. You can take it as only variables or main decision variables or simply decision variables. Okay, fine. And we know that x1 and x2 will always be positive. Now what I'm doing is, if I want to eliminate this inequality sign, can you tell me I need to add one variable on the left hand side or right hand side of first constraint? This one. In first constraint, do I need to add on the left hand side or on the right hand side? Tell me. Quickly. x1 less than equal to 4. If I want to eliminate this inequality sign, so I need to add it left hand side because less than hai na? Exactly. Right side. How it is right side, Sujeesh? No. Left side. x1 less than equal to 4. If I want to eliminate this inequality sign, left hand side is lower, right? You will be including one important variable, we call it as slack variable. So this S1, S2 and S3, we call it as slack variable. Okay, S1, S2, S3, we call it as slack variable. Similarly, you can write it over here, 2x1 plus S2. So 2x2 plus S2 is equal to 12, and here also 3x1 plus 2x2 plus S3 is equal to 18. So I have converted my constraints, inequality constraints, in form of an equality terms by introducing some variables. We call it as slack variables. Okay, fine. Now try to understand one very interesting thing. There are three equations. How many unknowns are there in this particular equation? Can you tell me? In these three equations, how many unknowns are there in these three equations? So there are 5 unknowns: x1, x2, s1, s2, s3. Yes, 5 unknowns, 3 equation, technically not possible. Yes, 5 unknowns and you are having only 3 equations. It is technically not possible to solve this equation. Number of unknowns should be equal to number of equations. Then only you can get the value, right? Okay, so that means, can we say there are 2 variables which are surplus or extra variables? There are 2 variables which are surplus because there are 5 unknowns, 3 equations. So there are 2 variables which are surplus. So what I have to do is, at a time, take value of the 2 variables as 0, calculate next 3 values, get one set of solution. Okay, that means, let us suppose I can have one possibility that I can take x1 equal to 0. Okay, I can take x1 equal to 0 and x2 equal to 0. By doing this, I can get the value of s1, s2 and s3. This is one possibility. Second possibility is I can have x1 and s1 equal to 0, right? And you can calculate the value of x2, s2, s3. And this way you can get different varieties of values. So can you tell me how many solutions are possible in this particular discussion? If you are having 2 variables, if you are keeping at a time to be 0 and calculating the other 3 unknown variables, so can you tell me in how many ways you can get the number of solutions? This is one possibility. Second possibility. So in total, can anyone who can tell me how many possibilities it is we can have over here? Yes, got the point? This is one possibility of solution. That is the second possibility of a solution. Exactly. Very good, Sujish. We can have 5C2, that is 10 ways. Number of possible solutions, that is 5C2, that is 10. So we can have 10 possibilities. We can have 10 possibilities, and among these 10 possibilities, I need to identify the best possibility. That is your iteration. Is this clear? What we are actually doing in simplex method, I hope so now this is clear. In simplex method, what we are doing is, we are identifying among this 10 possible solution, which solution is best. That is our linear programming. That is the concept of linear programming. Is this clear? Understood? So, sir, we can start our calculation by any possibility. And very important, the variables which I am keeping 0, the variables whose values I am keeping to be 0, that is we call it as non-basic variable. Non-basic variable. And the variables which I am getting the value, this we call it as basic variable or basis. The variables whose values I am getting, right, that is we call it as basic variable or basis. Like in this case, this is the non-basic variable and these are the 3 bases. Basis or basic variables. Both are same. Okay, so what we have to do is, whenever you are having this kind of situation, we always try to have decision variables ko will be taking it as 0. So if you put the first possibility as x1 equal to 0, x2 equal to 0, so can you tell me what are the values of the slack variables that we'll be getting? If you take the first possibility as this as the non-basic variable, what will be the value of S1, S2 and S3? You put x1 and x2 equal to 0. x1 equal to 0, S1 equal to 4, S2 is equal to 12, and S3 is equal to 18. So this is one set of solution, and as we know that because we are introducing slack variables into the constraints, so definitely I need to introduce into the objective function also. We need to introduce in the objective function also. What we are doing is, I am having a coefficient of slack variables as 0. So whatever value of slack variables you are getting, always it won't be impacting my objective function. Okay, if luckily let us suppose you are getting some value of slack variables as a non-zero value, no problem, 0 into that value will always be coming to be 0. Okay, fine. So now I've got the first solution. This is the first solution. This is the first solution, right? And if you clearly see that first solution, do we get any optimum value in the first solution? If I say this is a maximization problem, your x1 and x2 is 0, and this is the first solution where you are having this as basis whose values we are getting non-zero. So first solution, we always call this first solution as the worst solution. You can never, if I talk about maximization problem, you can never ever get the optimum solution in the first table or the first solution, because you are making the decision variables to be 0. Calculate the value of slack variables. There is no point of calculating this. Understood? There's no point of calculating this because you'll be getting a 0 value, I think. Okay, so now what you have to do is, from this particular value, you have to go frame the second table. So let us first of all draw the first table. Okay, so first table, how we can draw, right? Let me draw it for you guys over here. There are some Cj values. So Cj values is nothing but the coefficient of the objective function 35000. 35000. These are the Cj values. And what are the bases in the table number 1? This is your first solution or table number 1. In first solution, we are having S1, S2 and S3 are the bases. S1, S2, S3 are the bases. And its corresponding values are 4, 12 and 18. 4, 12 and 18, right? We'll be writing x1, x2, s1, s2, s3. So can I write the first constraint as like this? x1 plus 0x2 plus s1 plus 0s2 plus 0s3 is equal to 4. Is equal to 4. Can I write it the first constraint like this? 1 0 1 0 0 0 1 0 1 0 0. If I talk about the second constraint, the x1 is having 0 coefficient. So x1 is 0, x2 is having a coefficient of 2, x2 is 2, s1 is 0, s2 is 1, s3 is 0. Right? Third one, x1 is having coefficient of 3, x2 is having coefficient of 2, s1 and s2 not there, 0, 0 and 1. Okay? So we have completed the table number 1. We have completed the table number 1. Okay, but if you try to visualize very interesting thing, if you try to see S1, S2, S3, what is this matrix called? Anyone? Try to write in the comment section. What do we call this kind of matrix? 1, 0, 0, 0, 1, 0 and 0, 0, 1. What do we call this kind of matrix? So this is a unit matrix or identity matrix. Always remember that the basis always forms a unit matrix. So if you write in the same order S1, S2, S3, in the same sequence you have to write 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay, fine. Chalo sir, perfect hai. Perfect hai, perfect. Right. So this is the first solution. Now definitely I need to make one of the basic variable to be 0 and one of the non-basic. Now in this case, your x1 and x2 are the non-basic variable, which is outside. We call it as outside the system, because as we say this is 0, I'm saying this is outside the system, this is inside the system, which are, we call it as basis. So in this particular first solution, S1, S2, S3 are the basis. These three are the basis, right? So I need to replace this basis with one of the non-basic variable. That we have to do. How we'll be doing? For that, there are some calculations that we need to proceed. So what we calculate is Zj. Zj is nothing but, you have to, what's the Cj value for S1, S2 and S3? That is 0, 0 and 0. 0, 0 and 0. So 0 into 1 plus 0 into 0 plus 0 into 3. What will be that? 0 only. 0 into 0 plus 0 into 2 plus 0 into 2. Again 0. So we'll be getting the Zj value as 0, 0 and 0. We get the values of Zj as 0 and 0. And here we calculate the value of delta. Very important. Delta is Cj minus Zj. Delta is Cj minus Zj. We call it as net evaluation row. We call this delta value as net evaluation row. Very important, because this decides which variable will be coming into the picture, which non-basic variable will be coming inside the system. So now if I try, what is Cj minus Zj? This is 3 minus 0, that is plus 3. This is 5 minus 0, that is plus 5. 0 minus 0, 0, 0 minus 0, 0 and 0. So what is the significance of this delta value? It's very easy. If delta value is having, let us say in this case we are having delta value is plus 3. So if this non-basic variable x1 is becoming a basis or basic variable, the objective function will be increased by 3 units. Second possibility, if x2 is going into the system, that means this non-basic variable is becoming a basic variable, so definitely it will increase the objective function by plus 5 units. So which variable you will be preferring to go into the system? Which non-basic variable you will be preferring to becoming the basic variable? Is it x1 or x2? Which variable you will be preferring? Yes, sir. Perfect. X2. Why? Because when X2 is going into the system, then what happens? My objective function will be increased by 5 units. So my entry variable will be X2. This we call it as entry variable, also called as key column. Okay, fine. That means now my x2 will be becoming, it will be getting a promotion. He'll be getting a promotion from non-basic to basic. If one of the variable is becoming non-basic to basic, so from this basis maybe you have to remove one of the variable. It has to be, because at a time you already seen that 2 variables will be non-basic and 3 variables will be basis. Now you have understood that x2 will be becoming a basis, so one of the variables should be coming out from the system. One of the basic variable will be converting into non-basic. For that, you will be calculating a very interesting parameter. We call it as theta. What is theta? That is replacement ratio. Replacement ratio. What is replacement ratio? It said that value divided by corresponding key row. It is nothing but value divided by the corresponding key column. That is a basic meaning of theta. So 4 divided by 0, infinity. 12 divided by 2, 6. 18 divided by 2, 9. So the variable, sir, also tell in examination, he asked in between which value takes, which values has to take. Actually, what is happening? In examination, they'll be saying, what is the value of the objective function in the second iteration? This is the first iteration. They'll be asking, what is the objective function in the second iteration? I'll be telling you that also, right? Or they'll be asking that, they'll be giving some intermediate table. They'll be asking that which is the entry variable, which is the exit variable. I hope so now you can understand, right? As this is a maximization problem, right? Let us suppose if this would have been, let us take an example, if this would have been negative, let us suppose, agar ye negative hota, if this would have been negative, then if x2 is entering the system, then it will decrease the value of z by 5 units. If x1 is entering the system, it will decrease the value of z by 3 units. So if I'm talking about your we can say maximization problem, which variable will be entering the system, x1 or x2? If this would have been a situation, let us suppose instead of positive we are getting negative, right? And they are asking you have to calculate the maximum value of z, z max. This is some iteration, after some iteration you are getting some value. So which non-basic variable will be preferring? No one. Why? Because you are getting some value. If this variable is entering the system, it will decrease further. If this is entering, this will decrease further by 3 units. So no need to proceed anything. That will be your optimized value. That will be my optimized solution. But as this was positive, right, and we are talking about maximization problem, so definitely I need to increase the value of objective function. So I'll be preferring that which is increasing by more units. Okay, so x2 will be entering the system. So now which variable will be leaving? The variable which is having the minimum replacement ratio, and we'll be talking about the magnitude. Okay, if this would have been minus 9, okay, or if this would have been minus 6 and 9, then you have to take the magnitude. That's it. Okay, so if this would have been, let us suppose minus 9 and 6, you will be taking 6 as the minimum value. So always take the mod value. That's it. Okay, so here the minimum value is this one. So S2 variable will be leaving the system. This is leaving variable. Is this clear? You have to identify the minimum value of theta, but that will be going out of the system. Minimum, yes. And the intersection, and we call it as key row, because I'm talking about a row. This is a key row. And the intersection of key row and key column, this is, we call it as pivot element. This we call it as pivot element. Is this clear? This we call it as pivot element. Okay, so we are now in a very, very good situation about simplex method. Okay, so this is your pivot element, this is entry variable, this is exit variable, or leaving variable, or exit variable, or key row, whatever you can write. Okay, fine. So now this is, we have understood that. Now in the next set of the solution iteration, your x1 and s2 will be having 0, non-basic, and s1, x2 and s3 will be having some values. This is basis, right? Because what has happened in this table, you have identified that x2 will be entering the system and s2 will be leaving the system. So that simply means that in the second iteration, x1 and s2 will be the non-basic variable, and s1, x2, s3 will be the basic variable, right? Is this clear? Right? Out of 10 possibilities, 10 solution, I have now come closer to my optimized value. And no need to check at all the 10 points. No need to check at all the 10 solutions, because we have already seen that when we were discussing this, NC2, 5C2, there are 10 possibilities. So instead of checking at all the points, what we can do, we can do some iteration and you can get the solution at 2 steps or 3 steps at max. Okay, fine. So now we have understood that your this one is your entry variable and this one is your exit variable, right? Okay, fine. So what I have to do, again I have to draw the table number 2. Let's draw the table number 2. So we'll be taking x1, x2, s1, s2, s3. Its CJ value will always, what is CJ value? Coefficient of the variables in the objective function. 35000, 35000. So it won't be changing. It is 35000, right? And now we are having, let's say this is value and this is basis, right? And its CJ values. Okay. So now the basis has shifted from S1, S2, S3 to S1, X2, S3. You have to use the same sequence. S1, X2 and S3. Remember one thing. Exactly. If you want to, let us suppose, if you want to calculate what's the objective function of the Z, this value, only you have to calculate this. If you want to calculate what is the objective function in the second iteration, you can say, if I'm able to calculate x2, because rest, whatever values you'll be having, no problem. The reason being, coefficient of S1, S2 and S3 is 0, right? And if you want to calculate x1, x1 is having a 0, the second iteration. So just only by calculating this value, you'll be getting the objective function in the second iteration. Yes? Perfect. So now, remember one thing, I told you unit matrix concept. So if you try to visualize S1, X2 and S3, they will form a unit matrix, same sequence, 1, 0, 0, 0, 1, 0, 0, 0, 1. So write in the same sequence, 1, 0, 0, X2 is 0, 1, 0, 0, 1, 0, and S3 is 0, 0, 1. Okay? Right? Same concept. It basically increases the speed in the examination. Okay? Fine. Chalo. Now, okay, now, if I want to calculate the new values in the row number 2, in this one, right? Then what you have to do is, you have to divide the pivot element by individual one. That is 12 divided by 2, 0 divided by 2, 2 divided by 2, 0 divided by 2, 1 divided by 2, and 0 divided by 2. So if you try to divide, you will be getting 6, okay? You'll be getting 6, 0, 1, 1, 0, 1 by 2, 0, 1 by 2, and 0 by 2 is 0. So that already being written. So this is the complete set of values you have completed in row number 2. This is the complete set of values that we have completed in row number 2. Now we are left out with 1, 2, 3, 4, 5, 6. Okay. So in order to calculate these 6 values, you have to use a very interesting formulation, that is your new element is equal to old element minus corresponding key row into corresponding key column divided by the pivot element. This we have to use. Chalo, let's try to apply this particular formula. Now, if you try to see, I need to calculate this value, right? That means I need to calculate this value. So old value is 4 minus corresponding key row and key column. 0 and 12 are the corresponding key row and key columns. 0 into 12 divided by pivot is 2. What will be this value? Again 4. So we can directly write this value is 4. Okay. If I try to write this value, this one, this value will be, old value is 18. So let us write this over here. 18 minus corresponding key row and key column. Its corresponding key row. Corresponding key row is 12 into 2. 12 into 2 divided by 2. That is coming out to be 12. That is 6. So the new value is 6. Is this clear? So by this way, you can calculate all the set of values. I think I've already written for your simplicity. This will be the value that we'll be getting. 4, 6, 6. If I talk about this one is x1 ke niche wala. This one. So if I say old value is 1 minus corresponding key row and key column, it is, try to identify a simplest way. If any one of the value key row or key column is 0, you can directly say old element is equal to new element. Why? Because if you try to see, if any one of the value key row or key column is coming out to be 0, old element and new element will be directly equal. Okay. So we can simply say one of the value is 0. So 1 minus 0 by 2 is again 1. So it will be again coming out to be 1. Okay. In this case, If I talk about this one of the value is 0, so again it will be having 3. S2 ke niche, S2 niche, this one of the value is 0, so again we can have 0. One of the values is not 0, so it is 0 minus 1 into 2 divided by 2, that is minus 1. So we're getting minus 1 over here. Okay, minus 1 over here. So this completes your table number 2. Table number 2 done. Table number 2 done. So we need to identify whether this is an optimized solution. Let us check. Let us check ZJ value. Now the CJ value of S1 is 0, X2 ka CJ value is 5, and this is 0. So 0 into 1 plus 5 into 0 plus 3 into 0, that is 0. 0 into 0 plus 5 into 1 plus 0 into 0, that is 5. 0 into 1, 5 into 0, 0 into 0, that is 0. 0 into 0, 5 into 1 by 2, 0 into minus 1 by 2, that is 5 by 2. 0 into 0, 5 into 0, 1 into 0, that is 0. So delta value Cj minus Zj plus 3, 0, 0. Cj value is, this is minus 5 by 2. है ना? हाँ. Cj minus Zj. हाँ. And last one is 0. Yes? Okay. So tell me, by looking at the delta values, which variable will be the entry value now? By introducing which variable your objective function will be increasing. So this is non-basic and S2 is the non-basic. These two are non-basic. S2 the negative aa gaya. Don't look at that. We are having this as positive. So this will be the entry variable. This will be the entry variable. So if it is entry variable, you have to get the exit variable also. For that, you have to get the value of theta. Theta. That is value divided by key column. So value is 4. Value is 1. 1 divided by 4 is 1 by 4. 4 divided by 1 is 4. Right? 6 divided by 0 is infinity. And 6 divided by 3 is 2. So which will be now exit variable? Exit variable will be S1, X2 or S3. Which will be now leaving the system. You have to take the minimum value. So if you take the minimum value, this one will be exiting. S3 will be the exit variable. S3 will be the exit variable and this will be the pivot element. This will be your pivot element. Right? So this one is your exit variable. Exit variable. Is this clear? Okay, fine. So as this is not an optimized solution, so again we have to draw the table, step number 3. And now in this case, S1, X2 and S1 are the S1, X2 and X1 are the bases, right? And S2 and S3 are the non-basic variable, right? So I have completely filled the table again by using the same concept. Again, if you see S1, X2 and S3, S1, X2 and X1 will be forming unit matrix 1 0 0 0 1 0 0 0 1. Same sequence you have to follow. So S1 1 0 0, X2 0 1 0, X1 0 0 1. Okay, the exit variable is this. So 3 divided by 6 is 2. 3 divided by 6 is 2. 3 divided by 3 is 1. 0 by 3 is 0. 0 by 3 is 0. 0 0. Minus 1 by 3 is minus 1 by 3. And last one is 1 by 3 is 1 by 3. For rest of the values, you will be using again the same formulation, that is new element is equal to pivot old element minus key row into key column by pivot element. Okay, so let's check whether I am getting a optimized value. Chalo. Cj value is 0. This is 5. Hai This is 3. These are Cj values. Okay. So Zj values 0 0 3 0 5 0 0, 0, and 0, 0, 5 by 2, minus 1 by 3. So 2.5 minus, sorry, minus 1, 1.5, 1.5, okay, and 0, 0, and 1. So calculate delta value, Cj minus Zj, that we are getting 0, 0, 0, minus 1.5, minus 1. So now, so that's quite obvious. They won't be asking you to calculate the optimized value. Okay, they will be giving you one particular table and they'll be asking you what is the entry variable, exit variable, like this, right? So now if you see, this one is the basic variable, this is basic variable, this is again basic, this is non-basic, and this is non-basic. Now we have to only check the delta value of non-basic, this one. Because this is outside the system. So can they enter the system, non-basic variable? No, right? Because if S2 is entering, it will decrease the value of objective function. If S3 is entering, it will decrease the value of objective function. So definitely this is not your optimized value, because this is the optimized solution, right? The final solution is optimized. This is an optimized solution. And what's the final value? X1 equal to 2, X2 equal to 6 is my final solution. Okay, fine. So final answer that we are getting is S1 equal to 2, X2 is equal to 6, and X1 is equal to 2. This is the final solution, and definitely S2 and S3 will be 0, because these are non-basic. Okay, this is the final optimal solution, right? So what is the objective function? Objective function was 3x1 plus 5x2 plus 0s1 plus 0s2 plus 0s3. So if you try to place all these values, I think you'll be getting 6 plus 30, 36 as the final answer. Okay, so definitely they never gonna ask you a question from simplex to get the optimized value, because it's a very long process, iteration. We have taken 20-25 minutes to solve this single question. So definitely never gonna ask you question from the optimization of the simplex. But yes, they can ask you, let us suppose they are giving the initial table, right? They're giving the initial table and they're saying, what is the value of Z in the next table? So in the next table, when I see the next table, we are having X2 is equal to 6, and this one is this table number 2. If you have placed it, you'll be getting, I think, 30 value. For the second table, if I talk about table number 2, the second iteration, I was getting S1 4, X2 6, and S3 6. S1 4, X2 6, and S3 6. This was the solution, 4 6 6, right? And what was X1? Non-basic variable hai. This is non-basic variable. And what's about the objective function? Z is equal to 3x1 plus 5x2 plus 0s1 plus 0s2 plus 0s3. So if they're asking what is the value of objective function in the second iteration, just place it. You'll be getting, I think, 30, which is not the maximum value. Is this clear? So this kind of questions you can expect from the simplex method, not the optimization value. Okay? Right? Is this clear? So to calculate this, no need to make this complete table. Just only calculate this value. Hana? Because S1 and, sorry, not this one. If I want to calculate for table number 2, only you have to calculate this value. That's it. Because S1 and S3, whatever value you will be having, it is independent, because the coefficient of S1, S2, S3 in the objective function is 0. So it is not required to calculate the slack variables, only you have to consider on X1 and X2. So definitely in table number 2, there is only X2. So only you have to calculate this particular value. Then you can get the value of next iteration Z2 as 30. Okay. So this is your discussion of simplex method, where you can calculate by using iteration. But kya exam mein they will be asking like this? No. They'll be asking like, what is the, they'll be giving one table and they're saying whether this is an infinite solution or no solution or unbounded solution. Let's try to have a discussion of that. If I'm having an infinite or many optimal solution. In that case, let us take one example. I'm having x1, I'm having x2, s1, s2, and they are saying value, right? They're saying, let's say, s1 and x2. There are some values, right? Some values they have given, and they are saying the delta values they have given as for s1 is 0, for s2 is 0, x1 0. This is negative. Can you tell me whether this solution is an optimized solution or not by looking at the table? By looking at the table, can you tell me whether this solution is an optimized solution or not? Maximization problem. By looking at the table, can you tell me yes? Yes. Why? Because the objective function, and we have to check only for the non-basic. So here the non-basic variables are, this one is non-basic and S2 is non-basic. And for non-basic variables, I am having no positive, there's negative and 0. So definitely this is an optimized solution. This is an optimized solution. But if you try to have an understanding that your x1 value, which is a non-basic, is having a value of delta, that means if it is entering the system, it won't be changing the value of objective function. So can we have an infinite many solution? Okay, can we have a situation where we'll be having infinite many solution? Is this clear? We'll be having an infinite many solution, right? Because x1 is a non-basic variable, and which is having a value of delta. Definitely it can enter the system without changing the value of z. So this is the condition that from that where you can understand that your linear programming is having an infinite many solution by using simplex method. Graphical we have already seen. By checking the value of z at the different points, we can identify the infinite many solution. But in case of simplex, you can check the infinite many solutions by definitely degenerate also. Exactly, this is degenerate. Absolutely correct, Manas. Because one of the decision variables is having a 0 value. Clear? One of the decision variables is having a 0 value. Is this clear? Fine. So this is the condition to check the infinity many solution. If I talk about, we'll be taking duality afterwards. If I talk about your, we can say, unbounded solution. How to identify the unbounded solution in simplex method? If the replacement ratio is either all value negative or either all value infinity, then we can get the solution will be unbounded solution. Is this clear? The replacement ratio in any one of the iteration, if you're getting all the values are negative or all the values are positive, right? All the values are infinity, then we can have the unbounded solution, right? Okay. And the third condition is your no solution. How to identify no solution condition in the simplex method? For that, let us have a quick understanding. Let us suppose I'm taking one example. I'm having a minimization problem. Let's say 3x1 plus 5x2. Okay. And we are having, let's say, x1 plus x2 is greater than or equal to 10. And 3x1 plus 5, not 5, x2 is greater than or equal to 6. Okay. We are having this kind of situation. And they're asking whether there is a no solution or not. Now, if I try to eliminate this inequality, can you tell me the slack variables will be added on the left hand side or right hand side? Exactly, very good. If you want to eliminate this inequalities, the slack variables will be added on the left hand side or right hand side. Definitely, sir, as lower side on the right hand side, I have to add on the right hand side. So x1 plus x2 is equal to s1 plus 10, right? Or I can say that it is equal to minus s1 equal to 10, and 3x1 plus x2 minus s2 is equal to 6. If you put x1 equal to 0 and x2 equal to 0, what is the value of s1 and s2 you are getting? If you put x1 and x2 equal to 0, what's the value of s1 and s2 you are getting? You are getting minus 10 and minus 6. You are getting minus 10 and minus 6, which is not possible. Why it is not possible? Because the decision variables and the slack variables, they will always have a positive value. They always have a positive value, right? That means our assumption is wrong, right? So here, what I'll be doing, I'll be using a very interesting concept of big M method. Only understanding, you won't be getting a question from this. Yes, you can expect, but not in GATE. What is big M method? I'll be now introducing a variable, we call it as artificial variable. Artificial variable, right? So now if I try to include the artificial variable, so I'll be having the artificial variable included on the right hand side. A1 equal to 10, A2 equal to 6, right? Now what I'll be doing is, now I'll be S1 equal to 0, S2 equal to 0, calculate the value of A1 and A2. So if we calculate A1 and A2, this will be having a positive value, that is 10 and 6. Now we are having a positive value of the variable. So now we can proceed by solving. Now, as we have introduced one more variable, so you have to introduce in the objective function also. So we can write it as 0s1, 0s2 minus, oh sorry, this is minimization, plus m into A1 plus m into A2. Where m is a constant that we are using, that will be called it as, which is having a large magnitude, and that is we call it as big M method. Okay, in minimization problem, we go for z plus ma, or z is equal to plus ma. In maximization problem, we go for minus m into a, right? Now, how we can identify whether having a no solution? If in the final solution, if artificial variable is present as basis, if in the final solution artificial variable is present in the basis, then we can say this is a no solution. You cannot get the optimal solution. Is this clear? If the artificial variable is present in the final solution, then we can say we won't be getting an optimized value. Understood? Right? So this is the criteria to identify the no solution. In case of graphical, it was very easy. You have to just only check whether we are getting a feasible region or not. But here, we need to identify by using the concept of big M method. That is artificial. If artificial variable is present as a basis in the final solution, optimum solution, then we can say the solution is having no solution. Okay, fine. Now the last point is duality. Let's quickly wind up duality. Then we'll be taking a 5 to 10 minutes break. Then we'll be again resuming our discussion on forecasting, queuing theory, and then transportation and assignment. So what is duality? We have the linear problem, we call it as primal. Okay, and we take the opposite of that, we call it as a dual. If you're having a maximization problem, we can convert into a minimization problem. If we're having a greater than equal to sign, we can convert into a less than equal to sign. So what's the use of using this duality? Okay, we have to convert, we have to use the transpose technique. The rows will be converted into columns and columns will be converted into rows, right? So if I take one example and then we'll be taking one perspective of how this particular is using. So if I say there is a maximization problem, 4x plus 6y subjected to two constraints, right? So if I write this, z max is equal to 4x plus 6y and 3x plus 2y is less than equal to 6, 2x plus 3y is less than equal to 6. You have to make the dual of this. How we can make the dual? The rows will be converted into columns and columns will be converted into rows. So here I will be using some new set of variables. Let us say I'm taking, let's say capital Y1 and Y2. Okay, so as this is 6 as 6, so we can say simply 6y1 plus 6y2, right? This is your objective function. This is maximization. This will be minimization, right? Convert this rows into column. If I write 3, 2, 2, 3, if you take the transpose of this, it will be again 3, 2, 2, 3, right? We'll be writing 3, 2, 2, 3, y1, y2, y1, y2, right? This is positive, positive, positive. This is less than equal to, greater than equal to 4, greater than equal to 6. So you have converted our primal, this we call it as primal. You have converted my primal function into a dual function. So what is the importance of using this? Actually, it is being seen that whatever will be the objective value, final optimized value, you'll be getting the same value over here also. If I say it is having some objective final value as a 10, so Z minimum value will also be 10. They can definitely get at some different points, but the final optimal solution will be same for both the functions. So that is the best part of duality. Okay, that means whatever will be the optimal value, the same optimal value you will be obtaining in this particular duality. This is the best part. You can have some different points. Let's say at maximization I'm getting at 2, 3, minimization I'm getting at 4, 1. You can get some at different points, but the final optimal solution will always be same for primal and dual. Okay, for primal and dual, it will be same. What is the use of using this? Let us take one example, one more example, and let us try to have a clarity. Let us suppose I'm having maximization problem is equal to x1 plus 2x2 plus 3x3. Okay, and we are having the constraint as x1 plus let's say 4x3 is less than equal to 10, and x2 plus x3 is less than equal to let us suppose 6. Okay, so they are saying calculate the optimized value, and this question is being coming in the gate examination. Sir, this is not possible to solve by using graphical. There are 3 variables, x1, x2 and x3. So you cannot use the graphical approach. They are saying calculate the final optimized value. Then what you'll be doing? Let us do one thing. Let us convert this into the dual format. Okay. So whatever that is being written in row, that will be converted to column 1, 2 and 3. Okay. As this is your column, right? It will be converted into row. So it will be Z minimum is equal to 10y1 plus 6y2, right? Column into row, row into column. So this is 1, 4, 1, 1. Transpose this. This is 1, 1, 4, 1. So it will be having expression like this. We'll be having expression over here as 1 x1 ka coefficient is 1. 1 into y1, right? Is one expression that is being missing over here, that we have to take it. One expression that we have to take it. One more thing. Let's say this is x1 plus 3x3. 3x2 is this less than equal to 4. Let's take a random value. Okay. So now what we can do is, अच्छा फिर तो वो 3 वेरिएबल में कन्वर्ट हो जाएगा. हाँ ठीक है. We can have here, what is the coefficient of x2? This is 0 into x2. Here it is 0 into x1. Okay, so x1 coefficient is 1. So y1 is greater than equal to 1. x2 coefficient is 0 and 2. 0 and 1. So y2 is greater than equal to 2. x3 coefficient is 4 and 1. So 4y1 plus y2 is greater than equal to 3. So are you able to visualize? Are you able to visualize what has happened? I have converted the 3 variables into a 2 variables. Now I can calculate this value very easily and get the final optimal solution. And this optimal solution will be having the same optimal value over here. Exactly. Now you can solve very easily by graphing. This is a very easy question now. What I've did is I've just written the coefficient, right? So coefficient of x1 was 1 and 0. So 1 and 0. Coefficient of x2 was 0 and 1. So 0 and 1. Coefficient of x3 is 4 and 1. 4 and 1. That's it. Now you can easily solve this question by graphical approach. So whatever minimum value that you are getting as the optimal value, the same value you will be obtaining as Z maximum in this particular question. That is the benefit of using this duality. That is the benefit of using this duality. Okay, fine. Because sometimes we are able to convert a 3 variable problem into a 2 variable problem. Okay, is this clear? Right? So now your linear programming is being completed, right? So now let's take a break of how many minutes? 5 minutes, है ना? Let's take a quick break of 5 minutes. Then I'll be resuming by the time is 4:31 ना? सही है, सही. We are going on track जा रहे हैं. Take a break of 5 minutes and we will be meeting at 4:37 or 4:36. Okay, then we'll be going for forecasting. Okay, fine. Now we'll be going for forecasting. We'll be resuming a break of 5 minutes. Then again, we'll be back and discussing about our forecasting, queuing model, transportation, and queuing query. Okay, चलिए, let's have a quick break. जल्दी आना है. 5 minutes से ज़्यादा break नहीं. Okay, चलिए. One second. Which topics is being remaining? Forecasting, queuing model, transportation, and assignment. These 4 topics will be covered in a single go. Okay. This is the last break that we are doing. Then in a single stretch, we'll be covering all the 4 topics. Yes. Last topic will be queuing model. No. Forecasting, then queuing model, then transportation, and then assignment. That's it. Okay. Chaliye, let's have a quick break and let's resume the class. Already I've taken 1 minute of yours. Okay. 4:36. Chaliye. Bye-bye. Okay. So let's continue our discussion of the forecasting topic. Right. So till this point we have covered PERT CPM, break-even analysis, inventory, LPP, sequencing. So now we are going for the forecasting topic, right? And then we'll be going for in a one stretch. Okay, now no break. We'll be trying to cover. If break is required, definitely we'll be going for. Only major I would say forecasting and queuing model, precisely. Queuing model is a very small topic. Transportation, we'll be taking one example and try to understand how to check the optimality. And assignment is like a Hungarian method, small topic. So let's start our forecasting. Let's try to forecast whether we'll be complete by 6:30. Okay, let's do the forecasting that. Chale yaar, please do like this section and please do share this video. Yaar, I want more students to be joining right now. So let's start with the forecasting techniques, forecasting model. Now, it is being seen that forecasting is broadly no, not that much important, but if you want, I can have a quick discussion of assembly and balancing also, if required. Okay. So now if I say forecasting, forecasting is broadly classified into two categories. One is qualitative, second is quantitative. What is the meaning of this word? Quantitative basically means I'm not having some previous data. Okay, there's something new that I'm discussing, right? I'm having some new product is being launched whose previous history data is not present. So there I'll be using the concept of this one, qualitative. Okay, where I'll be taking the opinion from the experts. I'll be taking some opinion surveys or market survey or market trial. There are many particular forecasting techniques in qualitative. Not important from GATE perspective, but yeah, yes, important from ESE perspective, but I'll be having a quick recap of this. So in this case, as we know that there is no historical data with me, so definitely I'll be taking the advice from an expert, okay, or from a consultant. Okay, are we going for a trial, market trial? Like you might have seen that in last previous 5-6 years, we used to have some free samples which is being coming from the newspaper, like a shampoo sachet or an oil, right? A small sachets will be they will be giving free of cost to the limited population. That is we call it as your market trial. So all these particular forecasting techniques where I'm not having some previous data, so I'll be going for a qualitative method where I'm taking the opinion from the expert. So I won't be taking the opinion from the expert from every week. Okay, I'll be taking in a one go, and normally I go for like 6 months, 1 year, 2 year, like this. So in this case, qualitative, usually we are preferring a long range forecasting. Normally we are going for a long range forecasting by using qualitative, where I'm taking the we can say opinion from the expertise, right? But on the other hand, when I'm talking about quantitative, in this case I'm having some previous data. So by using this previous data, I'll be able to forecast some values, right? So we'll be having some historical data. In this case, I'll be using two important models. One is your time series and second is correlation analysis, like your linear regression. Okay, fine. So let's quickly start our discussion of this one. I think this is not required. I hope so. This is already, you know, opinion survey, market trial, market research, Delphi technique. Delphi technique is basically we'll be having a panel of experts. We'll be giving some questions to them, and based on their response, we'll be forecasting, right? So all this we are talking about under the qualitative. Okay, under qualitative, also called as judgmental. Under quantitative, this is an from GATE examination perspective an important topic where you can expect questions specifically from exponential smoothing method. Okay, so here I'm having some past data with me that could be a monthly, previous month, or previous 10 days, or previous 2 months, like this. Okay, so based on that previous data, I'll be able to forecast the next data value or next value. So here I'll be having some previous data, so I can use some different techniques. This we call a time series, and second is your regression or causal technique. So we'll be going for linear regression in this case, right? So let us talk about the first one is past average. Past average means simply you will be taking the average of the past value. Simple as simple as this. Let us suppose I'm having the value of January, February, March, April, May, and June. I'm having some values as 10, 11, 15, 9, 6, and 10. So past average means whatever values you are having, you have to take the average of that. Like in here, I'm having a set of 6 values. I'll take the average of a set of 6 values. That's it. Okay, fine. I think no discussion is required. Fine. Second is simple moving average. Simple moving average, also called as SMA. In this case, some time duration will be defined. They'll be saying 3-month simple moving average. That means I have to take the average of only 3 months previous data. That means if I want to calculate the forecast for the month of July, I have to take the data of past 3 months only. That means 9 plus 6 plus 10 divided by 3. This will be giving you the forecast. This we call it as 3-month simple moving average. Okay, 3-month simple moving average. We can have 4-month also, we can have 5-month also. Okay, fine, clear. But if I talk about a third one, that is your weighted moving average. What is the meaning of this word weighted moving average? Weighted moving average is weighted moving average is denoted as WMA. Here, what I do, I assign weights to the different values. Example later. Let us take one example. Okay, let us suppose I'm having the value for January, February, March, and April. And the actual data that we are having is, let's say 100, or let us take a smaller value, 10, 12, 9, and 8. Okay, or let us take it as 10. Fine. This is the value that we are keeping. So let us suppose if I'm using 4-month simple moving average, right? So can you tell me what will be the forecast for the month of May? Anyone? If I'm using 4-month simple moving average, that means I need to take 4 months previous value. So we're having 8 plus 10 plus 12 plus 10. I can write it like this. 8 plus 10 plus 12 plus 10 divided by 4. Yes, you can calculate the value. I think 20 divided by 10, 20, 40. Divided by 10. I think that will be the answer. 10 is the final answer that we are getting. Or can I write it like this? 0.25 into 8, 0.25 into 10, 0.25 into 12, and 0.25 into 10. Can I write it like this? Yes, sir. 1 by 4 is 0.25. That means I am allocating equal importance to each and every data. I am allocating equal importance to each and every data. That is your simple moving average. But here, I'm talking about weighted moving average. That means I'll be allocating more weights to the recent data and less weights to the oldest data. So in this case, what I'm doing, I will be assigning more weights to recent data, right, and less weight to older data. Now, for when I'm talking about May, the recent data will be April. So I'll be assigning more weights to April, and oldest data is January. I'll be assigning less weightage to January. So why or where we can have this kind of method applicable where fluctuations are more? Because if fluctuations are more, then what will happen? Whatever changes happening recently, I'll be giving importance to that. I won't be giving importance to the changes happened 4 or 5 months before. Whatever changes happen to the recent data, I'll be giving more importance to that. And that is a basic benefit of using this weighted moving average. Okay, let us take one example. Let us suppose the same example if I take, if I want to calculate your weights. Now, for calculating the weights, you need to calculate summation n. What is summation n? That is n into n plus 1 by 2. So from here I can calculate the weights. What will be weights? Weights will be equal to 1, or we can say n divided by summation n minus 1 divided by summation n, 1 divided by summation n. Let us take one example. In this case, I'm taking 4-month weighted moving average. If I take 4-month weighted moving average, so what is the value of summation n? Summation n is equal to 4 into 5 by 2, that is equal to 10. So the weights will be 4 by 10, 3 by 10, 2 by 10, 1 by 10. That means 0.4, 0.3, 0.2, 0.1. And definitely if you add all these values, it will always be equal to 1. Similarly, if you add all this 0.4 plus 0.25 plus 0.25 plus 0.25 plus 0.25, you'll be getting this one. So always we'll be getting the one only. So here, if I want to calculate the forecast for the month of May, I'll be assigning highest weight to the recent data. Recent data is April. So 0.4 into 8 plus 0.3 into 10 plus 0.2 into 12 plus 0.1 into 10. Okay, so by this way, I'll be able to forecast this particular data by using the weighted moving average. By using weighted moving average, I'll be able to forecast very easily. But the main important thing is I'm assigning higher weights to the recent data and lesser weight to the oldest data. So whatever fluctuations is happening, I'll be able to forecast in a very proper way. Okay, so this is your weighted moving average. Is this clear? We can have 5-month also, we can have 3-month also, we can have different months of we can say simple moving average and weighted moving average, right? Time period will be defined. Okay, but yes, but normally question is being asked from a very interesting topic, that is your exponential smoothing. What is this exponential smoothing method? Generally, maximum question is being expected from this particular topic. Exponential smoothing method. Actually, if you try to visualize, this is also one form of a weighted moving average. We can say that this is nothing but a modified weighted moving average. This is nothing but a modified weighted moving average. In this case, I am assigning the weights to the recent data, highest weight to the recent data, and in exponentially decreasing order, I'm allocating the weights. Okay, if you try to visualize, if I say the forecasting for any time period or any time period n is equal to alpha into dn minus 1 plus alpha into 1 minus alpha dn minus 2 plus alpha into 1 minus alpha whole square dn minus 3 and so on. So what I'm doing is I am assigning exponentially decreasing order the weights, recent data highest weight, oldest data the weights are decreasing. And what is this alpha value? Alpha we call it as the smoothing constant, and it is having a very important significance of this smoothing constant. Let us have a quick derivation, then we'll be discussing about this alpha value. So if I want to write this expression one more time, I'm taking alpha value to be common. I'm taking this alpha value to be common. Alpha into dn minus 1 plus, if I take alpha 1 minus alpha to be common, minus 2 alpha into 1 minus alpha dn minus 3 and so on. Right, so what will be this? If you try to understand, this is fn minus 1, this is alpha dn minus 1 plus 1 minus alpha f n minus 1. If you try to rewrite this expression, I'll be having fn is equal to alpha dn plus 1 minus alpha fn minus 1. So we can write this as fn minus 1 plus alpha dn minus 1 minus fn minus 1. So by using this expression, I can calculate the forecast for any month just by knowing the previous data. Just by knowing the previous data, I can easily calculate the forecast for the next month, where alpha is smoothing constant, right? And what is this difference of demand and forecast? The difference of demand and forecast is nothing but we call it as error. Forecast error. We call it as forecast error. We'll be discussing this forecast error in later on stages, right? So from here we can say normally alpha value is ranging between 0 to 1. Normally the alpha value is ranging between 0 to 1. But practically it is being seen that we are taking practically we are taking the value of alpha near about to 0.1 to 0.2 practically. And if alpha value is not given, then we can use this relation as 2 upon n plus 1, where n is the period of duration. Okay, that means your 3-month period or 4-month period or 5-month period. So there we can use this expression and get the value of alpha. Now the important thing is, what is the significance of this alpha value? We need to understand that also, right? What is the significance of this alpha and how alpha is playing a vital role in explaining this exponential smoothing? If I talk about alpha, it is 2 upon n plus 1. Okay, take one scenario. I'm having, yes, where d minus fn, yes, right? N minus 1, guys, it is n minus 1. How you can forecast if you want to calculate nth period, how we can use in the nth period? It is n minus 1, right? Okay, clear? Or t minus 1 as a time period. Okay, fine, understood, Surinder? Yes. So now let us take one example. If I'm having two examples, one side I'm having infinite set of values, n is tending to infinity. Second case, I'm having only one value. Which one will be giving more appropriate result, infinite or 1? I'm having one side infinite set of values. Second case, I'm having one set of value, n is equal to 1. So which I'll be preferring? Definitely, sir, more the values of observation, that will be more appropriate for forecasting. If I say n tending to infinity, what's the value of alpha that we'll be getting? If n tending to infinity, alpha will be tending to 0. That means if you try to use this relation, ft is equal to ft minus 1 plus alpha dt minus 1 minus ft minus 1. So here, if alpha equal to 0, we can simply say ft is equal to ft minus 1. That means our forecasting is so stable that every time I need to forecast the same value. By getting this particular expression, what I can infer that every time I need to forecast the same value. And that is the best part. So if I try to have a graph between the forecast or a demand, right? Forecast and demand versus time, versus, let's say, time, right? So with that time, almost I'm having the same forecast value. So this is where using when alpha is tending to 0, and this kind of situation we call it as stable or stability. This condition we call it as stability. When alpha tending to 0, that means your condition is quite stable. Whatever forecasting you will be doing right now, the same forecasting will be doing in the next month. Okay. But let us suppose I'm having n equal to 1. What will be the value of alpha? If I take n equal to 1, the alpha value will be equal to 1. That means if you put this value alpha over here, ft will be exactly equal to ft minus 1 be cancelled out. So t minus 1. That means whatever is the actual demand in the previous one, that same will be used as a forecasting. value. Okay, fine. So here I can say if the demand is also changing, the forecast value will also be changing. So we can say this is highly sensitive, or alpha equal to 1 is your responsive. Okay, we can say when alpha is tending to 1, our forecasting is highly responsive. When alpha is tending to 0, our forecasting is quite stagnant. It is having a constant value throughout the time. But if I talk about alpha equal to 1, it is actually useful where you're having a very, very high fluctuations in the demand occurring. Okay, there I can use this concept of alpha equal to 1. Okay, fine. So I can say that now if alpha it is tending to 0, then we are having a stability condition, right? And when alpha is tending to 1, we are having a responsiveness condition. Okay, responsiveness or responsive condition, right? Okay, and if we want to calculate the value of alpha, if it is not given, so 2 upon n plus 1, you can easily calculate the value of alpha by using this relation. Okay, fine. So let us take one example and let us have a quick understanding of this. Let us suppose I'm having January, the actual demand is let's say 100, and forecasted value they have given us 90, and they're giving the value of Feb. Actual value is 120, and they're asking the forecasting value for the March. Forecasting value of March. Can we calculate alpha? They're giving it as 0.2. Can you calculate this question quickly? Tell me in the comment section what will be the forecast for the month of March. They're having some set of values being given. So very easy, sir. If I want to use an expression of forecast for the month of March, forecast for the month of Feb plus alpha demand for the month of Feb minus forecast for the month of Feb. But the problem here is I don't know the value of forecast for the month of Feb. For that, what I'll be using? I'll be using this expression. Forecast for the month of January plus alpha demand of January minus forecast of January. Okay, so now I can use this expression very easily to get the value of forecast for the Feb. That will be 90 plus 0.2 into 100 minus 90. 10 to this will be 92, right? So now you can use this 92 plus 0.2 into 120 minus 92. So whatever you are getting, that is a forecast for the month of 97.6. Perfect. 97.6. Okay, you can get 1 marks question like this. You can get one more set of values, something like this, that they are let me rub off this. They are not mentioning about the forecast value, and they are saying that you have to calculate the forecast for the month of March. You can have one possibility that they are not giving the value of January forecast and they're asking to calculate the forecast for the month of March. In this case, what you have to do, the assumption is whenever they are not giving the value of forecast for the first month, you have to have an assumption that the demand and forecast is absolutely same. Okay, if they are not mentioning about what will be the forecasting value for the first month, then you have to do the assumption that the actual demand and the forecasted value will always be same for the first month, and by after that now you can calculate the individual set of values. Okay. Demand and forecast will be same. In that case, I think your Feb month will be 100. Then you can solve and you can get the value. Right? So it will be somewhere around 102.4. 102.4, I think. Yes? 20 into 0.2. Done? Okay. Yes. Understood. The very important and easy concept that we need to have a clarity. So next we have to understand what is the forecasting error, because sometimes they're asking question from this forecasting error also, right? What is forecast error? Whatever difference we are having between the demand and forecast for a particular time period, that is the error that you are getting for that particular time period. Okay, so now forecast can be classified under different classification. Okay, so let us talk about the first forecast, that is mean absolute deviation. We call it as MAD. We can call it as MAD also. So we have to take the means average, absolute means, mod of that. So what you have to do, you have to take the average of di minus fi, the mod value divided by n is equal to 1 to n. This will be giving you the mean absolute deviation. This will be giving you the concept of mean absolute deviation. Simple. So what does this implies? This implies that mean absolute deviation will always give the magnitude of the error. Yes, it will always give you the magnitude of error. Yes, they will never ever give you the direction. They will only give you the magnitude of error. That means, let us suppose let's say I'm taking the same example. Okay, they are giving this, so we can calculate the error. So error will be 0, this will be 20, right? So you can take the mod value, it will be having the same. But let us suppose I'm having some error values as minus 10, 20 and 40. So in this case, I'll be taking the mod value. So if I'll be taking the mod value, so they only will be telling us about the magnitude of that error. So mean absolute deviation will always tell us about what is the magnitude of error. They won't be telling us about the direction. So next is your bias. Mean forecast error or bias. This is nothing but the same thing, but you have to now include the negative sign also. This is your bias. Now what is this bias basically telling us about? We can have a negative value or a positive value bias. Dekho, MAD you cannot have. Mean absolute deviation you cannot have a negative value. It will always be a positive value. But bias can be a negative also and positive also. If I say this bias value, if this bias value is negative, what is the meaning of this? If this bias value is negative, then what is the significance that you are able to understand from this particular? Yes, if I say bias is negative, what is the meaning of this? That means on an average, this forecasting value is always more than that of demand. Exactly. Very good, Shashank. I can say on an average, majority of the time, this F value is more than that of D. That is why I'm getting a negative value. So can we say this is a condition for under forecasting or over forecasting? Over forecasting. Over forecasting. This will be the condition for over forecasting, not under forecasting. But on the other hand, if I'm having a bias to be positive, that means on an average, demand is always more than that of forecast. That means I'm always short by some value. That means we are talking about under forecasting. We are talking about under forecasting. Is this clear? So basically bias is telling us about what? It's telling us about the direction of error. Direction of error. It basically tells us about the direction of error, right? Is this clear? Fine, bias. Okay. So third error that we need to understand is your mean square error. Third error is mean square error. That means you have to take the square of the error and take the mean of that. This is we call it as mean square error. Sir, what is the significance of this? Do you remember we have studied in PERT CPM? We have studied a very interesting term called as variance, right? So here also, and standard deviation, here also if I say standard deviation of the forecasting, we can easily calculate by taking the under root of the mean square error. So by using this formulation, I can calculate the standard deviation. I hope so now you have understood what is the significance of standard deviation. Standard deviation tells us about how much fluctuations we are getting from its mean value, right? Or from the mean square error, we can say we are talking about the variance. That means how much uncertainty we are getting in that particular value. So that is the physical significance of standard deviation and variance. Okay, fine. And it is being very effectively being used. How where you're using? We are using this to plot the control chart. What is control chart? Control chart is like you might have seen in your production engineering. Let us suppose I'm having a mean value, I'm having an upper limit, and we are having a lower limit. Okay, we always say that the maximum value will always be lying near about to the mean value, and minimum value will be lying near about to the upper and lower limit, right? So how we can calculate this particular range, upper and lower limit, that we can calculate by using the concept of standard deviation. That particular concept we can use by using the concept of standard deviation, right? Fine, is this clear? Okay, fine. So now let's talk about the next one is mean absolute deviation. Mean absolute deviation. Now, mean absolute deviation means you have to take the percentage error of this one. So that is d minus f divided by d into 100 mod of that. You have to add from I is equal to 1 to n divided by n. This is your MAPE. We call it as mean absolute percentage error. What is the meaning of this? It simply means that if I say I'm having 40 out of 100 and 40 out of 1000, definitely these are having two different significance. If I say I'm having a value as 40 out of 100 and I'm having a value 40 out of 1000, so definitely these two are different. It is 40%, this is only 4%. Is this clear? So whenever I'm talking in terms of percentage perspective, there I'm using this concept of mean absolute percentage error. That is, we call it as MAPE. And the last one is your tracking signal. What is tracking signal? That is equal to summation of I is equal to 1 to n di minus fi divided by summation of I is equal to 1 to n mod of di minus fi divided by n. That is nothing very bad. So we can say bias can be written as running some forecast error divided by n, or we can say summation of I is equal to 1 to n di minus fi divided by n. Okay, so bias can also be written in terms of running some forecast error. That means you have to take the summation of all the errors, right? If you take the average, that will be bias. So if you take the ratio of running some forecast error to the mean absolute deviation, then we can get the tracking signal. What is the significance of tracking signal? If you are the owner of the company, right, you will be hiring some forecasting or forecasters. So definitely are those forecasting the exact value or how much deviation is happening, that particular parameter is your tracking signal. That means your forecaster is predicting the correct values or not. Is it performing a good, it is able to forecast better values. So this tracking signal help us to identify exactly. It helps us to identify whether my forecaster is forecasting a better value, right? So it is being seen that the tracking signal is always ranging between plus minus 3 to plus minus 5. Then we can say this is a good, we can say better forecaster, and ideally the tracking signal should be equal to 0. That means, let us suppose there are two forecasters. One forecaster is having a tracking signal of 10 value. Second forecast is having -1. So definitely I'll be hiring that forecaster which is having closer to plus minus 3 or plus minus 5. Okay, I won't be hiring that forecaster which is having a value of tracking signal of 10, because that will be having a huge deviations will be getting from the forecasting value and the demand. Okay, so this is actually helping us to identify whether the forecast is forecasting exactly. Which method is best method to predict the error? Actually, every error is not, we are talking about different types of error. Each error is having its own significance. If I talk about mean absolute deviation, it tells about the magnitude of error. If I talk about mean forecast error or bias, it tells about the direction of error. Are we going for over forecasting or under forecasting? Because by using mean absolute deviation, it always be a positive value. you never ever gonna get, am I going for an over forecasting or under forecasting? So every particular discussion that we have did is having its own significance. Okay, so this basically helps us to identify the magnitude of error. This helps us to identify the direction of error, right? This helps us to identify the standard deviation of the error. This helps us to identify what's the percentage variation that is being occurring from the absolute value. And the last one is tracking signal, which is basically helping us to identify whether the forecaster is forecasting the value appropriately or not. Is this clear? Okay. Yes. Exactly. Mean absolute deviation is, which is basically we are using to calculate the magnitude. Okay. Fine. And individually, every particular term that we have discussed is having their own significance. Right? Perfect. Okay. Yeah. Right. So now let's move on to your queuing model. Oh, sorry. This is, we already have covered sequencing done. Yes. Now let us talk about as tomorrow we are having the mock test. So I thought let us have a directly questions will be discussed there only, because I think 100 questions will be discussed, and industrials shall be taking approximately 15 to 20 questions. I think that is more than sufficient. That will be covering each and every topic. Okay, tomorrow we'll be having the mock test, 100 questions from each and every faculty, 20 questions per faculty, I think. So definitely there you can have a quick revision, and I think that is more than sufficient. Industrial ke liye more than sufficient. Okay, so now let us talk about queuing theory. What is queuing theory and where we are using this queuing theory concept? It's a very small topic, but students do have some difficulties in queuing theory also. Actually, in queuing theory, you might have observed that sometimes, like when you go to railway station, you might have seen that sometimes all the counters are open and sometimes only few counters are open, right? Or when you go to mall, when you go to food court, you are seeing there are 4 counters, but only 2 executives are standing in front of counters. Not all 4 counters are operational. So there, what I'm doing is, I'm actually having an economic balance between the cost of providing service and cost of waiting. Because in weekdays, let us suppose I'm having 4 counters, right? Let us suppose I'm having 4 counters at the food court, right? Let's say I'm talking about KFC. I'm talking about Kennedy's Fried Chicken, KFC, 4 counters are there. And I'm talking about Wednesday afternoon, 1 p.m. Wednesday, 1 p.m. Weekday. So is it a wise option to have all the counters open Wednesday afternoon, a weekday? Is it a wise option, wise decision to open all the counters, or only one executive is self-sufficient to run our system? Yes, only one, right? It is not a wise decision to give all, because if I'm allowing all the 4 executives to stand, I have to pay the salary to them. Yes, no doubt, when a customer is coming, he don't have to wait. They don't have to wait, but the inflow rate of the customers during weekdays is not that high. Okay, right? So what you can do is, you can have at least 2 executives, right? 2 executives is more than sufficient to operate on weekdays. So you have saved some money. Let us suppose if by some reason, if some customer is coming, there might be a possibility. Let us suppose there was a college class. They have bunked the class and they are going to outlet, and there's 60 students. So suddenly 60 students are coming. So these 2 executives won't be able to give the service. Okay, so it is actually a wise decision, because it is not always possible that every student will be bunking the class every day. It's a once in a while. Okay, so what is happening? I'm actually having the waiting time and cost of providing service. I'm making an economic balance. But on the other hand, I'm talking about Sunday evening, peak time. I'm planning, let's try to save some money, and I am only allowing 1 executive. Is this a wise option? I have to pay only salary for 1 executive. So This might be a wise decision. Yes. Sunday evening, KFC. So, yes. Why no? Why no? From my perspective, it's good because I have to pay the salary for one executive. Big. Okay. Exactly. Maximum possibility is that many customers will be seeing the, "Arey yaar, bahut bheed hai, very large queue. Let us go to McD, let us go to Burger King and have some burger today. I'll be coming in some other day." Okay, fine. So what happens that the waiting time, okay, here the cost of providing service I have decreased, but by doing so the waiting time has increased, and by increasing the waiting time, I would rather say 80% of the customers won't be placing an order because there will be a huge crowd. Okay, either I'll be having a complete loss, right, or I have to shut down the shutter because it will be full of college students. Might be they could get angry. It's better let's have all the executives standing and placing the orders, and I'm getting perfect economic balance. So now what we have seen that sometimes some counters are operational, sometimes all the counters are operational. So definitely I need to have a proper balance between what I am providing the service, right, the cost of providing the service, and the waiting time. And this balance, economic balance discussion, we'll be discussing in this queuing theory. Okay, in queuing theory, we are basically having an economic balance between cost of providing service and the service time. It is applied to the service oriented organization. That means it is being applied to food courts, your workshops, right, ATM, okay, your banks. You can use this particular railway stations. You can apply this particular concept to all this service oriented organization. Okay, where we can say customer is taking service from the company. Okay, there we're using this concept of queuing theory. So here I'll be having, let's say this is a scenario you might have seen. This is an ATM bank, I think. Okay, this is an ATM bank, and it's a huge line that is being seen. And if a person, let us suppose, he wants to open a bank account in this HDFC bank, he'll be saying, "Arey, better I will be opening my bank adjacent. There is one more bank, ICICI. I'll be opening my bank there only because there's a huge crowd always." Right? Okay, fine. Let's say in this case also, it's basically a peak time in the bank. Right? So you can see there's a huge crowd in this counter, even in this counter. Okay, so whenever there is a huge crowd, in that case, I need to operate multiple counters simultaneously. You might have seen that in banks, when you are trying to enter, there are some counters which is having the same role. That is, if you want to deposit the cash, there will be some set of counters from counter number 3 to counter number 8. You can give the cash and you can have that receipt. Okay, it's not like there will be only one counter to submit or deposit the cash. Okay, so how many counters should be operational? That calculation is being done by using this queuing model. Okay, fine. So what is this queuing model? Here we are having a concept of system. We are having queue. We are having server. What is the meaning of these words? And we'll be having a calling population, right? So what happens? We are having a calling population. We are having a population, we call it as calling population. Calling population. From this calling population, some customer will be arriving to our system. Some of the persons will be, these are, let us suppose, server. That means the person who, or the executive which is providing the service. And there are some person who are taking the service. And there are some person who are standing in the queue. Okay. So these are the person who are standing in the queue. These are the person who is taking the service. These are, we call it as servers. That means the bank associate, the executive in the food chain, right? So here, and after taking the service, you're going out of the system. Okay, fine. So here we need to understand there are two very important aspects. One is arrival rate, and second is your service rate. Arrival rate, which is basically denoted by lambda, and service rate or service pattern, which is denoted by mu. It is being seen that arrival rate as it is following a random. It's not like this in the banks. They'll be saying only those customers will be entering whose name is starting from A. No. Any bank, any customer, that could be from other branches also, they can definitely go to that particular branch. So definitely the customer arrival rate is normally random. So as this is random, so it always follows a Poisson distribution. But in case of service, it always follows a negative distribution. What's the meaning of this negative distribution? If you try to visualize, let us suppose you are entering the bank and you are the only customer in the bank. So definitely the bank executive will be saying you would like to have a cup of tea, you would like to have some other, they'll be telling about some products, about the features about their banks. But let us suppose you are standing in the bank and behind you there are 100 persons standing in the queue. At that point of time, the bank executive won't be asking you whether you will be having a cup of tea. Right? Okay. Because if the number of customer is more, in that case, they will be only taking whichever service is required. So service time will be very less. When the number of customer is low, then the service time is very high. That means I'll be taking half an hour or 20 minutes. I'll be giving to that particular customer if the number of customers are low. So that is the reason we are always following a negative exponential distribution. Is this clear? And remember, very important thing, that is the units. We always take the units as customer per time. Okay, this is customer or jobs per time. That will be per hour also, per minutes also, per second also. That depends, right? Usually you can convert into per hour because that basically helps us to calculate very easily the calculation. Okay, let us take one example. Let us suppose I'm having that the customers arrives after every let's say 6 minutes. So can you tell me what will be the arrival rate? That means after every 6 minutes the next customer is arriving. So can you tell me what will be the arrival rate? That means customer per tell me in number of customers arriving per hour. In 1 hour, how many customers will be entering the system? Per minute, I can say 1/6 customer is entering per minute. If I want to convert into hour, can I say 10 customers will be entering the system in 1 hour? Yes. So I can say this 6 minutes, we call it as the inter-arrival time. We call it as inter-arrival time, that is 1 upon lambda. Okay. Second one, let us suppose I'm taking that the service time is let us suppose 4 minutes. That means you take 4 minutes to serve a customer. So can you tell me what will be the service rate? What will be the service rate? Which we are taking it as mu. Anyone? What will be the service rate? If I'm taking 4 minutes to serve a customer, so what will be the service rate? Let's say the unit is customer per hour. In 1 hour, how many customers you will be able to serve? In 1 hour, how many customers you will be able to serve? Sir, 15 customers. 60 divided by 4. So in the questions, they won't be giving you lambda and mu directly. Majority of the time, they'll be giving you time, inter-arrival time, or the service time like this. Okay, we can call this as service time or inter-service time. Okay, fine. Is this clear? Now, here we are discussing very important discussion about yeah. Chalo, let's take this. Nahi hoga. Pata nahi kya hota hai. Okay, let's take this particular space to have this clarity. Let us suppose arrival rate, if it is more than that of service rate, then what will happen? If arrival rate is more than that of service rate, then what will happen? That means let us suppose 10 customers arrive in 1 hour and 3 customers per hour you are able to serve. What will happen? If arrival rate is more than that of service rate, then gradually the length of the system will increase. Gradually the length of the queue will increase, right? Or we can say we'll be having one point when the system become unstable. And queuing model, we are discussing for the stable model only, right? So always remember that lambda will always be less than that of mu, and this is, we call it as a stable system. This is, we call it as a stable system. Is this clear? Clear? And all the discussions that we are doing is for the stable system only. So if I try to have a very important we can say terminology, that is your utilization factor, rho, that is equal to ratio of lambda by mu. What is this rho signifies? It tells us about the percentage of time the server is busy, or we can say the percentage of time or the probability that the new customer has to wait. Let us suppose if I say lambda is equal to 5 and mu is equal to, let's say, 20. So rho is equal to 5 by 20. Let's say this is customer per hour. This is customer per hour. So this will be equal to 0.1. What's the meaning of this? That means 10% of time the server will be busy. The server will be busy. That means if the server is busy for 10% of the time, that means, can I say, when a new customer is entering the system, he'll be seeing that the server is busy. That means he has to wait. So I can simply say it also means that the probability that the new customer will have to wait. This is basically the meaning of rho. This is basically the meaning of utilization factor, traffic intensity, right? There are many multiple names, but normally we are using this term as utilization factor. Okay. So if I say 10% of the time the server is busy, can you say at what percent of time the server will be idle? If I say 10% of the time the server is busy, can you tell me how much percentage of the time the server will be idle? Simply say 90%. So I can say that 1 minus rho is the probability that the server is idle. Or can I say the probability that the new customer, does he need to wait? Yes. If I say 1 minus rho, it is a probability that new customer has to wait, or yes. Yes, the new customer does not have to wait. New customer does not have to wait. Or I can say it is nothing but the probability of zero customer. Probability of zero customer in the system. Right? That is the reason we are denoting it as P0. It is a probability that there are zero customer in the system, or the new customer does not have to wait, or the probability that the server is idle. So that is basically the physical meaning of this rho and 1 minus rho. Okay, fine. Now the next formulation is very important. So the probability that the system is idle, probability zero customer, that is P0, 1 minus rho. What is the probability of having exactly n customers in the system? So Pn is equal to probability of one customer in the system is equal to rho to the power n into P0. This formulation will give you what is the probability that there were exactly n customers in the system. Let us take one example. Let us suppose your lambda value is 3 customer per hour and the service rate is let us suppose 9 customer per hour. Okay. So what is the probability that there are exactly 2 customers in the system? Can you tell me? Probability of exactly 2 customers. So for that, always remember, whenever you're solving any question from queuing model, always you have to calculate the value of rho. Okay. So what is rho? Rho is equal to lambda by mu. Right? So from here I can calculate this as 1 by 3. And what is 1 minus rho? That is 2 by 3. So they are saying the probability of exactly 2 customers, that is equal to rho to the rho square into 1 minus rho. So from here I can get the value directly. है ना. Rho square is 1 by 3 whole square into 2 by 3. So from here I can say 2 by 27. This is the probability of having exactly 2 customers. This is the probability of having exactly 2 customers, which we can easily calculate. But the problem here is, let us suppose I'm having, we know that as the probability, the summation of all the probabilities will always be equal, or will always be equal to 1. Right? The summation of all the probability of exact 0, 1, 2, 3, 4, n number of customers will always be equal to 1. Okay. So if I ask you a question, what is the probability of at least 3 customers in the system? What is the probability that there are at least 3 customers in the system? Can you tell me? What will be the probability that there will be at least 3 customers in the system? That means you are basically asking at least 3 customers means 3 and more than that 3. So P is n is greater than equal to 3. That means I'm talking about P3 plus P4 plus P5, so on till the nth value. But it is not practically viable to calculate this value. What we can do is, I can say this is 1 minus P0 plus P1 plus P2. So by this, I can now calculate what is the probability. What is the probability that there are at least 3 or more than 3? Okay, so what we can do, you can calculate the probability of 0, 1 and 2, subtract by 1, that is the probability of having 3 or more than 3 customers, right? So what is P0? That is 1 minus rho. What is P1? It is rho into 1 minus rho. What is P2? Rho square into 1 minus rho. So from this expression, now we can easily calculate what is the probability of at least 3 customers. That means up to 2. P0, 0 customer, 1 and 2, that you have to subtract from 1. But on the other hand, if I say, if I'm having what is the probability of at most 2 customers? Yes. What's the meaning of this word? At most 2 customers. At most means max to max you can have 2 customers. You can have 0 also, 1 also, 2 also. So that means it will be equal to P0 plus P1 plus P2. That's it. Okay. Up to 2. Perfect. Up to 2. Is this clear? Very good. Up to 2. Okay. Fine. Chalo. Now, average number of customers in the system. That means they are saying what is the length of the system. Average length of the system. Average length of the system, which we have denoted as LS. So LS is equal to rho upon 1 minus rho. This is the average length of customers in the system. So that we can calculate by using this relation as rho upon 1 minus rho. If I want to calculate what is the average number of customers in the queue, that is denoted as LQ. Okay, so that is equal to rho square upon 1 minus rho, or we can say this is equal to LQ is equal to rho times LS. We can write it like this also. Rho times LS, right? Fine. And after this, we'll be having a discussion of the Little's law. Very important, because normally question is being framed from that particular topic. Okay. What is this Little's law? It states that for a steady system, the length of the average number of customer, it is equal to the product of the arrival rate and the waiting time. That means L is equal to lambda times the waiting time. So if I want to write for length of the system, then I have to take the waiting time of the system. If I want to write the length of the queue, then I have to write the waiting time of the queue. So from this particular expression, I can easily calculate what is the waiting time of the system and waiting time of the customers in the queue. Average waiting time. It's not exact value. It is the average waiting time, right? But sometimes what happens, they are not giving the value of, you have to calculate the waiting time of the system or waiting time of the queue. So there it is being observed that, if nothing is mentioned, right? If nothing is mentioned, then mean value, it is only applicable if in the question they have not mentioning. So can you tell me, if I talk about mean, I'm talking about system or queue? If I'm talking about mean, I'm talking about system. That means you have to calculate the length of the system or waiting time of the system, or waiting time of the queue or length of the queue. Yes, mean value and average value. Quickly, those who have studied, let's have a quick revision. If nothing is mentioned in the problem, then mean value we are taking for queue or system. A simple question. If they are mentioning, then it's okay. If they are not mentioning, then what you have to do? Yes, Baumik, Mithun, Sujish, everyone. If nothing is mentioned in the problem, then mean value you will be taking for queue and average value you are taking for the system. If it is not mentioning, okay, fine, we are taking the average value for the system and mean value for the queue, right? If they are not mentioning, if they are mentioning, then it's okay. If they are mentioning, then it's okay. Like in this case, if they are mentioning that what is the average waiting time of the queue in the system, then that means they are talking about WS. Or they can say that what is the average waiting time of the queue. That means they are mentioning about the queue. That means they have to calculate the WQ. Okay, fine. After this, there are some other empirical formulation that you have to understand. What is the probability that customer more than T time period will be required? That means what is the probability that the time period T is more than required to service a customer? Okay, that means we can say it is equal to exponential to the power mu into D. One thing you have to understand that if mu is given in per hour, then you have to take the time period in hour. Remember this, okay? Because if it is given in minutes, you have to convert this capital T in minutes, right? Talking about what the probability that waiting time of the queue is greater than that of queue. That means probability of waiting time of the queue is greater than some time period T. So this is equal to rho times e to the power minus T by WS. Okay, I think this is given over here. Fine. If I want to calculate what is the waiting time of the n arrivals in the system, we can use this relation and you can calculate what is the probability that n customers are arriving in some specific time. N customers are arriving in some specific time. You can use this equal to e to the power minus lambda into t, lambda into t to the power n divided by n factorial, rarely being used. But you should be knowing at least this. And the last one is probability that the waiting time of the queue is greater than that of system. Waiting time of the system is more than that of t time period, e to the power minus t divided by ws, where ws represents the waiting time of the system. Okay, so let's take one example over this so that you should be knowing how to calculate questions from this topic. Now let us read the question. A railway reservation counter has 20 counters. Okay, a railway reservation block has 20 counters. The peak arrival rate is 150 per hour. The service time is exponentially distributed with the mean value of 5 minutes. So can you tell me what will be the service rate? What will be the value of service rate? Anyone? If 5 minutes is the for servicing one customer, so can you tell me what is the service rate in hour, customer per hour? Sir, 1260 by 5, 12 customer per hour. Okay, now what is this value being given? Can anyone who can tell me? What is this value being given? Arrival between 0 to t. I think that expression we have already been seen. Okay. Acha, arrival wala? No. We are talking about with respect to this. Yes. Sharma ji. Yes. Now, what is this lambda? Is it lambda? Is this 150 per hour as lambda? Sure. Pakka? Tell me. Is this 150 per hour given as lambda? If it is lambda, then the system is unstable. Then how we can solve this question? Mu is 12 customer per hour. Then how you can have 150 per hour as a lambda value? Getting the question? Now they are saying that a railway reservation counter has 20 blocks. If the waiting time in the queue is limited to 15 minutes, that means they are saying in one counter, I am allowing 15 minutes as the waiting time on the queue. Determine the number of counters that need to be kept open. An equal distribution of customers to all counters. That means if I say, if I'm opening out of 20, if I'm opening n counters, so arrival rate at each counter will be 150 by n. Right? So I need to calculate this value of n value. This is the total arrival rate, right? You have, and this is we are talking about for per counter, 12 customer per hour for one counter, right? So you need to calculate what is the value of n. What is the value of n that we need to calculate? So WQ they have given. We know that what is the length of the queue, right? The length of the queue is rho square upon 1 minus rho. What we have to do is, let us write this in lambda and mu terms. So we can say this is equal to lambda square by mu square divided by mu minus lambda by mu. So ultimately what we are having, the length of the queue is lambda square by mu into mu minus lambda. Okay. Fine, you know the value of WQ. So what we can do is WQ is equal to LQ by lambda. We know this expression, one lambda will be cancelling out. So this will be lambda upon mu into mu minus lambda. This is the waiting time of the queue. Now you can place all the values. Waiting time of the queue is 15 minutes. So that means 15 by 60, because everything you are calculating in per hour. Lambda is 150 per hour, that means 150 by n divided by mu is how much? Mu is 12 into 12 minus 150 by n. After solving it, you will be getting the value of n, and that is the number of counters that I need to keep open, kept open in order to have a waiting time of 15 minutes. Is this clear? Have you understood how we are using the concept of queuing theory in the railway reservation counter? This is actually we are using to have the clarity. Okay, this we are using to have a clarity of the queuing model. Okay, clear? Right? Like how many counters we need to keep open in weekdays. Same thing we are discussing over here. Okay, fine. I think this will be somewhere around 16 point something. If I try to calculate 16 point something 7, so we can say the next value is 17. So you need to open 17 counters in order to have a waiting time of 15 minutes. If 17 counters are open, then the customer will be having a waiting time of 15 minutes. So till date, GATE, they have not asked any question like this. So definitely you can expect this type of question this year. I'm not saying surely, but as they have not yet asked this pattern of question from queuing model, so if they can ask this kind of question, definitely. So now you are having a clarity how to solve these type of questions very easily. Okay, fine. So now let's proceed to the second last topic, that is transportation. Then we'll be going for the assignment. Now what is transportation model? Transportation is, we're having some factories. We are having 16.67, perfect. Thank you. So 16.7, I think that was the answer which I remembered that value. Okay, so 17. Acha, chalo. So we are just entering into the almost the completion value. 6:30 is the estimated time of completion. So I think the probability of completing will be a higher value, 98%. Z value is 2. Okay. I'm getting a Z value of 2 that I can complete this particular session by 6:30. Okay. Chalo. Can we proceed? Arey bhai, haan na bolo yaar. Yes. Fine. Okay. So now let's enter into the transportation problem or transportation model. Now in transportation model, what is happening is we always try to, because we are studying industrial engineering, so we should be having an optimized approach, right? We should be having an optimized approach. So whatever we are doing, like when we were had that 2 o'clock wala break, that was exactly at 2 o'clock. वो तो by default हो गया. I was not planning to have a break at 2 o'clock, but I think industrial engineering का effect हमारे session में भी दिख रहा है. Okay, fine. चलो. Now, in transportation, what is happening is, let us suppose I'm having 3 factories, and some products is I'm sending from factory 1 to factory warehouse, factory 2 to warehouse. So individually we'll be having some cost. Let's say C1, C2, C3, C4, C5, and C6. That means sending some product from factory 1 to warehouse 1, it will be costing some amount C1 per unit. Sending 1 unit of some product from factory 1 to warehouse, it will be costing me C2 rupees. So definitely I can have different combinations which can be possible in from sending some units from factory 1 to warehouse, right? So in transportation model, out of all these possibilities, which is the best combination that I'll be having the minimum cost? I'll be having this minimum cost. So in this case, transportation model is always, we are, or maximum time we are always dealing with minimization problem. So this we have already discussed in our simplex also, but only slight special case that we are having is we are sending some material from factory to warehouse, and definitely every material from one factory to one warehouse will be having some cost. So I need to have that what should be the proper allocations of the units so that I will be able to send whatever is demand and what is the supply. So here I'll be talking about, let's suppose I'm talking about factory 1, factory 2, factory 3, and this is warehouse 1 and warehouse 2. Let's suppose for sending one product from factory 1 to warehouse 1, it is costing me rupees 10, this is costing me rupees 3, this is costing me rupees 6, 7, 2 and 11. Okay, rough meaning. So that means if I send a product from factory 1 to warehouse 1, it will be costing me 10 rupees for 1 unit. If I send from factory 1 to warehouse 2, it will be costing me 3 rupees for 1 unit. So I need to have, let us suppose the total supply that factory 1 can do is 50 units. Total supply that F2 can do is 30 units, and here we are having 20 units. That means this is the total capacity of factory 1, factory 2 and factory 3. Warehouse definitely will be having some capacities. Let us suppose the warehouse 1 capacity is 70 and warehouse 2 is having capacity of 30. Okay, so can we say this is the total demand? That means 70 plus 30, and this is the total supply that I'm able to provide. So in this case, can you tell me the total supply and total demand, are they same or different? Let's check. 50 plus 30 plus 20, 100. This is 100. Let us suppose this is total demand that we are having from the warehouse is 70 plus 30, that is also 100. So that means here the total supply and total demand is exactly same. So this kind of situation, this kind of problem where the total demand and supply are same, we call it as a balanced transportation problem. Okay, very easy. We can have a possible scenario that, let us take one example. Yeah, this one. We can have a possibility that warehouse 2 is only having a capacity of 20 units, warehouse 1 is 70 units. So in total, we'll be having 90 as a demand. But factory wise, I can supply 100 units. So there is a shortage of 10 units in supply or demand. There's a shortage of 10 units in supply or demand. We're having a shortage in the demand. So what we can do is whenever, and this kind of problem we call it as unbalanced transportation problem. So whenever we are tackling from this particular kind of situation, what I do is I'll be introducing a dummy demand because there is a shortage in the demand. So I'll be adding one dummy demand which is having capacity of 0 or capacity of 10, and it is having a cost 0 only. okay, because it's a dummy, it's not real. So I'll be adding one dummy column will be added, which is having capacity of 10. So now I can say 90 plus 10, 100. Now it is converted into a balanced transportation problem. Okay. A question was asked in GATE also, 1 marks, that they have given some values of total supply and total demand. They ask what should be the dummy added to the demand or to the supply. Okay, I think that is very easy to now solve, right? So now, in order to calculate the possible solutions, we need to have there are some models that we can use. Okay, fine, thank you. I want appreciation from all of you. Main appreciation is from my students. So maza aa raha hai? Are you liking this session? I think that energy is maintained. Energy में कुछ कमी हुई तो please do let me know in the comment section. Okay, if there is some energy का कुछ कम होना, that is okay. चलिए. Fine. So now let us talk about the transportation problem. Now, transportation model we can solve by using 4 or 5 different techniques. Okay, we are having 4 to 5 different techniques. Least cost method, northwest method, Vogel's approximation, row minima, column minima, very easy. These are very easy. I'll be telling few points, right, about individual one, and I think you will be able to understand. Let us start with the first one is northwest corner rule. If I use the northwest corner rule, what's the meaning of northwest corner rule? If I try to see, this is north, south, east, west. So northwest will be extreme left to the top. Extreme left to the top. So that means I will be doing the allocation every time extreme left to the top. Now, first of all, tell me, is this a balanced model or not? Try to check. Yes, it is in the syllabus, but okay, we'll be discussing it in a quick manner. Okay. Is it a balanced one? Please check. 16, 28, 38 plus 5, 33, I think. Hai? Add these. 32. Sorry, this will be 43. 43 and this will also be 43. Hai? 43 and 43. Balanced one. Yes, perfect. It's a balanced one, right? So now I can say that it's a balanced one. Now what will be doing? I'll be allocating from the top left corner. So the top left corner is this one. So how much I can allocate? Now this particular, let's say this is your demand 1, demand 2, demand 3 and demand 4, and this is your factory 1, factory 1, factory 2, factory 3. So demand 1 or warehouse 1 is having a capacity of 6. Factory 1 is having a capacity of 11. Can you tell me how much allocation will be doing? Will be only able to allocate 6. Why? If you allocate 11, it is not possible because we are having a total capacity of 6 only. So this is being completely allocated. So this is being removed. So now we are having how much left out? 5 units being left out. So column number 1 striked off. Again, extreme left, northwest corner. Extreme northwest block is this one. How much we can do? We can have a possibility of 10 and 5. So definitely I can take the shorter value, that is 5. So this is being completely allocated, right? And how much is left? 5 is left out. Okay. Next, extreme left corner. Now we are having this unit, this cell as the extreme left corner rule. So here I can allocate either 13 or 5. I'll be going for a lower value. 5 is being allocated. So here I'm having 8. Done. Extreme left, top left corner. This is the only cell we are having. 8 and 12 will be allocating 8. So this is completed. And we are having 4 units. So this is done. So we are having 4 over here. We'll be having 15 over here. So this is the complete allocation done. This is the total allocation. So if I want to calculate what is the total cost that we are getting, the total cost is, what will be that? You just need to multiply. This is the 21 rupees for 1 unit. I'm sending 6 units. So I can say 6 into 21 plus 16 into 5 plus 18 into 5 plus 14 into 8 plus 18 into 4 plus 41 into 15. So whatever value you are getting, this is the total cost, 1095. Perfect, yeah, very good. Thank you. 1095 rupees if I'm going for the northwest corner rule. Okay, northwest corner. This is the total cost that will be getting. Okay, काम करते. If I try to take row minima, what is row minima? It's quite easy. In every row, I try to identify the minimum cost cell. This is the minimum cost cell. This is called as cost cell. We try to allocate maximum possible allocation. So maximum possible allocation will be 11. So this way we go for row minima. If I talk about this one, column minima is, I'll be going row, column wise. Column number 1, minimum is this one, 17. I'll be allocating maximum. Until unless complete column is being allocated, I won't be shifting to second column. Like in case of row minima, unless and until every row will be, this particular row will be allocated, that if I say 11, so I can allocate 11, so row 1 completed. Now you can go for row number 2. Here we are having minimum as 14. You can have an allocation of 12. But if you try to allocate 12, still 1 unit is being left out, so you will be allocating 1 over here. So this is your, we can say, column minima. This is an interesting one, least cost or matrix minima method. What is happening in least cost or matrix minima? We only need to identify from entire matrix the least cost. From entire matrix, the least cost is over here. So maximum possible allocation will be 11. Done. 4 left out. Next one is least value is 14. Okay. Maximum possible allocation that we can do is 12, 0 and 1. Done. Next least value is 17, but here only one possibility, 1, this is 5. Okay, this is also done. Okay, so by this way you can go with the least cost method. Okay, next is minimum is 27, we'll be having 10, we'll be having 5, we'll be having 4. Allocation done by using the least cost method. Allocation is being completed by using the least cost method. Now we can calculate the total cost just by 13 into 11 plus 1 into 17, 12 into 14, 35 into 5, 27 into 10 and 41 into 4. Okay. But the interesting part is the vowels. This is important. This is important because normally it is being observed that out of all these 5 methods, I am getting the minimum cost in vowels approximation. I'm getting the minimum cost in vowels approximation, and this is also called as penalty method. We call it as penalty method, right? So what is this vowels approximation or penalty method? Let us take the same example. So what we try to do, we try to calculate the penalty. What is penalty? Penalty is second minimum minus the minimum. Let's say if I talk about in row number 1, what's the difference between second minimum and the minimum value? Minimum is 13, second minimum is 16. If you take the difference, 16 minus 13 is 3. Minimum and second minimum, 14 and 17, again 3. Minimum and second minimum, 18 and 27, that is 9. Now go column wise. In this column, 13 minus 23, 10. 14 minus 18, 8. 16 minus 18, 2, and 21 minus 21, that is 4. Okay, so we have calculated the penalty. Okay, yes, please check and please do let me know anyone having any doubt how to calculate the penalty. Done. Okay, so what we do, we try to identify the maximum penalty value. So maximum penalty value is this one. So we try to move in this particular row or column, whichever we are having. In this case, I am having a column. So in this column, we try to identify the minimum cost cell. The minimum cost is 13. Maximum possible allocation that we can do it over here. What allocation that we can do? We can do how much allocation? 11 or 15. In this particular column, what should be the maximum allocation? This is 4. Thank you. Yes, 11. If this is 11, this is completed, only 5 left out. So we'll be eliminating this particular. Again, calculate the penalty. Now this is same row only, so we'll be having the same value 3, 9. Here now the values will be changing. 41 minus 23. 41 minus 23, that will be 8, 18. Next 4, 9. This will be 15. Yes. So among all these values, the maximum value that we are getting is over here, right? Try to allocate. Minimum cost cell is 23. What should be the allocation that I need to do? How much allocation that I need to do in this particular cell? Because only 5 left out, there is 13, so I'll be going for the minimum value, that is 5. So this is completed. So this is, we are having 8 left out, so this is done. Okay, fine. So now let us again calculate the penalty. Minimum, second minimum is 3. Minimum and second minimum is 9. This is again 4. This is 9. And this is 15. Right? So you'll be selecting this particular column because it is having the maximum value. So 17 will be my allocation. So here I can have an allocation of maximum 6. 0, 2 left out. Okay, done. Fine. Next, we are left out with only 2, right? So 2 is left out. If I now calculate, this will be 9, this will be 4, this is 4, and this is 9. So we can have 2 possibilities. This is 9, and this is also 9. Okay, so if I go in this way, 18 is the possibility. In this way, 18 is the possibility. So you can see same values. Okay, so what we can do is you can allocate 2 over here. So 8 left out, 8 over here. If you allocate 8 over here, then you have to allocate how much? Is there any calculation mistake that we are doing? No. This is this is already we have seen now. 1 second. First of all, we did 8. So 8, we're having 2. 2 is left out. So we can allocate in this particular, this is 18 and this is 14. Okay. So how much we can allocate? We can allocate 2. If we allocate 2, we are having 8. If we are having 8, then we have to allocate 12. 20. Kay mistake ho raha hai. Can you tell me where's the mistake that we are having? First allocation. Exactly. 4 hai na ye? This is 4. Yes. 4. Wahi bola na? If you commit mistake, you will be having that particular will be observed. That will be 9. So here we'll be having 6. Here we'll be having 3. Here we'll be having 3. Here we'll be having 7. Okay, 7 and 12. Now it's okay. Yes. Done. So now we have completed our allocation by using the Vogel's approximation. You can cross check at any point. 12 plus 7, 19. 6 plus 3, 9 plus 4, 13. 11, 11. You can do it like this also. 6, 10, 12 and 15. Yes. Fine. Allocation done. So this is your Vogel's approximation method that we have used. And after this, you have to check the optimality. Now, for optimality checking, there are 2 conditions that you need to check. First is your, to check optimality, condition, there are 2 conditions that we need to have. That is, your solution should be non-degenerate solution. Non-degenerate solution. And second one is, you should be having an allocation should be at independent positions. Allocations at independent locations. Now, what is the conditions for degenerate or not degenerate solution? Not degenerate solution means your m plus n minus 1 should be exactly equal to the size of the matrix. Or we can say not size of matrix, number of allocation. Number of allocation. If this condition is satisfied, then our solution is not degenerate solution. If this condition is not satisfied, then it is a degenerate solution, where m and n are the number of rows and columns. M and n are the size of matrix. Okay, fine. So if you try to understand here, the allocations are 1, 2, 3, 4, 5, 6. Number of allocation is equal to 6. Number of allocation is equal to 6. What is m plus n minus 1? What is m plus n minus 1? It is 4 cross 3 matrix. So 4 plus 3 minus 1. It's a degenerate or not degenerate? It's a non-degenerate solution. It's a non-degenerate, so because number of allocation is exactly matching with m plus n minus 1. So our first condition is being satisfied. That is, it's a non-degenerate solution. Okay. Second condition is allocation should be at the independent position. What is the independent position? That means you should never ever able to make a closed loop by taking all the allocation, by taking horizontal vertical lines. Let us suppose if I start from here, right? Not possible to make a closed allocation, right? Fine. Or if you want to take from this point, not possible. So independent allocations means you are not able to join the cells where allocation has been done by using horizontal and vertical lines, and you making a closed loop. If you're not able to make a closed loop, that means the allocations are at independent positions. That means we can say not forming a closed loop. Closed. Okay, not forming a closed loop, right? So now we have seen that both the condition is being satisfied. Now you can use the Modi method or UV method in order to check whether the solution that I have calculated by using Vogel's approximation, is that solution optimum or not. Okay, so let's do one thing. This is the where we're having the allocation. Can you quickly repeat that allocation where we're having, I think where we're having allocation over here 11 or Kantha 4, 12. 4, 12. I think there was 6. Okay. It was 3 and it was 7. Yes. This was the allocation that we have obtained by using Vogel's approximation. Now I need to check whether the solution that I got is an optimum solution or not. So for that I will be using the UV method. What is UV method? You have to let me draw a 4 by 3 matrix. 1, 2, 3, 4, 1, 2 and 3. This is U1, U2, U3, V1, V2, V3 and V4. So what I do, wherever allocation is being done, I'll be writing the cost value of that cell. 13, 23, 18, 17, 27 and 18. Okay, then what I'll be doing, I'll be writing the expression as U1 plus V4 is equal to 13, U2 plus V1 is equal to 17, U2 plus V2 is equal to 18, U2 plus V4 is equal to 23, U3 plus V2 is equal to 27 and U3 plus V3 is equal to 18. So we have written all the set of values of U and V. Now you can apply for all the methods. You can apply for all the methods. It's not because Vogel's is giving me more closer to optimum value. So it's better you can directly use Vogel's. If you know Vogel's is more closer to optimization, so I'll be using Vogel's, then I'll be using optimality check, because other methods, they won't be giving me optimize, then I have to go for reallocation. है ना? So better what we can do is you can calculate by using Vogel's approximation, then you can check the optimality test. Now here I can say V1 equal to 0. That is the assumption that we'll be doing. If V1 equal to 0, U2 is equal to 17. If U2 is equal to 17, V2 is equal to 1. If V2 is equal to 1, U3 is equal to 26. Right? If U2 is equal to 17, V4 is equal to 3 plus 3, 6. है ना? We calculated U3, V3. U3 is equal to 26, V3 is equal to minus 8. Okay, so I think all the 6 values, 1, 2, 3, 4, 7 values, 1, 2, 3, 4, 5, 6, 1 value is left out. U1, U1 ही बच गया. U1 we can calculate it as V4 is 6, so U1 will be equal to 7. है ना? Yes, we have calculated all the set of values. We can check U1, U2, U3, V1, V2, V3 and V4. Okay? Yes. So after calculating all the U and V values, what I have to do is I have to again draw this matrix 1, 2, 3. In examination, if they're asking, they will be asking you 3 by 3 matrix ka. Isse upar they will be rarely asking. Write the values. U1 is 7, U2 is 17, U3 is 26, V1 is 0, V2 is 1, V3 is how much? Minus 8, and V4 is 6. So what we have to do is, you have to write U plus V value for the unallocated cell. Unallocated cells 1, 2 and 3, these all cells. 7 plus 0 is 7, 7 plus 8 is 7 plus 1 is 8, 7 minus 8 is minus 1, right? Unallocated cell, this is the unallocated cell, third one. 17 minus 8 is we can say 9. Okay, this one and this one. 26 plus 0 is 26 and 26 plus 6 is 32. Right? Okay, so we have calculated the matrix. Now the final matrix that we have to calculate is okay, so what we have to do is we have to subtract. This is basically the ZJ value. Remember ZJ value, these all are the ZJ values. Now we have to calculate the delta. Delta is nothing but CJ minus ZJ. What is CJ? CJ the cost value. So cost value is this 21 minus 7. What will be this? 21 minus 7, that will be 14. 16 minus 8. 8. 25 minus or minus 1. 26. 14 minus 9. That is 5. 32 minus 26. 6. And the last one, 41 minus 32. That is coming out to be 9. So here if you see, these are delta values and these are non-basic variable because allocations is being done. Allocation इन्हीं पे हुआ है ना. These are basic variables. These are basic variables. These are non-basic variables. Unallocated cell. So I am getting the non-basic variable delta value positive. Is this a optimized value for a minimization problem? I'm getting non-basic variable to be positive, and I'm talking about the minimization problem. So is this a optimized value or not? Tell me. Use the same concept that we have used in our simplex method. If delta value for non-basic variable, we are getting all values to be positive, and I'm talking about minimization because this is I'm talking about the cost. And the cost should be minimum. So if we are talking about minimization problem, so can we say the logic that we have studied in simplex method, same logic is being repeated over here? Yes, this is an optimized value. This is my optimized solution. So the whatever allocations that we have did is perfect. That means now if you try to calculate the answer, whatever answer you're getting, that is the minimum cost. That is 13 into 11 plus 17 into 6 plus 18 into 3 plus 23 into 4 plus 27 into 7 plus 18 into 12. Okay, so by this calculation, No, because tomorrow is your mock test. So let's try to presume our energy for tomorrow's mock test. Because tomorrow also we'll be having a lengthy session. 5 faculties, 20 questions each. So I think 20 questions more than sufficient to cover all the topics of industrial. That's the reason I'm not taking today any practice session. Okay, nahi aaj nahi hai, rest kariye, है ना? You can try to revise your previous concept because every day marathon session is going on. You want to have some self time. वो भी देना बहुत जरूरी है. Okay, so now we have seen that by using UV optimality test, we are able to identify whether the solution is optimal or not. Okay, so now let's move. Next 13 minutes may we have to complete 7. Very good. We have got one value 796. Okay, thank you, Sujesh. 796 is my final answer. And you try to visualize when we were discussing by using the the northwest method, I'm getting 1095. By using the Vogels approximation, I was getting 796. I've checked that whether my allocation is optimal or not by using this UV method, and by this I have seen that the solution is optimized. So final answer is how much? 796. Okay. Skipping stone, you want to do? Yes, we can do it right now. Skipping stone is actually an interesting one. Skipping stone is, let me rub this off. I'll be using this space. Skipping stone is what we do wherever there is unallocated cell. We try to allocate and check what will be the change in the objective function, whether increase or decrease. Let us suppose I'm talking about this particular cell. This is your unallocated cell X11. So if I allocate +1 over here, I need to make sure that if I'm taking this unallocated cell, all other 3 corner points should be allocated. Is this clear? Very important. If I'm taking this unallocated cell, all other 3 corner points should be allocated. I have to take a closed loop in that way, right? So if I'm doing +1 allocation, definitely in order to maintain that, I have to take a -1 allocation, +1 allocation, and -1 allocation, right? So if I try to have +1 allocation, that means your cost will be increased by +21. You are decreasing by 17 rupees, -17, increasing by 23, decreasing by 13. So tell me, is this value positive or negative? Is this value positive or negative? This is 4 plus 10, 14. It's a positive value. That means if I try to allocate 1 unit to this particular cell, it will increase the objective function. So is that my criteria? Is that my criteria? Right? It is not my criteria because I need to have the minimum value of the cost. So that means the allocation should not be done over here. Next, try to go with X12, this one. So if you try to so I'll be taking a closed loop like this, 1 allocation, 1 allocation, 1 allocation like this. So by this way, for each and every cell we'll be checking, and for all the unallocated cell, if I'm getting the positive value, that means my allocation is perfect. Okay, skipping stone method is this only. Understood? This is the skipping stone method. You have to calculate for individual unallocated cell X12, X13, then X23, X31, X34. Okay, and if you are getting positive value, that means whatever allocation I have done, it's perfect. If any cell, if it is having a negative, let us suppose you calculated this by using this one, you calculate this one is coming out negative. That means I have to do some reallocation over here because it is giving me more lesser value. Understood? Because our main objective is to get the least value. Cost should be as least as possible. Okay, fine. So this is your total discussion of the transportation model. So now let's go with the last segment of assignment. Okay, so kitna ghanta ho gaya? It's like 6.5 hours, nahi, 8.5 hours done. Right? Okay, so now we are entering to 10 hours. Ab to ho gaya, I think. Chaliye, assignment model. In assignment model, what we are doing is, we try to assign the job to a particular person. Let us suppose if I say there is a job 1, job 2, and job 3. And there's a person 1, person 2, and person 3. Right? And let's say person 1 is taking to complete job 1 is 2 minutes. This is 5 minutes. This is 7 minutes. This is 10 minutes, 6 minutes, 2 minutes, 3 minutes, 5 minutes, and 6 minutes. This is the completion time. That means person 1 is completing job 1 in 2 minutes. Person 1 completing job number 2 in 10 minutes. Person 2 completing job number 3 in 5 minutes. So this is the completion time. So I need to calculate what should be the combination or assignment or allocation of the person with the job, so that overall I'll be completing this project in a minimum time. So again, it's a minimization problem. But the best part is, in assignment model, we always deal with the square matrix. Yes? Can you tell me why? That is M is equal to N. Why we are always dealing with a square matrix in this? There's a reason for this. The reason is, if I try to allocate, let us suppose, job number 1 to person 1, I cannot allocate job number 1 to person 2 and 3. If I allocate job number 2 to person 3, so I cannot allocate to this. So if I'm allocating job number, this is the only option that is being left out. So now I can say person 1 will be doing job number 1, person 2 will be doing job number 3, person 3 will be doing job number 2. Okay, so this I'm allocating or assigning the jobs to the different person, and this is, we call it as the assignment model. Okay, this is, we call it as the assignment model. Last 7 minutes, 6:30 optimization we were taking. So I think last 7 minutes we will be trying to cover. But as a running here, we can take some tolerance also, right? So that means if you're having some resources and we're having some tasks, so we need to allocate the resources with some particular task, and this is, we call it as the assignment or allocation. So in assignment model, there is only one method that we have to use. That is your Hungarian method. Hungarian method. Okay, we have to use this Hungarian method. What is Hungarian method? It's very, very easy. That is, you have to first of all take in the row, take the least value, subtract from individual values in that particular row. So if the least value is 13, so if you try to subtract, we'll be having 2, 0, 1, 4. 15 minus 13, 2, 13 minus 13, 0, 14 minus 13 is 1, 17 minus 13 is 4. Least value is 11, so 11 minus 11 is 0, 12 minus 11 is 1, this is 4, this is 2, this is 10, this is 3, 2, 0, 1, 15 is the minimum value, 0, 2, 0, 1. This is, we call it as row minimization. Okay, we call it as row minimization, right? Or simply we can say your row operation. So once we are done with the row operation, then we have to go for the column operation. Now if you see in this column, 0 is the minimum value, so definitely we'll be having the same set of value. In this also 0, column number 2, 0 is the minimum value, same set of values, because 1 minus 0, 2 minus 0, 2 minus 0, same set of values. Here also 0, but here in column number 4, we are having the minimum value as row reduction or a column reduction. This is, we are talking about the column reduction. So 1 is the least value, so your updated value will be 2, 0, 1, 4. What's a gap there? Right? Sorry. Let's start with row number 1, column number 1, 2, 0, 3, 0, 2, 0, 3, 0, 0, 1, 2, 2, 1, 4, 0, 0. Now the minimum is 1, so 3, 1, 0, 0. So this is, we call it as net evaluation matrix. Okay, yeah, opportunity cost matrix. So now we have calculated the matrix. Now we have to do the allocations. How to do allocation? This is a very simple method. The method is, we call it as row scanning and column scanning. We start with row. So in row number 1, if you're having single 0, try to allocate and strike off the column. That means if I say I'm moving in row number 1, Am I having single zero? Yes. Try to allocate and strike off the column. Second row, single zero, try to allocate, strike off that column. Third row, 2 zeros, no allocation. Row number 4, 2 zeros, no allocation. Right? Chalo. Now we go with column wise. Column wise, 2 zeros, do not do any allocation. 2 zeros, no allocation. Now, single zero scanning is being done. Now we'll be going for double zero scanning. Now, when you try to go with row number 1, row number 3, the first zero, if I'm allocating, strike off this, and this is the allocation. So now if you try to see, there are 4 lines that is required to cover the zeros. 4 minimum line is required to cover all the zeros. So we can say here, number of lines is exactly equal to the size of matrix. Right? And that is equal to 4. And whenever this is happening, that if minimum number of lines to cover all the zeros, it is equal to size of the matrix, then we can say the solution is optimized. We'll be taking one problem where the solution is not optimized also. Okay? So that means our final answer will be, what is the allocation? This one, sorry, okay, this one, and this one. So the final value will be 13 plus 11 plus 10 plus 16. That's it. This is my final value. Okay, this is my final value. Let us take one more example. Let us take one more. And in this case also, we can have a balance or unbalance. How we can identify, if let us suppose I'm having a matrix like this. 1, 2, 4, 3, 2, 1. That's it. Let's say J1, J2, P1, P2, P3. So is this a balanced one? How we can identify assignment model? In assignment model, you have to always remember it should be a square matrix. As it is not a square matrix, so you have to add one dummy. So where you will be adding one dummy? You'll be adding one dummy in the row number 3, 0, 0, and 0. Okay? Is this clear? You can add one dummy and now you can calculate the final calculation. Okay? You have to convert into a square matrix. Right? Chalo. So let us take one more example. This one, yeah. Let us do the row, this one. Row reduction, then column reduction. If we try to do row reduction, minimum is 110, 0, 10, 20, 0, 25, 25, 0, 20, 40. Yes? Okay. Now let's go with the column reduction. So 0, 0, 0. Minimum is 10, 0, 15, 10. And this one is 0, 5, and 20. Right? So now if you try to do the allocation, go with row number 1. Go with row number 1. Am I having single zero? No. Skip it. Row number 2, I'm having single zero. We can say allocate and strike. Row number 3, no zero. Column number 2, single zero, allocate and strike it. So now if you try to see, I'm able to cover all zeros by using 2 lines. So whether this is number of lines is equal to 2. Size of matrix, it is equal to 3. So our solution is not optimized. This is not an optimized solution. Is this clear? So if it is not an optimized solution, what we have to do? We have to do some recalculation or reallocation. So whatever cell which is not being crossed, uncrossed cell, we have to identify the minimum value. So whatever be the minimum value, you have to subtract that value for the uncrossed cell, and where we are having the intersection, we'll be adding this. That means here we're having 5 as a minimum. So at the intersection, we'll be adding that. So this is 5, and where we're having the single lines, there will be won't be changing anything. It will be as same, will be placing. So 5, 0, 0. 0, 0. 5 minus 15 is 10. This is 0. This is 5 and again 15. Okay, now let's try to do the allocation and let's see whether we are having the optimization or not. First row, single 0, single 0, single 0. Yes. Strike this. Column number 1, single 0, strike this. Column number this, single 0, strike this. So now if you try to see, I have used 3 lines to get the we can say strike off all the zeros. So definitely 3 lines, and that is the size of the matrix. That is the size of matrix, right? So now we can, this is an optimized solution, right? If this is an optimized solution, so final allocation that we are getting is here, here, and here. So it will be 125 plus 120 plus 140. What's the value? 385. Perfect. 2 marks gate examination done. 2 marks gate problem. It's been done. Okay. So this basically, I think, completes our discussion of our marathon, Maha Marathon. Almost we have taken a maximum, let's say at least 90% we have covered. Okay, and there is a gate test series. Definitely now you can attend some questions from our full length mock test, and I hope so everyone is attempting the full length mock test also. It's very important, right? And at the end, it's very important that you need to subscribe to this channel, because more such videos will be coming in the next few days. So those who are not yet subscribed, do subscribe to this particular channel. Okay, and I hope so you all enjoyed, and if any problem still you are facing, you can connect with me on my Telegram channel, that is mechanical by Suraj Gopi. Either you can connect over here, this is a Telegram channel, or there's one more Telegram channel, that is Learn with Suraj. Okay, I hope so everyone has connected. If not connected, please do join, and you'll be getting the PDFs also for this session. Okay, fine. It won't be taking 5 minutes to complete probability. It's actually, we can say, perishable item. There we are using the cumulative method. Okay, Sujish, we are taking the calculation of the cumulative method, and there we are going for the calculation. Don't worry, I'll be taking one question from that tomorrow. Guaranteed one question from probability model. They'll be trying to understand, because without question won't be able to have the completion. Okay, so thank you guys for awesome response from everyone patiently listening to this particular. What is that ratio? It was actually, let me tell you, P upon, it was actually P upon P plus L. We call it as static inventory model. We call it as static inventory model. Okay, I'll be taking one question from this, no problem, right? Okay, so I hope so now you have understood and you have enjoyed this session, and please do not forget to like this session, and yaar apne doston ko please do share this video, so that whoever is our mechanical, because I want our mechanical students to be promoted as much as possible. Okay, so energy में कोई कमी रही हो तो यार please बताइएगा, and I hope so energy is maintained till the end. It's 6:35, so 8.5 घंटे है ना? Okay, चलो, thank you guys, bye bye, take care, stay safe, and please be forward. Tomorrow we are having the we can say mock test. Please do join without any doubt. All the faculties, no previous year question, at least I can guarantee from my side. Okay, fine. So no previous year question will be done from industrial. Okay, so thank you, and I hope so you all enjoyed. So thank you guys. एक बार please do tell me मजा आया in the comment section. Please do tell me in the comment section. Do you like this session? Yes. If you like, तो यार please do share. बनता है. Yes, no problem. In heat transfer, maybe me and Chandra sir both will be coming. Okay, me and Chandra sir both will be coming. 2 faculties, heat transfer will be covered in that particular time. Okay, so thank you. Bye bye. Good, not good night. Good evening, because this is the starting of the evening. We're having a lot more still left out. Okay, thank you. Bye bye. Stay safe and please do not forget to share, subscribe, like तो यार आपने कर ही दिया होगा, नहीं किया तो please जाते जाते please do like the session. Okay, thank you. Bye bye. Thank you.